Good morning, IoT Builders. Thank you for joining us for day 2. And today I'm joined by our lovely Richard Berry, the founder of FreeRTOS. Few words, Richard, before we start?
Yeah, well, thanks for inviting me in again. I was interviewed yesterday.
Yeah.
And yes, it's start of a new day. It's good to be here at the beginning of what you've got coming up today.
Exactly. So, because it's a live stream, that's why you could hear the announcements going off in the exhibition halls. So, please ignore that. So, let's talk about what we actually did yesterday, right? We welcomed you and did our first Embedded World live stream from here in Nuremberg. And we started off kicked off the live stream at 9:15 in the morning yesterday. So we started off first with Dave Prenzler, who was hosted by my colleague Richard Elberger. Dave is the general manager for AWS IoT device software. Then we had a second session, which was Richard Berry.
It was me, yes.
Yeah. You were Richard on that session?
Yeah, it was fun. That was with Richard as well. We were talking about the kind of link up between AWS and FreeRTOS and the kind of symbiotic relationship and all the good things that Amazon do with FreeRTOS that are then contributing back to the community for everybody to use. So it was fun.
Yeah, awesome. So you heard from Richard. It was an awesome presentation, awesome discussion. If you missed it, don't forget to go back and watch the session on the day 1 session. Then we actually had Richard Elberger, who's the head of IoT ecosystem services in AWS IoT service team, where the session was how developers can get started with AWS IoT device software on embedded Linux, right? And then we had a guest from Silicon Labs, where we talked about implementation of Silicon Labs with Amazon Sidewalk. If you missed that session, the details of the timelines of the session, you should be able to find it in day 1 video. and you can basically pick and watch the session based on the timeline. Then we actually had a session with Pedro Mendoza, who's one of my ex-colleague who used to be part of AWS, and now he's working for Semtech, where we talked about LoRaWAN, where we talked about location services, how you can basically use Semtech hardware of LoRaWAN, augmenting with location services of AWS IoT.
Did that link back to the sidewalk
Yeah,
discussion?
yeah, it did, and it was hosted by our producer here today, by Alina. And then we had a session with John Slomonki, who's a solution architect, and Rajesh Khanna, who's a principal product manager for AWS, where we talked about embedded developer approach to AWS IoT, Greengrass. If you missed the session where we talked about with Avnet, with Mike Powell, with the business development specialist, where we talked about how you can use Avnet products to cut your development time in half by connecting and using Avnet IoT Connect. And then the session which I had actually with my colleagues, where we actually dive deep into ExpressLink with Lucio and Liam, where we talked about how ExpressLink can bootstrap your journey to get started into the IoT world, and how we basically are providing you the pathway for your highly valuable resources, utilizing this hardware of ExpressLink to get connected your products and build a quick MVP, and then obviously take it to market. Any points you want to add there, Richard, with ExpressLink and FreeRTOS input?
Well, I'd say they did a couple of talks yesterday
Yeah.
on it too as well. I'm very enthusiastic about the ExpressLink. So it's good. It's getting so much coverage. You gave yourself a lot to do yesterday here.
Yeah.
Yes.
Exactly. Yeah. So as Richard said, I mean the ExpressLink is basically do bootstrapping for you to get started into IoT world, and specifically connecting to AWS IoT.
Yeah. So there was one of my colleagues, Dan. He did a talk on the conference floor yesterday, which I think was recorded. So I'd recommend going and watching that. It's a great product.
Awesome. So you can basically catch up on the talk on Embedded World channel, where our colleague Dan actually did the discussion and talk on ExpressLink. Coming back to the recap section, where I actually had a discussion with Cloud 56 Cloud. I had a direct relation who's a co-founder of the company, where we talked about parsec security, augmenting that with Greengrass, how we basically can make it to make sure that it is actually incorporating and making secure for you. They do have some GitHub repositories where you can go and play with it to get started with their offerings. Then we actually had a discussion with IAR Chief Strategy Officer Hayden Powie, where we talked about embedded solutions for AWS using IAR. Then the second session we had after that at 2:20 was with Clickattack CTO Andrew Mazur, where we talked about using co-op enabled devices with AWS IoT. Moving on, we had Anand Gupta from Expressive and Anton, who's a partner solution architect, where we talked about Expressive Matter offering. So Matter is basically gaining a lot of traction here, and how basically you can use the Expressive Matter offering and its role in the cloud environment. So go ahead and watch that session if you missed it.
We've got a couple of Matter examples on the booth here, running on FreeRTOS, and there's also some other partners on the show floor that are doing the same. So it's good to see that been talking about it for so long, and now we can see it for real.
Exactly. So coming back for later half of the day, for day one session, we had Microchip, Ronnie Titoto, who's an embedded solutions engineer, where we talked about securing the IoT devices using Microchip secure element, and they talked about in details how you can basically use it to step-by-step integration to get going with that. And then I had a session after that with Intrinsic CTO and co-founder Gert. The session where Gert actually went in deep details in terms of how you can use Puff to make sure the credentials the device used to connect to cloud can become unclonable. So they actually use hashing within the device, within the silicon, to map and create the certificate on the fly. And the algorithm which they use is making sure that the mapping it always stays the same based on the silicon. If you actually had a situation, let's say the device had to restore and go back to its original state or factory reset, they will make sure as part of their algorithm the credentials are always created, new credentials, but based on the same hashing. And it was, yeah,
Sorry, I don't mean to interrupt you. Okay, remind me what PUF stands for? It's like physically unclonable.
That's correct. Function.
Hmm?
Physically unclonable function.
Function, right?
Yeah. So the algorithm which they provide was allowing you to make sure that you can actually deploy that into your ARM virtual hardware and test it. They provide libraries to incorporate it and test it. So if you missed that session, go ahead and watch that session. Then we had a FreeRTOS LTS session. I got joined by Lian. Unfortunately, Gil couldn't make it to the session due to some unforeseen circumstances. And where we talked about in details about FreeRTOS and FreeRTOS LTS offering. And I know FreeRTOS is very close to your heart, Richard, because you're the founder. So tell us a little bit about the LTS offering to our viewers.
Well, I think this is again another good example of where Amazon's investments into FreeRTOS benefit everybody. So for free, you can get 2 years of long-term support on most of the libraries. Most of the libraries required to create secure connectivity. And what does that mean? If you want to fix on a long-term support version, then if there are critical bug fixes or security fixes, then you can bring those in to make sure your product's kept up to date, but without having to bring in all the developments that have occurred on the main line since. If you bring in all of the developments, then it might be that you have to do a lot more testing and make sure that the performance of your product hasn't changed or whatever. So on top of that, so everyone gets 2 years for free. On top of that, there is the option also to have an additional 10 years. If you're working in industrial or automotive, something like that, where devices are out in the field for a very long time, that is a commercial offering, but you're providing 12 years worth of support in different versions. There's obviously a cost to us to that. So.
Awesome. So I have a customer, I think I mentioned it in the session yesterday, who actually adopted FreeRTOS. They went into production and they are avid user of FreeRTOS. And the CTO told me that, okay, by adopting LTS support, they were able to take out their developers or highly valuable resources and put it into customer improvement and customer feature enhancement of the product itself. So they don't have to worry about it in terms of security, in terms of patching, in terms of what are the upcoming things, because the LTS provides you that support. So if you don't know it, go ahead and check out FreeRTOS LTS support. As we just said, first 2 years free, but it gives you plenty of time to obviously go ahead and start using it. And also, it will give you peaceful sleep. So knowing that your products are safe, knowing that your products are secure based on the best security standards adopted by Amazon. Yeah.
I think coming back to the ExpressLink, that takes that even further. So the over-the-air updates, the secure storage of keys, all the integrations of all the libraries required, all that. As far as offloading from your main application and allowing you, to leverage all that testing that's been done already, and really just focus on adding value to your product as well. So we've got lots of options here.
Yeah, exactly.
Depending on whether you want maximum flexibility or whatever.
So there's a lot of variations. Obviously, because of shortage of time, we can't give you input in exactly what are the offerings there. But go ahead and watch the session. Go ahead and have a look at the website on the FreeRTOS LTS support. Some of the nuggets Richard has just dropped it here, such as OTA, security, and long-term support of the product through the libraries and so on. And then finally, coming back to the last session of the day, we had building IoT ExpressLink demo badge, part 1, where we had Joe Duliker, who's a SDE, software development engineer in AWS IoT service team, and Thomas who's basically a specialist solution architect. They basically created a workshop where they talked about how you can basically use this ExpressLink product, the demo badge, and use the workshop to build it and quickly get all connected to AWS IoT. And finally, the wrap up of the session was with my colleague Nenad, who basically went through the recap and talked about what we actually had in the session. And that's it, folks, for yesterday. Any closing words, Richard?
Yeah, well, I think you've done a fantastic job to squeeze all that in, and I look forward. I mean, I was busy yesterday, right?
Yeah.
So I look forward to watching some of that myself. It's interesting to me. There's kind of two categories there. There's some of my colleagues who are talking about our offerings, but there's also a kind of security focus there as well. You've got, I didn't write it down here, intrinsic ID, the microchip talk with the secure element, Hayden from IAR.
Yeah.
So I think this is so kind of ticking off these customer pain points as we go, and the offerings that people have, the partners that we have that can help you with security, making sure that your devices are secure in the field.
Exactly. Yeah.
Is great. So,
absolutely, as you rightfully said. So we are making sure that we are giving you a variety of flavors in our talks: security, developer experience, functional safety, cloud orchestration, and so on. So watch out where I talk about what you have in store for today. Thank you very much, Richard, for joining us for this morning. And thank you very much, viewers out there. And we'll be back shortly. Thank you. Good morning and welcome back. So, in this session, I'm going to talk about what we have in store for you today in this live stream. So, without further ado, let's start. We're going to have a first session with Jack, who's the CEO and founder of Percipio, and we're also going to have Mike in the session, joined by Alina, my colleague, where we're going to talk about observability in FreeRTOS applications with DevAlert and Tracealyzer. I'm certainly looking forward to it because it's one of those things where I would like to see and learn in terms of DevAlert and using the Tracealyzer to basically see how we can leverage that and keep it on top of the products we actually use and observe it, hence the observability. Um, Followed by the session, we have in open source software for connected vehicles, Ahmad Muley, who's a director at DXC Technology, and Jack Ogawa, who's a senior manager for IoT AWS, where we go in details how we are basically using open source software for these emerging products such as connected vehicles, right? Following that, we have a session FreeRTOS for industrial automation with OPC UA FX. In that session, we have my colleague Adrian, who's a partner development specialist, joined him by Stefan Schwinger, who's a group product manager for BNR Industrial Automation. In this, we talk about industrial automation using OPC UA FX in detail. Then we have a session where we talk about embedded device CI/CD, virtual hardware, and device advisor. Here we are going to be joined by my colleague David Walters, who's a partner solution architect, and Elham Hairpush, who's a senior solution engineer at ARM. I'm definitely looking forward to the session because I have been using ARM virtual hardware. I love it. It basically gets you bootstrapped and get started quickly to start using the ARM virtual hardware, build the product, and basically connect to AWS IoT. It's pretty awesome. Do join the session. If you have any questions, obviously you can ask that questions. Then we will have a session with Leon Granat, who is a CTO, and where we're going to talk about embedded runtime security, continuous monitoring, and threat detection with Sternum's FreeRTOS-based evaluation kit. Following that session, we have your tag, Reliagate, AWS IoT gateway integration with AWS IoT Greengrass with zero touch provisioning. Great session where you basically want to learn about zero trust provisioning. In that session, we will join by our guest, Marco Carrer, who's a CTO of YourTech. And then we have the cloud native car with SOAFEE and Linaro. We'll be joined by my colleague. And then we have a guest on board here who is basically Andrea Gallo, who's a VP of Business Development, and Grant Likely, who's the CTO for Linaro. Great session if you want to basically get that an understanding of how to basically have the connected car connected to the cloud in SOAFEE and using Linaro. Then we're going to have a session where we talk about how to build an automotive grade Linux for AWS. This is the session in which we are joined by people from a Linux Foundation and AGL. We have Walt Miner, who's the AGL community manager, and Jan Simon Moller, who's the AGL release manager, where we talk about the usage of this product of AGL. Then we have OpenSynergy, how to develop automotive solution with hardware abstraction techniques, where we are joined by Ishak Trefes, who is actually a product manager for OpenSynergy here in Germany. Then the following session will be me, joined by True Loan, who's an application engineer at PHYTEC. PHYTEC, the session where we talk about in detail about security, rapid development, connecting industrial machines, cloud-connected machines, where we talk about using PHYTEC SOMs and how we basically can use SOM with connection with AWS IoT and AWS Cloud in general. Then we're going to have using Mender for embedded Linux system updates on AWS. This is where we will have Joseph Holzfire, head of developer relations for Mender.io. It's the session to watch out for because Joseph is really entertaining, and I'm looking forward to it because I've had many interactions with Joseph. If you are on embedded world over here session, then I will say go ahead and hop into his booth as well and have a chat with him in terms of Mender.io. And we have a session with AWS IoT device tester framework and IoT solutions. Here we're going to have Anton, who's a partner solution architect here at AWS. And joining him would be Joseph Zaluka from Head of Business Development. This is where they talk about in complete details in terms of how they can use embedded system. They will go into details about using maybe Yocto, where we're basically going into how to use the build system for embedded system and basically connecting that to AWS. Then it will be me joining you back here. I have Andrew Longhurst joining me, who's the managing director of Oreston, where we talk about functional safety. You might have seen some of my functional safety series of videos on our IoT Builders channel. In this session, we're going to go further in details and we're going to see what other functional safety products where his company are offering, and we will basically get our geeks on in functional safety. Final session, wrap up of the day, we're going to have Joe and Thomas joining us back again for ExpressLink demo for Badge, where they talk about ExpressLink, the product. This is a continuation series, part 1, part 2, and part 3. Being a day 2 is a part 2, and then we're going to be day 3, doing part 3 next tomorrow. So keep a lookout for it. Make sure you tune in. And if you have any questions, put into chat. We are obviously monitoring for your questions, and we will get back to you and basically make sure we ask these questions for our guests. So stay tuned for these exciting sessions. And with that, I'm going to wrap up and watch out for the next session.
Hi, good morning, IoT Builders. We are here live from Embedded World 2023 from Nürnberg. And it's a really exciting day too in our live stream. And I am here with Johan and Mike from Percepio. Good morning, both.
Good morning.
How are you doing? How are you enjoying the show?
Great. Thanks for having us.
Show's been good.
Very nice. Well, thank you for joining us. And today in this session, we are going to be speaking about observability in embedded systems. So, Johan, Mike, can you introduce yourselves briefly?
Yeah, so I'm Johan Kraft. I'm the CTO of Percepio, also engineering manager, founder, do a bit of everything. I have a background in software development for industrial robotics, also applied research, did a PhD. But for the last 13 years, I've been focusing on observability for IoT and edge and embedded systems.
And I'm Mike Skurdik, and I'm an old assembly language programmer that got seduced by the dark side, and I'm running sales and marketing at Percepio.
Right. Well, thank you very much for the introduction. So now let's talk about observability. So what do you mean by observability and why is it important? And also what does Percepio offer in this space?
Sure. So observability is about how you can infer or understand the inner workings of a system from its outputs. And that's really useful and important when you're doing debugging, optimization, profiling, and also monitoring deployed systems for anomalies. And limited observability is often a bottleneck when doing RTOS-based development. You can get a crash or something, and you have no clue what will happen. It could also be about performance issues where your system is running slow and you don't really understand why. You try to optimize it, but it doesn't help. You need to know what the real bottlenecks are. And things like that can be quite hard to see in the source code. You need more detailed information from runtime to understand what's going on. And that's what observability is all about, really, and what we are trying to achieve with Tracealyzer and DevAlert.
Okay. Well, you mentioned Tracealyzer and DevAlert, and we're going to speak about both of them. So, first of all, what is Tracealyzer, Mike?
Yeah, Tracealyzer is basically a set of tools that sits on top of an RTOS, like FreeRTOS or Linux, and basically what it allows you to do is to see what's happening with all of the runtime interactions that's going on while you're running your program or your application. So I mean, if you think about a normal source code debugger, you can see what's happening row by row. But when you're actually running with an RTOS, you get lots of asynchronous actions, and there's no way with a source code analyzer to basically see how these things interact with each other and what happens when they don't interact correctly or they take too long or something like that. And so Tracealyzer is a tool set that allows you to actually see these and zoom in and zoom out and visually understand what's going on in your program.
Okay, that's very interesting. I think we've got probably a lot of embedded developers watching us today. So for those developers, could you tell us a bit about the developer experience? Like, how does it look like with Tracealyzer?
Mm-hmm. So the first thing you will notice is that you get a large set of graphical views from many different perspectives where you can analyze your trace runtime data. And you can spot anomalies in high-level overviews, like in CPU load or memory usage, timing latencies, and then drill down into the details to see why that happened. So you get kind of a comprehensive timeline where you can see your FreeRTOS task scheduling, RTOS API calls, CPU load, stack heap memory usage, much more things like that. And on top of that, you can also add custom observability into your application and see important variables, state machines, and specific timing metrics.
Okay, so this is very nice. So what kind of issues do you really spot with Tracealyzer?
I would say there are four main types. when many people think of tracing, they think about real-time analysis, deadlines, things like that. And of course, that's an important use case. If you have a real-time system with important timing requirements, you can use Tracealyzer to verify them. We have a lot of support for things like that. But we also have more general profiling and optimization use cases. I mean, is the code reasonably efficient? What parts could make sense to optimize? For example, one of our customers found that they were spending like 20% of their processor time just on a small loop that were polling a keypad. And they had no idea, and they could speed up their application quite a lot by fixing that, by having interrupts instead. Another use case is software design analysis. I mean, observability lets you ensure that best practices are followed. I mean, you know that your own code is perfect, right? But what about the other code from your colleagues and also suppliers and other open source projects? Are they working together in a nice way? Are they playing nice? And is the system execution really stable and deterministic, or is it perhaps more chaotic? And that is really important for testability and the overall reliability of the system. Finally, you have the debugging use cases. When you notice a problem and you don't really know where to begin your debugging, Tracealyzer can show you what happened or at least point you in the right direction so you can do a more focused debugging session. But where Tracealyzer really shines is the more complex issues that are difficult to reproduce. For instance, when you have issues in the field, when you have a Tracealyzer trace, you can understand the problem and hopefully provide a solution on the same day. But without observability, you might be looking at weeks of guesswork to figure it out.
Okay, so Tracealyzer is running on the local machine of the developers, right? Okay, I see, got it. Okay, so this is really interesting. You mentioned another product at the beginning, and that was DevAlert. Can you tell us what DevAlert is?
DevAlert's a monitoring system for not just development, but for testing and deployment. So you have an agent that reports issues back to your user. So basically, what you're doing is you're triggering issues in the field that are unexpected or have error conditions, and you send it up to the cloud. You report it to a development team, and then they can fix it and perform an over-the-air update and get back to you. So it's basically a reporting framework. Yeah.
Okay, I see. So it closes the feedback loop.
It
Right.
closes the feedback.
Mm-hmm. From the moment you get the bug, actually fixing it and getting it deployed.
Instead of waiting for the traditional way is sort of customer support, and that takes a while for the issue to propagate back to development, and the information that you get is very helpful. Sort of like it doesn't work instead of a trace or some debug data that goes with it.
Yeah. Okay, so this means that developers can use DevAlert and Tracealyzer together, right? So how would that work to get observability in FreeRTOS applications with both of them together?
Yeah, right. Well, DevAlert is nowadays it's larger than just Tracealyzer, but the way they relate is that DevAlert can collect traces and provide them to Tracealyzer, so you can analyze what happened in the field. And so, I mean, whenever something bad or weird happens in your code, you can report that with DevAlert, and it goes up to the DevAlert service. And when you get the trace into Tracealyzer from DevAlert, you get the timeline of events leading up to the anomaly. And not only like FreeRTOS tasks and API calls, but also any data you choose to log in your application. So, I mean, this can explain the problem right away, or at least it can point you in the right direction and help you to reproduce the problem in the lab.
Mm-hmm. Okay, so on a more technical level, for all the technical people watching us, how does DevAlert work?
Okay. Well, it starts when the issue is first detected in the device. You might have some assert statement that fails or a hard fault exception that kicks in. So the error handling code have been extended to use DevAlert, and a diagnostic packet is created basically that is with the DevAlert client, a C library that we provide as open source under the Apache 2.0 license. And this diagnostic data can be either stored on the device and uploaded or downloaded afterwards, or it can be uploaded using AWS IoT Core over MQTT, for instance, to an S3 bucket. And that's on the customer side. So DevAlert client doesn't talk with Perceptive stuff directly, but it goes through the device backend in our customer's AWS account. And the diagnostic data like Tracealyzer traces and crash dumps stay at the customer side at all times. So the developers can provide their own storage and feel confident that they have full control of that. Some metadata about the alerts are sent to our DevAlert service. This is classified using some fingerprinting information and stored in a database to provide a fleet level overview. We have a dashboard where you get kind of a to-do list based on an aggregation of this data, the database, where all repetitions have been grouped. So you don't need to wade through all the individual occurrences, but you can see a number of particular issues you need to look into with all the occurrences that then become kind of examples of this issue. And from this dashboard, you can also access the diagnostic data just by clicking a link. And that might not sound very amazing, but the thing is that the data isn't stored with us. It's stored on the customer side, but it's still easily available within the DevAlert dashboard. And this works by, we have a desktop tool that is registered as a protocol handler in the user's web browser. So when they click the link, they're actually triggering a desktop tool on their side that has been configured to fetch the data in any way they like, and also to launch a desktop tool for viewing the data. It could be Tracealyzer for traces, or it could be a GDB server or debugger for a crash dump, for instance. So this way, developers can keep sensitive data like crash dumps, health files and stuff on their side while having complete control and at the same time having the convenience of a hosted service and integration with familiar desktop tools like GDB and Tracealyzer.
Okay. All right, that's very interesting. So you mentioned that there is a DevAlert client. Does that run on the devices?
Right, yeah.
Okay, that's really interesting. So developers can already have a look at that because it's open source. From my understanding, it's a C library. Very good. All right. So what I did see as well is that there is a sandbox for DevAlert.
Right.
So Mike, can you tell us more?
Yeah, the DevAlert sandbox is basically a complete development environment with a DevAlert example running on a virtual board. So it's running on some virtual hardware. You download it and it runs via AppStream, and you can basically, as I said, it's a complete application complete with bugs, if you will. And so basically, there's a whole set of training videos and analysis blogs that comes with the package. And basically, you can go in and you can look at the code and see the alerts going up to the cloud and everything, and then analyze, what actually happened. You can see it in the code, and you can see the effects of it, and then you can actually modify the code and recompile it. So it's a complete development environment for DevAlert, for DevAlert, and
it's like a virtual example device for DevAlert that feeds example data into the solution.
Okay, and then from there, developers can put their own application or modify the application. Very good. So then people can get started and learn about DevAlert and about Tracealyzer, and then move on to more production-ready solutions. Very nice.
It's a good way to learn how DevAlert and Tracealyzer work together, as well as get you some experience with thinking about the cloud as a debugging solution.
Yeah, that's very nice, especially because we've got a lot of embedded engineers not being familiar with the cloud and vice versa as well. So when it comes to debugging and observability tools, it's really good practice. Okay, so now because we are at Embedded World 2023 and everybody's talking about what's new, So what are the new features for Tracealyzer and DevAlert? What has been new? What's been recently released? What's coming up? If you can tell us.
So on the Tracealyzer side, we made a big update like 2 weeks ago, Tracealyzer 4.7. And this is a major feature update with a couple of things. We have improved automotive support for specific automotive profiling. We've added support for something called runnables, which is a common concept in automotive, but it can also be used on other software, basically for tracing a particular part of the code. So more detailed profiling capabilities, and also made logging more efficient by having support for it. We can get data from ELF files, so we don't need to push as much data through the tracing. And then over the last months, we have also been working on an updated version of DevAlert. This is live now since February, I believe. We haven't announced it yet, really, so this is basically the start of the marketing for that. But I mentioned already that DevAlert is not only about Tracealyzer traces anymore. That was the case earlier, but now we have generalized the solution, so we can support providing multiple payloads of any type. It could be a Tracealyzer trace together with a GDB crash log, together with an existing application log that is provided in a single alert. So that way we can get more detailed diagnostic data, and it's also more flexible for the customer. They can integrate their own data and also their own desktop tools.
I think it might be impolitic to mention it, but Tracealyzer in the 4.7 release also has support for bare metal tracing.
Right, so it's an RTOS independent solution that can be used on top of RTOSes, or with RTOSes we don't yet support.
Wow, it's really nice.
As I said, it might be impolitic to mention it, but
Yeah, right.
So just out of my curiosity, you mentioned state machines. Can you talk a bit, just briefly, of what kind of support for state machines is there?
Right. So with Tracealyzer, as I mentioned before, you get kind of RTOS level data like task scheduling and API calls. They are traced automatically, basically. You hook in our header file, and we populate the FreeRTOS trace macros to catch things like that. But you can also add your own custom observability, and that could, for instance, be on a state machine. So then you would log the state transitions, and the Tracealyzer understands these events are for a state machine and shows you this like a logic analyzer in the views. So you can see the states all the time, and you can also get this aggregated state diagram showing the transitions, a trace state graph. Before, you had to configure Tracealyzer on the host side manually to do that. You would use generic events to log the state transitions, and then on the host side, you would map that to a state machine definition. But in 4.7, we've added support for state machines and also what we call custom intervals, which is a similar thing. Added that in the Tracealyzer target library. So you can actually define your state machines or the tracing of your state machines completely on the target side. So when you open the trace, they are there immediately. You don't need to configure anything.
That's really great. Thanks for that. So what about the next steps for developers? So how can developers get started? What do they have to do? How easy is it?
Yeah, basically, the best place to start is Percepio.com. On our website, we've got a whole bunch of instructional videos, blogs. We have a series called Tracealyzer Hands-On, where we take a look at specific issues that you can find with Tracealyzer and show users how to use the tool to focus on a specific issue. And then DevAlert, you can download the DevAlert sandbox from Percepio.com. So that's really the place to get started.
Okay, all right, thank you very much. It was a really great talk about observability in embedded systems. Do you have any last words?
Ooh, didn't think of that. Well, I could add that DevAlert is not only for cloud-connected systems. You can start by having actually a local setup if you just want to play around with this. And I mean, all we need is basically a way to move a piece of data from the target device to a desktop, and then it can be forwarded to the cloud, or you can upload it directly. So there are many ways to configure this. You can do a lot of kind of custom plumbing with this. It's a rather flexible system, and I would really encourage you to look into DevAlert Sandbox, where I think we have 5 or 6 different videos there showing both this high-level marketing pitch and some more concrete hands-on examples of how to use this and how to analyze a trace from DevAlert.
Okay, thank you very much. So percepio.com is the website to go to if you want to learn more about Tracealyzer and DevAlert. Thank you, Johan. Thank you, Mike. IoT Builders, stay tuned. We're going to be back after the break with more sessions around observability and CI/CD and so on.
Hello and welcome back to the Embedded World. I'm Nenad and I'm here joined with Amod. Maybe you can introduce yourself.
Yep. Hi, my name is Amod. I work with Luxoft. I'm part of the R&D team. I'm actually leading the R&D team, and we're actually working a lot with AWS within my teams to look at new technologies and how we can bring technology world to the cloud world to the vehicle world. Other than that, I'm also responsible for connected services, which are of course related to vehicles or automotive area, and we're trying to figure out how all these new changes can be brought down, where consumers can use it and OEMs can also benefit from it.
Excellent. This is a really interesting topic, as we talked. I mean, it's kind of evolving as of now, and there is quite a lot of opportunity to kind of set the standards and showcase what other people are doing and kind of build in public rather than what we had previously, like each company developing their own solution and so forth. So maybe you can talk about this. I heard that Luxoft and AWS are releasing this kind of blueprints for software-defined vehicles. So maybe you can talk about what's happening there, like why this is happening.
Yeah, so basically at heart we are an engineering services company, right? So which means our goal at the end of the day is to bring value to whichever customer we are working right now. So our goal is not to create products. So that kind of fits into the entire concept of creating blueprints and making them available. And what helps is we bring a lot of domain knowledge. In the past, we've worked with different OEMs, with different tier 1 suppliers, and built a lot of knowledge within the company. And now as the world moves towards the SDV, or everybody jumps onto the SDV bandwagon, we have to figure out how these old world technologies, everything that's new, how can we get this together? We can go two ways, right? In the past, it was all about having a closed environment.
Yes.
Everybody was keeping their IPs to themselves and locking in OEMs, for example. But now that is changing. As we bring the cloud to the vehicle, we try to bring as much as our knowledge into that topic, bring out these reference architectures which enable smaller companies, for example, to also contribute. They have great ideas, they just don't have the budgets, right? So they can come into it, and at the end of the day, as more and more OEMs, more and more solution providers jump onto the bandwagon, use these blueprints, we get more business because we are also then part of that journey. And at the end of the day, they also consume a lot of cloud resources, which is a win-win for AWS and also us.
Yeah, exactly. It's a win-win for everybody, as you said, like working in public. But coming to this, like just in this show, I had 3 or 4 companies approaching me yesterday. There are startups. They are building self-driving vehicles, semi-self-driving vans, and all that kind of stuff. Which without this technology, what you mentioned, like open source and so forth, they couldn't do this. So.
Exactly, because all of these companies would then have to invent or
reinvent what is already
invest in doing the same things over and over again.
Yes.
Which, if it's available, it can be reused, extended, even made more efficient.
Exactly. Yes. No, I really like this concept, and I think I heard also that this is you guys using SOAFEE as kind of to release these blueprints. So why? First of all, what is SOAFEE, and then why you choose to go with that?
Yeah, basically, for us, SOAFEE is a great platform because first of all, it is bringing the cloud to the vehicle, and it's creating a framework and the processes, and also bringing the community together so that we can all contribute to the SDV cause.
Yes.
Right? And as stated earlier, right? So at the end of the day, the more people that are on board, the more we can extend, the more we can enhance those blueprints, and also the frameworks that are around developing these blueprints, right? As I mentioned, we are not a product company, which means once we are done with the project, we move out, we do the next thing. So these blueprints can be taken over, but they will not be developed every time and enhanced. So if you are in a consortium like SOAFEE, where there are a lot of stakeholders who are trying to do the same thing, if these are available to them, then that also helps us to not just streamline, but also to make some standardizations as to how things should be used. And we could end up in a totally different blueprint later, but this is a start.
Yeah, so I see this point. This is pretty cool. So basically, you are kind of putting this open for discussion for the SOAFEE community members to kind of discuss and even drive in different direction. But again, you as a main contributor, you are the expertise. You have the expertise in house to kind of like take this further to even the customers who do not have those expertise and even develop it further for them. So
I also see it from the other side,
Mhm.
from our developers, our colleagues,
Mhm.
our engineers, who also get a chance to contribute
Yes.
into a greater
yeah,
movement and
I
not
like this.
simply go from customer to customer.
yeah,
It's a
that's-
motivation from them for them to.
yeah. And then, so what? I mean, you mentioned this, but like, what does then makes Luxoft unique as a software supplier?
So it's simple, the domain knowledge, right? So you can have all the cloud technologies and everything you can get uh, into the vehicle or make it available through the infrastructure connectivity. But if you don't know how a vehicle works or what are the intricacies of making or manufacturing or building a vehicle, all these technologies basically just are tools. It's like using a hammer to hit
Yes.
at everything where you need some finesse. You need to know exactly what tool to use when. And so basically, what we bring is the knowledge that is for in-vehicle, but also with all the projects and different fields, the domains that we are in, we also bring the cloud knowledge. So the marrying the edge, the cloud, and making a solution which is end-to-end and having some kind of consistency.
Excellent. No, we did talk to this about in a different podcast as well. It's like you guys you have the expertise to build out the infrastructure that is spread across the vehicle and the cloud that allows other developers to build, their applications, their business logic, whatever they need on top of this, and kind of speed out that development so they can focus on like what they are doing best, right?
Okay, so I mean, if you look at what we have done, we as part of DHC, we have also managed data centers. But as Luxoft traditionally has also created incredible in-vehicle entertainment systems. Many vehicles that you drive around today probably has Luxoft
Yes.
code in it. So we've been there, we've been behind the scenes,
Yes.
and we know how stuff can be built. And now we are trying to make it open source or make it available to a wider community so that we can grow faster in this direction.
That's pretty cool. That's pretty cool. And so coming back to this, like, how does a software-defined vehicle differ from the automotive IoT edge application in general? What are your thoughts on this?
Yeah. But first, maybe we need to define or understand what
Yes.
software defined.
Yeah, what it is.
Right? So,
I've heard
because-
many definitions.
I mean, it's something that's there right now that's everybody is talking about.
Yes.
But I personally feel nobody has come down to like this is the definition. This is exactly what it means, and you will not deviate left or
Yes.
right. So here is my take on it. Right? So basically, as we all know, so a software-defined vehicle basically is bringing the vehicle features to the end consumer via software and not bound to a specific hardware. So now, as I said, my take on this is we will move more in the direction of software-defined vehicles the more we are abstracted from the hardware, which means
Yes.
when the hardware becomes a platform where you deploy your software on and then make it available as features of the vehicle, that is where you will start going into the direction of being software defined. So the maturity of your vehicle or can be, I'm 50% software defined, let's say. I don't know how you could say that, but you could potentially look at how many features are bound to a piece of hardware or
I see your
PCU
point. That's pretty
versus
cool.
what is replaceable software.
Yeah, I like this definition. Yeah.
And then again, if you, as you asked, if you move from software defined to edge applications, they run on the vehicle, sure, but they are in two different environments. SDV as a whole actually comes from the manufacturer himself, so it's a trusted environment. It's a trusted piece of code that runs, which is tested, which has gone through security, safety, all the regulations that you have.
Yes.
I mean, you still have to follow regulations, right? Just because I am software, I'm not allowed to just drive a vehicle
Yes.
around without all the critical safety regulations. Because at the end of the day, it's lives that are
Exactly.
at question here. So, and when it comes to edge applications, they are basically deployed in a namespace which is external, which can be developed by many service providers. Let's say, for
Got it.
example, the project that we did together, right? So the usage-based insurances, for example. So you have an application which is consuming data, which is generated in the vehicle, and processing it, probably doing some level of edge processing, and sending it back to the cloud to do further analysis,
Yes.
whatever needs to be done. It does not, in any case, and should not affect the behavior of the vehicle. It does
Yeah.
not change the
I see.
characteristics of the vehicle,
I see.
and that's a clear difference. SDV changes characteristics, defines characteristics, edge applications consume that information and enable bringing the cloud into the vehicle and do the processing, a bit of edge processing, so to reduce the data that is sent in the back end.
I see. That's a really good segregation. Yeah. And I mean, I remember this while back. I was also like in part of the automotive industry, so I remember like the iteration cycles. You had like mechanical engineering, and then once you like start working on a car, the iteration cycle when you need to change something is like measured in many years, right?
Months, half a year.
Many years, right? And then you have like electrical engineering, like with all the wiring and software, and then their iterations are like quite high as well. And then you start going into this like software, and then there is one part of the software which is like board support packages, like system, software as well, which is the iteration cycles are measured in like months. And then you come to the application layers, which are basically measured, like the iteration cycles are measured in weeks. And if you are now able, what we're saying is that if you're able to have the majority like for those developers who have the shorter iteration cycles, that means that for the end customer, you can bring new features, like battery optimization, whatever, now much faster, right? So that's what we're saying, like with this SDVs, like if you have more of those things that you can change by software deployment, that's basically where the SDV starts, right?
Yeah,
I really like the definition.
I couldn't put it better than you already did.
That's pretty cool. I really like it.
Over there updates and all these things are then part of this bigger SDV topic that we are talking about. Because right now you have over there updates, right? But then still, as you said, you have to look at the cycle. I get updates for my car once in a year, or sometimes even once in two years. So I have my car for 5 years, and I've had 2 updates till now. And it's not that, and because there is a problem, there's a battery management issue, you get a problem. There is no feature addition. There is nothing new that you can provide.
This is security patches and whatever not, right?
And this is where, I hate the analogy of a phone, because that is not a phone.
No, definitely.
If you buy a phone, if you buy an Android phone, if you buy an iPhone, you get OS updates. You get newer apps. You get new features. In Android, for example, if you have bought a phone 2 years ago, you will still get the latest camera functionality of removing objects. That's something that you don't see in vehicles, and that is something that eventually will come. That will be a differentiator if I choose to buy a particular brand or not. So
exactly. I would rather choose some, to buy a car that can, give me new features and kind of surprise me with new things, and I can advance it further, rather than the car that's like not able to do that. So as a customer, right?
Absolutely, and that's what appealed for the likes of Tesla, right? So you have the techies or people who are more technically oriented, let's call it that way. They were like the first people who grabbed onto that idea, because they always got new software, they got new features. There will also be a set of customers who don't want that.
Yes.
But having that functionality in your vehicle is much better than not having it, because there is a small subset of people who don't want it.
Yeah. And maybe that subset of people will grow and so forth. So
eventually.
That's excellent. So I know you guys also have like a booth here. Maybe you can just briefly tell me about like what's happening here.
Sure. This is another demonstration of how software-defined vehicle concept can be implemented. Right. This is actually in production, so it is used, but unfortunately, or I wouldn't call it unfortunately, it is not inside the vehicle, but it is on a dongle. It is connected to the OBD2 board. It's based on the NXP board.
We've seen those,
So basically, it is containerization work within the vehicle, but through the OBD2 dongle in this case. And what we're doing is interfacing with the vehicle signals, getting those signals into our applications which are running. and these applications are basically consuming data and making it available to the backend. Now, the
Is this
thing
using
is,
Fleetwise or?
in this case, we are not.
Okay.
But FleetWise is another example, right?
Mhm.
For a solution from AWS, where what you do is process the data at the edge, because you do not want to dump everything into
Yes,
the backend
it's
and
quite
then consume
expensive.
bandwidth and
It's quite
connectivity.
expensive.
So you basically do edge processing, and this is what we are basically doing here: processing the data, loads of data which is probably irrelevant. So doing intelligent data capture.
Yes.
We know what data is relevant in the vehicle itself, and just then sending the vehicle data back. And this particular company then is using this data to provide services to not just to customers, but
Mhm.
also to different service providers, which are then providing services to the customer. So
Nice.
they're like a middle company which is providing this data for further usage.
Yeah, I like this story. I remember when we were talking about in industrial environments, you have that kind of like predicting maintenance and whatever not. But like this is coming to the automotive industry as well. Like if you know that certain parts are tearing with certain, like you can interpret which parts are tearing based on those CAN messages that are flowing around, you can then, before some tearing happens, you can say to your customer, you know what, you should go service this vehicle. You were using your battery or whatever thing more than expected, even though you haven't passed the certain mileage as well. So
But that's exactly something that demo can also potentially do, right? Because it
That's
has as you say, it's a platform. You
Yes,
have something
that's cool.
running on it, and if you want that, you can have inference model, and
Yes.
SageMaker can through your IoT infrastructure just send it to the vehicle. It runs in the vehicle and makes its decision and
That's
sends
cool.
it back to the backend, right?
I
So
like this.
this kind of really demonstrates
Yes.
that it's not just made for that one use case. You can repurpose it to do
Excellent.
something different.
Is it using Greengrass?
Yes, it is.
Yeah, I see Greengrass and K3B, K3S. Yeah.
So that's the Kubernetes cluster,
Yes.
the baby version of it, let's say,
Yes.
which is meant for hardware constrained, resource
Yeah,
constrained
perfect.
environments, and we basically use both of them to achieve this particular use case. But there are various ways we could achieve this. This is by the way, this blueprint is accepted in SOAFEE now, so it's
Yes.
officially out.
Cool.
And if the viewers want it, you can simply have a look at it and develop your own cool little application on that.
Yes, we can paste this in the comments, Sophie. I think there was also like this write up about the architecture and as well and so forth, so we can also paste that for our viewers as well. This is excellent. I think we can talk about this for like hours as well. Anything else you wanted to add? I think we have a couple of minutes left for the session.
I mean, not specifically, but I'm personally I'm looking forward to how this develops, right? So I think we are at a inflection state where we don't know where it's going to go,
Yes.
and I think I am lucky enough to be in a position where I'm going to see this
Excellent.
happening. This happens more probably once in a few decades, right?
Yes.
So we went from purely mechanical vehicles to vehicles with small little computers, ECUs inside. And now we are going into the world of having high performance computers and having features which you never dreamed of having in a vehicle. And I think it's going to be an interesting ride.
Yes.
And
definitely.
I'm glad that AWS is some a partner in this, where we can actually do a lot of partnership and try to figure out how we best fit into the market.
Yeah, I mean, we always try to follow like what customers needs and what we talked about. Like at the end of the day, they want to be having new features and so forth. So we always kind of follow that, and we saw as well opportunity to contribute the best we can as well to this study. So, okay, excellent. Thanks a lot once again for coming here and talking about this topic. As I said, it's a pretty cool one. Yeah, and then that will be it for today's session. So,
Thank you.
thanks.
Hi, welcome back. My name is Dan Gross, and I'm a senior developer advocate here at AWS. And this session, we're going to talk about FreeRTOS for industrial automation with OPC UAFX. We're live here in Embedded World, and this is the AWS booth. You can't see it, but it's all around us. We've got demos and all kinds of things happening here. Very exciting. This session will detail the collaboration work with AWS and 7 leading industrial automation and semiconductor companies that are accelerating IT and OT convergence by enabling TSN and OPC UA for constrained devices with FreeRTOS. So joining me are Stefan and Adrian. Why don't you introduce yourselves? You want to go first, Adrian?
I'll go first. So I work with them at AWS. I'm a strategic partner manager in AWS IoT specifically, and I work a lot of the industry partners there. Lots of them here at this show. Stefan?
Well, first, thanks Dan, thanks Adrian for having me here today. And my name is Stefan Schönecker. I'm working in the industrial space since 2006. I'm at BNR, part of the ABB group, and I'm there running the PLC and controls business, including machine vision.
Fantastic. So glad you could join us today for this session. I'm excited to learn more about this because I don't know that much. So this is a learning experience for me. So when we talk about, industrial automation, connected factory, these kinds of terms, Industry 4.0, what does that all mean? What are we talking about with these terms? And maybe what are some of the differences when we hear these terms? Because I hear them thrown around a lot. And I understand it to some degree, but I don't know necessarily the subtleties of these terms. Maybe you could, help us understand.
Yeah, I think we need to curate it a little bit, right?
Yes, I think let's start first with the term Industry 4.0.
Yeah.
And looking here at the show, this is really it's an incredible place. Lots of people, lots of innovation, lots of great ideas. But one term you don't find at all. That's Industry 4.0. So now we could question: is that gone? Is that dead? No, it's not. The Industry 4.0 was created, I think it was close to 10 years ago, as something to make manufacturing, starting out of Europe, but it was picking up in other regions as well. How can we make manufacturing more, let's say, more digital, more competitive, more smart, more variable, higher flexibility? I think that's what it was all about.
Yeah, and maybe more data centric too,
that's
right?
what I just wanted to point out. And what do you need finally to get there? And then for sure, it really condensed a lot to data centric, data modeling, connectivity, security. So that were kind of the technical ingredients missing to enable the thoughts of Industry 4.0.
I see.
And why is it not used that term anymore? I would even say it was replaced by the more simple and more generic term IoT. IoT has its roots probably outside of the industrial space. IoT it comes from other places. I think maybe you want to comment where IoT comes from.
Yeah. Well, it depends which industries you ask. If you ask the telco providers, what used to be M2M, now it's IoT, right? So now we're going to factories. But I think one point here is the Industry 4.0 term has been misused, in my opinion, because you walk around here and you're going to find Industry 4.0 solutions, and they're just bolt-on. You just slap something there, and then all of a sudden you make that equipment that's not very smart. But I think it's not the right way, because the factories have not been built secure. They've not been built to be connected. So the underneath layers are not secure. So that's the fundamental problem, right? That needs to be solved.
True. There's a lot of history in this also. If you look on how factories have been built in the last 100 years, it's a very layered architecture. And layers, I talk about sensors and actuators. That's really the analog world of sensing temperature, vibration, driving a motor. But this layer, and this is really, finally, if you look at it from today, where the data is actually generated, this is where the value is. But that layer was completely, let's say, unlocked and decoupled from the layer where maybe there was some intelligence already for decades, like the data centers. And then there were layers in between called the control layer with PLCs, the HMI layer, the SCADA layer, and each layer had its own role, its own function, while they were relying on each other but not collaborating. And then it's why did that not take place? Well, if there is no security, connecting devices is also a challenge.
Right.
And if then there is
Right.
no intelligence, no digitalization, no compute power on sensors and actuators, then again, how can you in a good way transfer data? So it's kind of really
How-
something that had to break up.
How do you get the raw data, right? So basically, the raw data is missing up on the information level. So bring it up to me. When I look at the Industry 4.0, I think it's very simple. There are several problems. So you need interoperability.
Yeah.
There are too many vendors, too many protocols. They don't interoperate. So you have to go horizontal, make them to talk to each other.
Yeah.
And that would be the TSN, time-sensitive networking that we're talking now. But
Okay.
there is also a vertical one. The information that Stefan is talking about, it's zeros and ones. Nobody understands it. So to propagate that all the way up, you need to decode. You need to decode many protocols to put it there. So that's the other problem to solve. So you kind of have to talk the same language from the bottom to the top.
Yeah, this is interesting. I've never heard it quite described that way, where Industry 4.0 is essentially IoT, but I can see the parallels, right? Nobody buys Industry 4.0. Nobody buys IoT. But you implement the practices and the systems that are involved in that infrastructure. And so really it's all about getting the right infrastructure, right?
So connecting the factory, not a big problem. We have
Right.
many ways to connect.
Yeah.
But we need to democratize the data, make the data flow inside first,
Yeah.
and in a proper language, then it can be accessed. Then we
Okay.
have access.
And get the data from the, as you call it, the raw data, from the origin, the source of the data. That's the sensors, that's the actuators. That's actually where everything happens. And if, for example, a motor gets stuck and you want to indicate, you want to predict outages because the motor starts to have deviations or friction, hey, the motor was first. But what we did in the past was we communicated something because it was not digital to the PLC. The PLC made an assumption, tried to interpret and then forward the data. Then the next day, then the next day.
Yeah.
So modern analytics couldn't even take place because you base your analytics on wrong data, on manipulated data.
Right.
And if you want to do good predictions, you need really the raw data, and that's really generated at the sensors and actuators.
Okay, yeah, that's really cool. So, what if we're looking at the benefits of bringing Industry 4.0 into play? What's missing? And there's so many industrial protocols for automation. Where are the gaps essentially?
I think we have a state, or let's say we had one, because we are really on a good way to change, where probably telecom has been, I don't know, probably 20, 30 years ago, where you couldn't take a mobile phone, or even maybe didn't have one, go to another country and continue talking.
Oh, yeah.
Meanwhile, that problem is solved. And if you look from what you call it in the data center world, TCP/IP is out for decades, and no one questions anymore, can all the laptops, PCs, and Windows can talk with a Linux server? That problem has been solved.
Yeah.
It sounds ridiculous maybe to AWS or even other people out there.
Yeah.
But in the industrial
we've been doing it
space,
for a while now, but in the industrial,
I don't want to really, judge in a negative way on the history, because technically there have been constraints which didn't allow that, like real time, like safety. But that led to the fact that so many different protocols and signals have been invented, which finally, if you want to have the maximum usage of a system, you had to go on one vendor.
Yeah.
And that's what people call the vendor lock-in. And that's really neither helping competition or helping to be competitive, but also not helping to really add value, while different companies get together with different competencies, different skills, and finally really get the best out of it.
Yeah.
And that's where those different protocols have been created for whatever reason, but now we really are on the edge to transition to unified communication, including real-time, which is not inherently part of TCP/IP, and that's what we do around TSN, time-sensitive networking, and OPC UA.
Okay, yeah. So let's dive into that a little bit. So OPC UA unifies essentially these different protocols and things like that. So what is the TSN part of this?
Maybe you want to take it, Adrian?
Well, if TSN of the sounds complicated, but in reality, it's a layer. It's all the changes that we need to do at the layer 2, and it's not a new protocol. It's features added on top of Ethernet. Making the data with different priorities, to stay on the same wire. That's basically what it is. In reality, I think Stefan has been driving with a number of industry leaders standards for about 10 years or something. So the reason we're here right now, there is a state that we got to, right?
Okay.
So they've been working the standard, right? So TSN started, we're not going to dive into that history and so on, but it's all about putting quality of service on the wires, right?
Okay.
And the idea is to have one wire. Right now, if you have a wire that connects a motor to a control device, you can't put anything else on that wire.
Yeah.
So that's a problem, right? So that's what TSN solves, and then lets everybody connect through normal routers. They have to reinvent protocols. There are plenty out there. So that's the other portion. You unify. You bring the IT world into the machines, because those have been proved to work.
Yeah. So what makes this different? Oh yeah, go ahead.
Just sort of interruption. I think it's a number of standards. It's 802.1q protocols, right? The standard, and then you have time synchronization. So critical part here is machines need to be able to synchronize the time or offset from a time that is desired and so on. So that needs to be provided. So this is pretty much all these standards that have to be included into make it easy for developers then to develop against.
Okay. So what's this sounds really like a great idea. So what makes this challenging, or what makes this difficult to implement?
I think I can comment from a device vendor point of view. So basically, we have the standard being pretty ready, and yes, standards always evolve, but the majority of the standards is ready and ready to be used. I would also say we have a quite good access to the technology. Once you are at a certain compute power, for example, Linux-based systems, there's a lot of ready-made source code, sample code, but also code you can really use in productive use cases already.
Yeah.
But where is now the barrier? Don't forget, we said that we want to get rid of the layers. The more you get down to sensors and actuators, the more you really talk about small devices, and small from different angles. Small means physically small. Small means also small in terms of power budget, So small, and you have a housing, you have certain temperature ranges, so you also have to get down in power budget. And the last portion of small is also cost. You talk always in every layer. It's kind of an X10 number of devices. So also the financial impact and the cost adder works against the fast market spread.
Yeah.
So what we are doing is really together, and we are super happy to have AWS and also the other partners here on that, is how can we make it better accessible on small footprint devices.
Okay, yeah.
Maybe you add.
So I said about the state where there was standardization. Then TSN is not necessarily new. It works on Linux system, so microprocessor based, but they have enough of processing power. But our goal here is to bring it down to microcontroller. So just to cut to the chase, we bring it down to microcontroller to get the cost down, to eliminate the need for DDR, for high-speed lines, for complex boards, and to be able to compete with existing protocols. Because existing protocols, they don't need to operate, but they're cheap now because they've been around for like 30 years or so.
Yeah, and you're really getting to the edge then, because now you're getting more to the atomic.
This is the bottom.
The atomic level of the factory, right? Which is sensor, microcontroller, combo, right?
And what you're saying is to get to the edge. I would even say we are driving the edge layer one level down.
Oh, I
so
see.
I would say, looking at the last 5 years, when edge started to be big with all the capabilities of security, data modeling, edge was called to be the edge layer. And the way we want to take is there is not anymore the edge layer. It's one. It's every, as you said, on the atomic level. The atomic level, the sensors and the actuators become an edge device with edge capabilities. That's the whole process.
Yeah, that's great. And so, when we talk about constrained devices at the edge, with sensors and things like that, we talk about real-time operating systems generally, and what better real-time operating system than FreeRTOS? So, what are you doing with OPC UA and FreeRTOS?
So, at the end of the day, the industry, partners came to us that we need an RTOS. Why we need an RTOS in general? Why we need an RTOS is because the developers won't be able to. Otherwise, the developers will do a lot of repetitive work.
Yeah.
We basically abstracting from the hardware. So you need TSN, you need all those protocols implemented, but then the developers to code against that is very difficult. You at the application level should be able to say which traffic is priority, what priority, what's the delay budget, and so on. So we make it easier for developers. There are hundreds or maybe thousands of field device makers that don't have the power to go code this every single time. So abstracting this with FreeRTOS. And the reason is FreeRTOS is because it's the most used operating system out there. But FreeRTOS also sits in an interesting position. It's free, it's the most free, it's MIT-based license, but it comes with support because it's an AWS. So we bring in support. So inevitably you get 2 years of support at every version of FreeRTOS.
With
and
LTS,
then you have and it's free. You know, even the support is free. And if you want more, then there are options to get more support. So that's why FreeRTOS. And then at the end is, you know, how we enable FreeRTOS to work. You know, I was talking about the state of the industry. So first was the standards. Then we wanted to do the silicon. There was no silicon. There was no process to support this because you're looking for devices that have at least 2 ports. In industrial, Stefan will tell you, the devices have to be daisy chained. So you need 2 TSM ports. So every device is essentially a switch, which you need to configure. So it is FreeRTOS, but it's also enabling applications that need to support it. So we're not going to stop at enabling FreeRTOS to support the hardware. It's about adding the missing elements to be able to configure, to make it easy for the industrial automation.
Yeah. So what are we doing in this space? What's happening here? Then it sounds like there's hardware involved. There's some software to work on. A number of things. Maybe break it down.
Talking about the LOI.
Well, I think I would start maybe commenting from DNR, from an automation company point of view on FreeRTOS. I think, you know, on the one hand, we always try to be as neutral and as open as possible. But what we really like about FreeRTOS is really the way how you deal with the good match of, on the one hand, having a supported solution, as you mentioned, but really bringing a license which kind of really avoids also vendor lock-in. So that's really something what we really appreciate about the way FreeRTOS is bringing on the table here. But then what are we doing? I think it's at the end it's a lot about also making available solutions and technology and porting it in a way that it really becomes a small footprint, scaling down to, as you called, RTOS, MCU type devices, low memory footprint. So it's a lot about that. There are some ongoing activities based on security, and we bundled that in an activity where we had a couple of companies coming together, agreeing on where we want to go, agreeing on a North Star of that project, and then really making it happen.
So in November, we signed a letter of intent where 8 partners, so it's AWS, DNR, Schneider Electric, a number of silicon providers like Texas Instruments, NXP, Lattice Semiconductor, analog devices, and ARM. So we got together. It's open for everybody. We don't exclude others, but to stay agile, we limit it to this. So we're looking at a collaboration in terms of go-to-market, reference implementations, and reference design to give the start to developers.
That sounds great. That sounds really great. So how do people get involved with this, and how do they find out more?
So you're gonna watch in about 1-2 months this, because FreeRTOS is open. It's an open source. We're gonna open the project, and we're gonna welcome. So the action items here are: we want developers to contribute. We want the community. We're not gonna stop at these partners that we put together. We want people to contribute. There's a lot of repetitive work that's already ongoing on FreeRTOS. People are writing code. Contribute. We'll consolidate. We'll make everybody to reuse everything that's being used in a uniform way. So, for example, we realize that all the silicon providers that we have, they modify in the same elements. Like, for example, the TCP/IP stack. We're gonna have just one, and feel free to use a different one, but we're gonna have one that's gonna support that. In a uniform way.
Okay. All right. Yeah, that sounds really great. So basically, developers should just stay tuned, and you'll hear some announcements around this coming up. And it sounds like a really great project. So any last perspectives? I guess while we have a few minutes left. Anything you'd like to say?
No. Well, I would really like to give the credit, Adrian, to you and to the AWS team behind, because they are really endorsing the adoption of technologies that are so common, maybe in the IT space, in the data center space, and I really we urgently need those capabilities in the manufacturing. And this initiative is one pillar of really making Industry 4.0 or IoT happen in manufacturing. So thanks for that, and really looking forward to the results of that initiative.
Adrian?
Yeah, so for me, the same thing. I think we're going to want to show what I call the true Industry 4.0, like really democratizing the data. Right? So we're going to spend a lot of time on showing the end-to-end, from the sensor to cloud, same language, with TSN, and then because we have to bring it up. Otherwise, it's really an acceleration motion.
Okay.
This can last 7 years, or it can be a year or two.
Yeah.
So we want to bring this up with reference designs and so on. So hopefully, we're gonna see people trying what's coming on the Git repo soon on the FreeRTOS, and let's engage.
Yeah, that sounds awesome. That sounds really great. Well, thanks for sharing all that information. Is BNR? Do you have a presence here at Embedded World?
No, this is not usually the show where you would see our customers. We are at different automation shows, but again, it's a super vibrant atmosphere here. Great to be here. Great to see some innovation, and we will take a lot of those back home and looking forward.
Yeah, well, thanks a lot for the time today. Really appreciate you joining. And so we're here live at the AWS booth at Embedded World in Nürnberg, Germany. And thanks for watching. We've got more sessions coming up, so stay tuned. We're going to take a quick break, and we'll be back with you shortly.
Hi, IoT Builders. We're back live from Embedded World 2023 from Nürnberg. And we are here with David and Elham for a very interesting session on AWS IoT Core Device Advisor and ARM virtual hardware and how you can test your firmware before deploying it to a real device. Hi both, how are you?
Hi. Good.
Alina, thanks for having us.
Thank you for being here. Can you both introduce yourselves, please?
Sure. I'm Elham, and I'm working as a senior solution engineer with ARM. It's infrastructure lines of business.
I'm Dave Walters. I'm a senior partner solutions architect here at AWS, focused on IoT partners. I'm also an ARM ambassador in the ARM developer program, so had a lot of chance to work with both AWS and ARM on our Better Together story.
Very nice. Thank you both. So let's talk about ARM virtual hardware. So what is it and what are the challenges that it solves?
Well, ARM virtual hardware is ARM virtual hardware scales and accelerates IoT software development by virtualizing IoT kits like Raspberry Pi and more, and ARM-based processors and system in the cloud. It's actually an evolution in ARM's modeling technology and helps developers to start working with virtual IoT instances in the cloud very easily by just their browsers and creating an instance very quickly.
Okay, that's really nice. It's really interesting. So, what kind of hardware types does it support? So, I know it's actually also third-party hardware, right?
Yes, we actually support different categories from Cortex M series like M0, 0 plus, 7, 3, 4, and 33, 55, 85, and some more that you can check it out. And first on 300, 310, and also we support for IoT development boards, popular ones, with our ARM partners, such as Raspberry Pi 4, IMX 8, IMX 8, and 93, and STM discovery board, and also we support for Android user, so Android developers can take advantage of that too.
Really cool. All right. Well, so David, what about the developer experience? Because we've got a bunch of probably embedded and cloud engineers watching us today. So how does ARM virtual hardware work with AWS IoT?
Yeah, good question. And you should be seeing a diagram as well next to this. So hopefully what I'm speaking will make sense in the diagram. I think the advantage of using AWS to build your embedded software, using AVH to test that software. And then, of course, there's the deployment to the real device, right? So in a very quick way, essentially we have a service called AWS Code Commit. And what this is it's a Git repository hosted on AWS. Now, I'm talking about Code Commit, but this could also be hosted on GitHub or any other type of source repository, right? But when you make a code commit, you change something in the firmware. At that moment, you'll kick off a CI/CD pipeline, right? So it kind of starts with a code build job, which is going to build your code using either the GCC compiler, ARM compiler, or you could use something like IAR compiler. Once that happens, either the code is successfully built, or the developer will get a notification saying, hey, you have an error in this function, it didn't compile. So assuming it's successfully built, then the next thing that happens is you can actually use ARM virtual hardware to test that firmware in the cloud. And you can do this in parallel so that you don't have to sit there and run this all locally on your laptop. You write the code, you wait for the test results while you go grab a coffee. Now you have a little bit of extra free time in your day as well. And what happens is you can exercise either the APIs to the ARM virtual hardware platform and say, hey, this is my built binary. I'm going to flash it to, for example, an STM32U5. I'll go and test that code. And what you can do is, on top of testing all of the conformance that you need for your firmware, you can also use something like AWS IoT Core Device Advisor, which is a cloud-based testing framework. Assuming that you your device will connect. It will run through your firmware's testing framework. It'll connect in the device advisor. And assuming that all of those tests pass, then you can automatically kick off an OTA to a real device. And so then you use, for example, AWS IoT Jobs to kick off an over-the-air update, deploy it to one device or a fleet of devices at that point. And so that way, every step of the process is documented, it's done in the cloud, and then eventually you end up on real hardware.
Wow, this is actually really interesting, and good that you mentioned IoT Core Device Advisor, because I think our viewers are probably really interested in what Device Advisor is and how does it solve the integration testing problem.
Sure. So Device Advisor is a cloud-based testing framework. If you're familiar with AWS IoT Core, it's a scalable message broker hosted on AWS and primarily supports MQTT and HTTP. And Device Advisor replaces that endpoint so that your device connects to a separate endpoint. And when it connects to that separate endpoint, Device Advisor will do a series of tests from the cloud. For example, it will automatically disconnect your device. It'll send like an MQTT disconnect or an unexpected hangup from the cloud side. And what you'd want to test is how your device handles that unexpected disconnect. Worst case scenario, something blows up in the firmware and now you have a problem. You catch that on virtual hardware before you deploy to the real device. Or best case scenario, you implement, for example, reconnect logic to, deal with that situation, connect back to the Device Advisor. And so Device Advisor gives you this test report at the end saying, these are the tests that we ran, like which messages did it publish to the cloud, which TLS tests did it do, and MQTT tests.
Yeah, that's actually really nice. Thank you very much. So now I'm actually curious because I know that you have a session at the Congress as well, and you are talking about machine learning models and how to build and deploy machine learning models on AVH. Can you tell us a bit more about that?
Yes, I have a session tomorrow here with the name MLOps on virtual Raspberry Pi 4. Well, actually, ARM virtual hardware is designed for machine learning and IoT application, and it allows developers, machine learning and data scientists to start testing and building their machine learning applications machine learning architecture and optimization tactic on our virtual hardware very quicker rather than on physical hardware. And it also helps developer to start taking advantage of software development practices such as CI/CD and MLOps and DevOps, so they can build their automated tested on the running on the GitHub and making sure that their tests are that their model are performing very well and the accuracy that they wanted to get. So it actually removes the barrier from the developer to building and buying expensive board farms and removing the needs of expensive, working with expensive board farm and hardware.
Yeah, and especially nowadays we face the problem with the chip shortage, and it's really important. I think it's on one side the speed, getting developers started and deploying and building really fast, and on a different note, it's also about shortages. So what do you do when your hardware hasn't arrived on time? So that's great.
Exactly.
So what is new for AVH? What comes next?
We are moving to we are offering a new getting access to so developer can get access to ARM virtual hardware very easily by register to our private free beta and start developing the application over there. And we are expanding some of our virtual devices for more complex application that needs that needs richer operating systems, such as Cortex 1000 and more. Yes, and that's all.
Yeah, no, that's, I think it's really good. So more accessible, more support for different, more complex operating systems and so on. I think it's great for developers to actually try it out. Which brings me to the next point. Where can developers get the material? What can they do? How can they access this? And I mean, also advanced developers, but also, more beginners as well.
There is a helper function with a helper with the ARM Virtual Hardware website, but also we have a developer program that developers can join and take advantage of talking with the ARM expert directly, and also many comprehensive resources over there at developer.arm.com.
Oh, that's really cool. So on a different note, I also have a session in the Expo tomorrow. So if you are here at Embedded World, the session is around CI/CD with ARM virtual hardware and integration testing with IoT Core Device Advisor. So just feel free to pop by as well. And yeah, I mean, we still have a little bit of time. So I would like to maybe ask David some more questions, or maybe one more question.
Sure.
You did say that Device Advisor has a variety of tests that one can, cover. So maybe we can go a bit more in detail on the types of test suites that you can run.
Yeah, I think Device Advisor is really good for two use cases. The use case that I talked about before is really around validation testing, right? This is testing your firmware to make sure before you go and put that firmware in over the air, you're not going to end up doing a truck roll to your devices because your device didn't reconnect as expected, right? And so for this, we have something called the long duration test. This test lasts from, I believe it's 30 minutes to, you can configure it to quite a long time, right? And it's essentially saying what your device does over a long period of time. So it emulates what it would do in the field, right? So it can randomly disconnect the device at any point during that long duration test. So what that means is you can't really cheat the test. Like, you have to build your device firmware so that it's reliable, right? So that you don't know when that disconnect is going to come. So your device firmware just has to deal with it at that point, right? We call that validation testing. But there is a second use case that's equally as important, and it's qualification testing. And so with the AWS Partner Network, we work with hardware partners that are either silicon vendors or OEMs that are creating, everything from development kits onto industrial PCs and gateways and everything in between. Mm-hmm. And with the qualification program, you can get listed into our AWS Partner Device Catalog, as well as advance through the AWS Partner Network tiers. And the first step to getting validated in the Partner Network is to do the qualification test suite. And so what that means is that the device connects, and it goes through a series of tests. So for example, the first test is a TLS connect. And so it's going to test, do you have the fundamental TLS libraries in order to connect into AWS IoT? You have to provision it with a private key and a certificate, and it will test all of that. The next test is an MQTT Connect test, and so it tests if the device has the MQTT Connect packet. If the test fails for any reason, the other cool thing about Device Advisor is you can go into the logs of the test, and you can actually see the entire, for example, TLS handshake. You can see exactly where something failed. You can go and debug that. Once you pass all the tests, you get a signed qualification test report that you upload into the AWS Partner Network's Partner Central portal. And along with, you do have to write some things about the device and some marketing information about it. Then you get it listed in the device catalog. Mm-hmm. So those are two main cases for Device Advisor.
Yeah, very nice. So here at Embedded World, we have a wall full of devices, and they've all been tested and certified. So if you're here, pop by and see our device wall. So Ella, any last words?
Thank you for having me here. I'm very excited to be here, and also having you as an ambassador with ARM. And I encourage the developer to start working with ARM virtual hardware, and they can see how they can scale and accelerate their application over there much more easier and quicker than physical hardware.
Yeah, definitely. Thank you very much. So I've played with ARM virtual hardware literally for about, I would say, 3 or 4 weeks now. So I've been working with third-party hardware and the MX8M, and it's been really great to get started, especially because I don't come from an embedded background. So I'm more on the cloud side. So it was really good to get accustomed to it. Yeah, thank you both very much for your time. It was a great session. And for the developer community, stay tuned. We're going to be back really soon for more content on observability and CI/CD and so on. Hi, IoT Builders. We are back live from Embedded World 2023. And I'm here with Leon from Sternum IoT. Really excited for the next session, which is going to be around embedded security, embedded runtime security, and continuous monitoring. So, hi, Leon. How are you doing?
Okay, how are you?
Very good. So tell us what you do and what is Sternum IoT.
Sure. So I introduce myself. My name is Lian. I'm the co-founder of Sternum. I'll tell a little bit about myself before talking about my company. Okay, so I started my technical background in Unit 8200, which is the NSA's equivalent in Israel. So I did a lot of cybersecurity and low-level development. And after that, when I joined the market, I went to work as a security researcher, understanding how the Android system works. And there I met our CEO, Natalie. She actually was also in an interview here about a week ago. And together and with some other partners, we founded Sternum, while our goal was to use our knowledge in cybersecurity and research to create an holistic cybersecurity solution to protect devices, especially devices that impact human lives. For example, medical devices, industrial, everything that has a meaningful impact. But now we really find ourselves that there are many devices connected, and so much of them affect our lives in a way that we don't know, because they are just out there. Everything functions, the trains, the lights in the road, everything. So everything is connected now, and we are working to protect those devices and also to monitor them.
Okay, thank you very much. So I'm wondering, what are the biggest challenges that you encounter when monitoring such devices that are out there in the field and accessible to everyone?
Sure. So I think the obvious answer is that embedded development is hard, really hard. I mean, it's not like being a Python developer or things like that. You need to focus on actually making sure everything works. Just once, not even executing your code. So just setting up the environment is very complicated. So I think developers are very scared of changing anything, especially if it's a third-party software. So I think the first blockage is the education, like getting trust in third-party components that the developer will embed. But after you pass that, you have a lot of technical issues where you have communication bandwidth limitation. You have, for example, I just talked with a person that told me he can only send 11 bytes at a time. So that's really an issue when you want to send really a short message that describes something. You can't do it because the system doesn't allow it. But this is an extreme case. Many other systems can, while maintaining low throughput, can send a lot of information, just making sure the behavior is intact. That's another aspect. Another aspect is the hardware. Everything is different in the embedded world. It's not like as standardized as a Linux system. You have different manufacturer, different bit speed, different drivers for everything. So a platform, let's say you develop a platform for Windows, for Linux, you can develop relatively one main software that can run on all of them.
Mm-hmm.
But on embedded, you need to invent the wheel every time. So that's another major issue, where if you develop something, you need to tailor it to a very specific system. In Sternum, when we designed our product, we wanted to solve all of these issues up front. We wanted to create a product that can be applied to many systems, no matter which communication channel is used, no matter the hardware. So this is why we made an instrumentation-based solution that will actually work in the binary level. So our only limitation is the ARM architecture for non-Linux devices. Basically, what we do is we go to the lowest level of the software, which is the opcode that the microprocessor runs, and we modify them to embed security. So that way we can actually work on really any RTOS, any ARM-based MCU, and so on.
Yeah, that makes sense. I mean, what is this proactive deterministic runtime protection, and what is the advanced threat detection?
Okay, so actually it's very hard to explain. I'm not sure why. I mean, I think when you look on a regular PC, you always install an antivirus. But when you maybe take a look on a controller that, let's say, manage a bridge that needs to go up and down when a ship passes by, no one thinks about it, right? So it's really, I'm not sure why. It's very not in our mindset. But generally, you have a couple of layers of security. First layer is making sure you have a signed firmware that is running. Let's say secure boot. You want to show no one tampered with your firmware. That's the first layer. Another layer, you want to make sure you have encrypted communication channels, so no one could tamper with them, gain sensitive knowledge, things like that. But the last layer is actually ensuring that the software during runtime is safe. But you can execute code. The device that makes decision based on inputs it gets from the outside world. So what validates that the device behaves as expected?
Yeah.
So that's the issue. So that's the issue of explaining it. But once you understand it, you see that it's necessary. The advanced threat detection, as part of the runtime prevention that we could give on the device, is based on our cloud platform. Basically, what we do, we allow the user to send a lot of data from the device. And in the cloud, we have our observability system that first checks for anomalies in the device's behavior. This is how we can alert you about maybe a logical issue with the device. Maybe it acts differently. Maybe it will reboot many times. Maybe it will connect to an unknown unrest for some reason. So this is another security layer. But I think the benefit of that is actually detecting many performance issues. So you get as a byproduct of threat detection, you get a rich observability system that you can monitor the device for everything they do, and to gain knowledge about how they are used and how they perform in field.
Mm-hmm. Okay, thank you for that. Thank you for explaining the very difficult concept. And now I would like to ask you about the evaluation kit offered by Sternum. So what is it and how does it work?
Yeah, okay. So we wanted to allow our potential customers to evaluate what is Sternum. So I can explain a lot for 1 hour what we do, but I think someone needs to actually do some hands-on playing with it to understand what it does. So this is why we published the evaluation kit. It's a device based on a STM evaluation board that has full firmware. It's an example firmware, not developed by us. It has a screen with many graphics functionalities. Actually, you can play music on it. You can play games on it. You can do a lot of things. It has a VNC server. So what we did, we first deployed our protection on this firmware. And then we also added the observability aspect by we call it traces, sending traces from that firmware to our cloud. So the kit will actually will contain the source code of that firmware, the Sternum integration that protects the firmware, but also an example of the observability SDK that we provide. All of that with access to the Sternum cloud. So you can get a visibility like it's a real device we just developed, and you can understand how it functions.
Mm-hmm. Okay, so the development kit, the evaluation kit, actually has support for FreeRTOS, right? And how does it really work?
Great. So the complex system I just described, it's all run on FreeRTOS OS, and Sternum as the out-of-the-box integration for FreeRTOS. This means we can adjust to your API that is using the communication channels that FreeRTOS can allow you to do. Mutexes, tasks, all of that is out of the box by Sternum. And we have adaptations to FreeRTOS because since it's a major real-time operating system in the field, we see it in many customers that they are using it. So we have out-of-the-box support for that. So this is why we wanted to select such a commonly used RTOS in our demo application.
Mm-hmm. Okay. So maybe can you describe some use cases for the viewers to understand a little more?
Yeah. So I'll stay pragmatic and talk about specific use cases. So on the protection side, okay, you want to keep your devices safe. That can be regulated in industries like the medical space, the industrial space, aviation, transportation, all of that. They are highly regulated, and there are a lot of regulation about cybersecurity, runtime security, things like that. That is, I think, the most basic use case. You have to stand with the regulation, and Sternum allows you to do that. Another aspect is actually to protect your intellectual property. I mean, many manufacturers are afraid that someone will hack their device and steal their IP, which they worked for 10 years, I don't know. So people used to jailbreak their phones, they do it using finding a vulnerability inside the phone software. So using our runtime prevention capabilities, actually the manufacturer gets also IP protection because people cannot jailbreak their device because they are protected. That's one aspect of runtime security. The other aspect is the observability work. I think it's very important. There are many use cases like that allow you to gain business intelligence. So let's be specific. If you have, let's say, hundreds of thousands of units in the field that are using battery, and now you can actually, if you monitor your battery health using the Sternum platform, you can predict when your battery will fail. So you can actually estimate how many units you need to manufacture or to fix, so you can prepare to that ahead of time. That's one aspect. You can take it to the business side. You can see which territories you have less sales cycles. You can see the but you're not selling a specific territory, so you can take business decision to increase marketing in a certain area of the world, for example. So using that observability, you can really create both business insights, but also insights for developers to make them build better products, to release fixes. You can monitor your errors in field. You can see basically what is the most painful parts that your users suffer from, and you can address them using the monitoring.
Mhm. Yeah, no, that's really cool, and I'm happy that you brought the topic. You nicely went from security towards observability, because now I would like to ask you more about observability. So, what are the metrics at device level? What are the metrics at fleet level that we can track?
Sure. Okay. So the Sternum observability SDK is very flexible. You can use it to many use cases. I can talk about some of them. So the battery health, for example, battery capacity is one use case. You can monitor your memory consumption, which is pretty basic, but it's something that not many device manufacturers have. They don't know if their memory consumption is behaving as expected. Another aspect is error monitoring. So if you have a critical error, like disconnection error, disconnections from Bluetooth, disconnections from Wi-Fi, maybe actually if you see a device that's supposed to communicate but does not communicate, that's another metric that we track. So, and I think the problem is that you can track a lot of data, but then you have, I don't know, hundreds of thousands of devices. Someone needs to understand what they do, and someone needs to learn or to create actionable insights from the data. And this is where I think one important secret sauce that we provide lies, because we have our anomaly detection engine that will let you know if there is an issue. We will let you know and focus where you should look, and not just collect a lot of data and then be swamped with it.
Mm-hmm. Okay, so in terms of the actionable insights, then you provide is it coming in the form of a dashboard or?
Yeah, sure.
Okay.
So it's a customizable dashboard. That's one part. But another part are actually anomaly events where you can investigate.
Mm-hmm.
So you can drill down from a huge fleet. You can drill down into a specific device, see what they did in the past hour, and investigate what was wrong in that. What went wrong there? So that's one aspect. I think when you talk about actionable insights, then the battery prediction and the BI use cases I mentioned were actually, they are actionable insights. But other actionable insights could be to see how your hardware behaves in areas you did not test it before, and then you can make future hardware decisions. If you can change your communication type because you see it's not working properly in some areas of the world, you can change your, let's say, sensor that you rely on because they see they don't work in a humid environment, which is relevant in some kind of world. So there are many actionable insights. I think it's sector dependent. So on the health industry, there are some kind of action. In the industrial, it's different. And we have that knowledge per sector, so we can help our clients focus and tailor the observability capabilities they have.
Yeah, no, that makes sense, especially with devices being out there in uncontrolled environments and totally different than the lab you've been testing them in. Right? Yeah, so I mean, this is really, it's been really great. And now maybe as our last call to action, let's put it this way, where can developers get started? Where can they get information based on how advanced or beginners they are, with a level of experience?
Yeah, so I think the best way is to use our evaluation kit, and that you just need to browse to our website. You can click on the Get Free Evaluation Kit there, and then you can just experience the system end to end. I think that's the best way to do it.
Okay. Yeah, so probably our producer has already shared the link with you all. So if you have any questions, please put them in the comment section and we would be happy to take them. And of course, if you are watching IoT Builders, feel free to watch the episode we had with Natalie, the CEO of Sternum IoT. It was a really good episode, very insightful. And yeah, I'm happy to have you here.
Thank you. Thank you for having me.
Yeah, stay tuned, IoT Builders. We are going to be live next shortly.
Thank you.
Hello and welcome to Embedded World live stream. I'm here, Nenad, joined with Marco from Eurotech. And today we're going to talk about Reliagate Edge IoT Gateway integration with AWS IoT Greengrass with zero touch provisioning, which is something that I'm really interested in. Maybe, Marco, you can introduce yourself.
Of course. Hi everyone, Marco Carver. I'm CTO of Eurotech. It's great to be here at the AWS booth. I'm talking with the IoT Builders community. Very exciting and looking forward for the conversations today.
Yes. Can you tell us a bit your background and where you come from?
So I come from the enterprise software background. I spent many years into enterprise software technology, focusing on developing most cloud native and large server enterprises, databases, and so on and so forth. I was fascinated by the idea of actually applying everything that we have learned into the IT space into the OT space, right?
Yes.
And actually seeing how cloud native methodologies, modern programming languages, more agility could actually be transferred from traditional IT development into the OT space, right? And that's where IoT is all about, right? And Edge is actually even the next step of that, right? Taking those technology, taking the largest software developer community that we have available now in terms of resources and uses that capabilities into OT applications, adding connectivity, autonomous behavior into devices that did not have these features before.
No, that's just pretty cool. I mean, usually we see like there is a barrier between like OT world, IT world, and all that kind of stuff. No, this is excellent. You know, when you're thinking about like extending this, what you said from the IT to OT, I remember back in the days they had like a strict security policies, like with firewalls and all that stuff. Like, maybe can you talk about this, cybersecurity certification and all that
Absolutely. Stuff? Well, so the barrier is still there, right?
Oh, okay.
It's still difficult to some extent to have a smooth transition and a smooth rollout of IoT projects. Everybody knows the statistics, right? The mortality rate of IoT projects is very high, right? 75% of the IoT projects do not go beyond the POC phase, right? And there are many reasons why that is happening. IoT is still very fragmented. The data is still very siloed, so it's hard to extract them. But there are also a lot of concerns, and cybersecurity is at the top of those concerns, right? There are many reports out there. We've seen Gartner, we've seen McKinsey that are doing surveys on what are the biggest barrier of adoptions of IoT, and cybersecurity always pop up at the top, right? There are actually answers that I've seen that larger OEMs are not adopting connectivity because the risk does not make it worth it, right? Now, in this landscape, what can we do as technology providers to actually lower the barrier of adoptions, right? And the best things are best practices, blueprint, standardizations, right? And we have seen that happening more and more. There is a large consensus on what are the reference norms in cybersecurity, what are the best practices in cybersecurity, and that will give the peace of mind, will give them pre-certified components to the adopters of this technology that they can start build upon. So us, for example, as Eurotech, we produce IoT gateways, IoT edge nodes. We go all the way to edge AIs. We have adopted a couple of cybersecurity frameworks across all our secure development product lifecycles. We have certified our IoT gateways PSA, Platform Security Assurance, in a collaboration with ARM. And recently, we have extended that certifications to the IEC 62443, which is Cybersecurity for Industrial and Control System, which is becoming one of the overarching framework for the development process of your products, as well as the certification of the process itself. Now, there is no silver bullet, right? If we go back on security, there is only good processes, good procedures, and making sure that you rely on a solid foundations of pre-certified components rather than reinventing the wheel from scratch. So,
yeah, I remember Dan was having this joke. Is like the good thing about standards is there are so many to choose from, right? Which defeats the purpose of the standards. Right?
That is very true. It's very hard to map them out, right? But there are certain points into the evolution and the adoption of standard, very much like the evolution and adoption of technology, where the start to seem to be convergence.
Exactly.
Right? And I think cybersecurity is getting close, right? I mean, we see what is happening in the US with the Cybersecurity Act. We're seeing what the European Union is trying to do. We're seeing a couple of these reference architecture for cybersecurity that are getting more traction than the other. So we lined up on 62443. It seems to be a good one both in Europe. Now it's also getting US traction. Whether or not it will be 62443 to some extent is beyond the point, right? The framework will be the foundation that you need, right? It's the best practices and the blueprint, right? That gives them an adoption path to our customers to follow, right? An assurance to start from, and an adoption path into the journey.
I immediately have like two questions. So one question is in regards to scaling this with many devices.
Great question.
And then another question would be then, accepting this developer personas who have been developing those applications in the cloud, and then now allowing them to deploy those applications on the edge. So let's first start with this scaling the devices, then we can scale the applications.
Scaling is a great question, and it's the next thing up, right? I mean, it's easy to prepare 10 devices on a workbench or in a lab. It's much harder to maintain a fleet of 100,000 devices, 300,000 devices, right? One of our customers is actually one of the largest deployments we have is 300,000 connected homes, right, for IoT deployment, and they rely on their heating in the winter to actually work, right? So scaling is a really big problem, and it cannot be an afterthought. Right? It's not something that you can retrofit into your design process. You have to start on solid foundation. That's why we love partnering with AWS, right, and all the infrastructure that he's building. And that's another building block that we can use to build up, right? But going back to the scaling, the first thing that you need to realize is that everybody jumps to the conclusion of, okay, I need IoT cloud connectivity, but that's just the last milestone of the journey of an IoT device, right? An IoT device is manufactured, is actually commissioned, is transferred to an ownership, then is finally installed, and then there is the end user using it. You have to keep all these milestones of the journey of the device in mind. Through this process, you have different identities that the device is taking, right?
Exactly.
So there are identities that are given to the device at the manufacturing time, like the nameplate of the device.
Even the ownership is changing.
Then the ownership is the device, right? The device may be decommissioned, may be repurposed, may actually be assigned into another applications, right? So we actually collaborated with ARM, with Infineon, and with you guys in AWS to actually define this blueprint, right? So we call it a zero-touch provisioning blueprint, where we are relying on a couple of standards. The Secure Device Identity Standard by the IEEE community is IEEE 821AR, which is using standard private and public key infrastructure to create an X509 certificate with standardized extensions to build the nameplate for the device, and to have multiple of these nameplates during each of the life cycle of the device. So you can have an initial device identity as it's defined in the standard and in the literature that is supplied by the OEM. You can have a local device identity that is actually attesting the ownership of the device by the customers. And these identities can act as credentials for public key infrastructures that will actually open up and enable the next layer into this hierarchy of identities, right? So I can have initial device identities that are very long-lived and that are attached to the lifetime of the device. I can have local device identities that are attached to the ownership and therefore to the application. And I can have operational identities that are very short-lived, so that I reduce the attack vectors, right? If they are compromised or abused, that are used as credentials for my authentication to the IoT cloud service.
That's pretty cool.
So what we have demonstrated yesterday and what we have here at the booth is it's exactly that. It's zero-touch provisioning flow where an installer with a mobile application can connect to the hotspot of the gateway and through a simple three-step wizard and actually take the gateway all the way through the onboarding process and connecting to it.
Nice. So just tell me also, I mean, when it comes to storing this certificates and so forth, does the gateway have like a TPM or?
Absolutely. So as you are managing the different identities, you are also associating, just as you said, the different owner of each of these identities. So you need the proper access control level at each layer, right? So we're actually using the different control domains that are available into the TPM 2.0. So we are using the platform hierarchy to store the IDEV ID, because us as OEM providers, that's what we control and that's what we lock. And we are actually using the storage hierarchy to store the LDEV ID, right? The local device identity that attests the ownership once the device is commissioned for a specific application. Now, the local device identity is used to connect as an authentication token into remote PKI services to acquire the short-lived operational identity that will be used to connect to AWS IoT Core.
No, this is really good. I mean, I remember a scenario where we actually had a customer that were not trusting the OEM. And I mean, in these scenarios, like this would be a perfect use case.
Absolutely. So you can actually trust the IDEV ID as a proof of the integrity of your supply chain. Right? The IDEV ID will be signed by the device manufacturer. So in our case, we as Eurotech test the integrity of the supply chain that led to the manufacturing of the device by installing that certificate into the device and lock it up so that you can use that as an attestation token for the next steps into the lifecycle.
No, this is really cool. That's really cool. And then coming back to the second question, like
of course,
now you have, you know, this kind of like chain of trust, more or less, and you will allow that applications to be deployed. Do you have any mechanisms to kind of like make sure that the right applications are landing on the right devices, and like how that is ensured?
That's a very good question, and it's the next part, right? The next part is the commissioning and actually making sure that at the installation side, you actually choose maybe from a predefined set of application scenario that enables the device communication. So it also ties back to security. Security is not a one-time action.
Exactly.
Right? Security
throughout the life cycle of device, right?
Absolutely. So you do have device management functionality, right? We provide some as Eurotech that are more intimate to the hardware. We collaborate with cloud vendors like you guys, right, to tie into your ability, for example, to remotely deploy application into the Greengrass runtime. So the idea is to extend that blueprint into the application configuration, right? As you scale up to the tens of thousands of devices, you will generally seed the devices with a superset of your applications, right? Some of them will be preceded. Other of that is configured at installation time, right? That's how you approach normally the problem, right? So you pre-install the basic set of applications that you need, and then you use cloud provisioning to compensate to the last mile, depending on the installation-specific configuration.
And this is what we see. There's kind of like two different personas. Like one is the embedded system developer, which is like doing the board support packages and doing like the system components more or less, which includes Greengrass in scenarios. And then, like once that is in the wild, then we have the application developer who's then writing those components that are actually the main differentiator of like or taking that use case and then making sure that it operates as expected, right?
Absolutely. I think it goes back to the high fragmentation of IoT.
Yeah.
Right? How do you address the fragmentation of IoT is by providing enabling technologies.
Exactly.
Right? That will reduce the barrier of adoption, will have a much faster time to market, and you'll have a larger community of people being pulled into this. So Greengrass, the IoT framework that we provide also we have 30 plus fieldbus protocol ready to use.
Yes, I saw that. Yeah, this is
acquire
really cool.
data. So what we show here in the booth of AWS is energy-driven protocols,
Yes.
right? So to pull data from base stations, RTUs, right, using 61850. But we have a large set of these protocols that you can use, right? So these are all Lego bricks, building blocks,
Yes.
that reduce that adoption. But the ability to use cloud-native technologies like Greengrass with its container management, the AI frameworks, the fieldbus protocol, maybe low-code, no-code environment like the one that we are providing over some of the Greengrass.
Yes, I saw that as well. It's like a web browser, and you can
absolutely
move the things around and then pipe them, and stuff. That's pretty cool.
That's what you need, right? I mean, you do need to break the silos in which data is trapped in the OT space.
I was about to say, especially in the OT space, the people who are actually going to use the system, they might not be familiar with writing C applications, whatever that. They might be familiar with like block diagrams, connecting them, and maybe writing some Python code there and there, or like Excel sheet or something like that, right?
It's absolutely true, right? So I think a lot of the edge applications have recurring patterns, right? The pattern, they always involve the data acquisition step, right? You may have different fieldbus protocol with the interfaces. You may use cameras as an additional sensor. You have data aggregation and filtering and local data historians in the edge itself. And then you have some kind of cloud connectivity and the feedback loop that cloud connectivity may give you.
And you can have like operating on data that's on the edge, and then you can have operating data that's on the cloud, and producing new insights and whatever.
So when you have repeatable pattern, what does every software engineer do? It builds frameworks, right?
Yes.
So that's the typical response.
No,
right?
I really like it.
And that's what we have now, right? Now we have frameworks that are mature enough that will actually take you faster through the process of onboarding your application, on getting into that POC phase, that will let you win the business support that you need to go forward into.
It is more or less like infrastructure that goes above the cloud. It's like an IoT infrastructure that allows whoever the personas is, either in OT or like other developers, to kind of like focus on what they actually need, right? That's pretty cool. I love that stuff.
That's where we are, and that's what we love collaborating with you guys, right? We share that vision, right, of how important is the edge, how modular the edge should be, because we are addressing fragmentation. We have to recognize that, right? There will no. I don't believe there will be a single company that can cover it all, right? This is an ecosystem play, and that's why we value this event and these opportunities.
Exactly. Right? No, this, and as you said, like different partners with different expertise need to come together to build that whole IoT, pipeline in order for a customer success at the end. But one thing
that's why I want to catch up on that open source that you have in your pictures.
Open source. We love open source.
Yeah, because that's really one of the best way of bringing and building these ecosystems, right? So the IoT Edge framework that we have is an Eclipse open source project that we founded and mentored, right? And we continue to steer. It's based on Eclipse Cura, and Greengrass is open source as well, right? So open source is a great way to bring great minds together and build all this collaborative framework that can take some of these barrier adoptions down.
One thing I'm interested now, like when we speak about this, there are this kind of greenfield environments where you actually start from scratch and you can employ all of this. But there's also like brownfield things that are floating there, and then they need to be retrofitted or something like that. It's like, is there any special things that you do or any special solutions that you provide based on that?
I think it's a great question, and it's part of the adoption of IoT itself, right? So a lot of the IoT started from the retrofit, right? We said that there are all these data silos out there, and you actually use a gateway to go in and break those silos, get the data out, and start, right? So you add the connectivity by retrofitting a gateway element into the existing assets that you have in the field, right? We have deployment into cargo trains, right? For example, Deutschmann is using our equipment into each of their locomotives to actually tap into the data paths that to extract those trains. But the evolution is to embed the connectivity into the next generation products, right? So now that we have hardware gateways, maybe tomorrow we'll start having software gateways.
Yes.
So we go back to that framework, right? The idea that if you lay your frameworks on technologies that are highly portable, on technologies that can be containerized, then you're ready for the next evolution, right? So hopefully your biggest investment into the IoT journey is choosing the right technology that is future-proof. And the future-proof may also entail, at a certain point, a migration from a hardware-level support to a software-only level support. But as long as you base that on Greengrass or on our ESF Edge framework, and you'll have API compatibility layers, right? And
perfect.
that will take you through the different journey in that stage.
No, this I love this kind of abstraction layer that allows you to move in different directions based where you want to go. So this is awesome. No, excellent. Yeah, I think we are running out of time. This is a fun topic. I think we can talk about it for hours.
We'll go get the coffee and continue there, right?
Yes, excellent. Yes, let's do that. But that being said, is there anything else you want to add for the?
No, I think it has been great being here. It's great to be in person again, right? After
true.
so long,
True.
and it really feels like a tight community of people that are getting together.
Yes.
So thank you for the opportunities. Really exciting.
Anything interesting you saw?
Well, we certainly encourage you to visit us, right? If you are here and following us from the show, right?
Yes.
We have a demo here at the DevAlert booth. We have a demo at the ARM booth.
Oh, okay.
And we have our own stand. So
nice.
Certainly welcome you to further the conversation.
Excellent.
After that.
I will definitely. I haven't seen the other booths. I'll definitely go there as well.
We're happy to introduce you.
It was a pleasure talking to you.
Same here.
Right.
Thank you so much.
Thank you.
Yeah. Thank
Bye,
you.
everybody.
Bye.
Thank you.
Welcome back. Here we are live again at the AWS booth here at Embedded World, the conference in Nuremberg, Germany. And I'm joined today by Grant and Andrea from Linaro. And we're going to talk about the cloud native car with SOAFEE and Linaro. My name is Dan Gross, and I'm a senior developer advocate with AWS. Hey guys, how are you enjoying the conference so far?
It's having a great time. This is my first time at Embedded World, and it is certainly bigger than any of the other conferences I've been at.
Awesome.
So,
yeah, I hear there's something like 18,000 attendees, so it's quite big.
Yeah.
Yeah.
For me, it's a regular event. It's great to be back, and it's a very positive message that we are back to what it was before the pandemic. It's so great to be back.
Fantastic. So why don't we go with some introductions first? Maybe start with Andrea.
Yep. I'm responsible for business development at Linaro, which is actually a technical role.
Ah, okay.
That's what I like, because it's about identifying new technical areas where we have common problems that multiple companies want to solve, and that is where Linaro performs and delivers at best. So my role is to identify these new technical areas, new problems, and identify the new companies that want to collaborate, because ultimately this is what we do. I've been involved with Linaro for 12 years. Linaro was founded in 2010 by ARM and other companies. At that time, I was a fellow at ST Microelectronics. And then a couple of years later, I crossed the fence, and from a representative from ST in the board of Linaro, I became a full-time Linaro employee.
Okay, so you've been in open source for a while now.
Yeah, I'm enjoying it.
Awesome.
Enjoying it.
And how about you, Grant?
So I am Linaro CTO, and I have been in this role for about a year now.
Okay.
And it's been quite exciting to look at technical direction and strategy and how we actually build products and help our customers, help our partners and members build the products that they need. My background is I'm a Linux kernel engineer. I was responsible for a number of subsystems. I brought device tree to ARM. And I was also responsible for much of the System Ready program that ARM started a couple of years back. And then when this opportunity came up to take the CTO role at Linaro, I've been involved with Linaro in various roles for the entire life of the company. And so it was quite an easy decision to say, yes, I want to do that, and I want to go to the next step with Linaro.
That's fantastic. Oh, okay. Well, thanks for the intros. So we're here today to talk about the cloud native car with SOAFEE and Linaro. So, maybe we could start with a little bit, what is SOAFEE, first of all? What are we talking about when we're talking about cloud native car and SOAFEE?
Right. So I go.
Yeah, sure.
SOAFEE is a new initiative that ARM has started around the vision for the next generation of software-defined car is that rather than a fixed function of you buy a car and that's exactly what you have, that the future generations of cars are going to be, it's more dependent on software, that the functionality and what your car is able to do can develop over time.
Okay.
There are services to do that. However, to actually meet that vision requires new technology. It requires a new way of doing the software.
Right.
That involves being able to load applications, have multiple things that used to be separate, being able to run on the same place. And it's also dealing with the major technology shift that we're seeing in the automotive market. And anyone who's in automotive will have seen the pictures that are going from every system in the car is a completely separate wiring harness and a completely separate setup to a domain or even a zonal architecture where you have the sensors connected to zonal controllers and most of the data all gets collected in towards a central compute server. And that central compute server needs to run more than one thing.
Okay. So this is a big change in automotive.
This is a massive shift, yes.
Okay, yeah, because as you mentioned, it's all been about the the control modules and things like that. Now we're talking about the architecture of the vehicle, right?
Yes. So SOAFEE is how we do that.
Okay.
SOAFEE is the architecture that we need. How different software vendors interoperate and be able to work on the same pieces of hardware. How we test platforms not just on the individual pieces of hardware, but in cloud environments or test environments such as AWS.
Okay, yeah, so that makes sense because that's where a lot of CI/CD pipelines exist. That's where there's a lot of best practices in developing software that can be deployed to systems like you're talking about in automotive. Yeah. Okay, fantastic. So it's both a software architecture and runtime services. Is that right?
Yes. So to dig in a little bit deeper on what SOAFEE's doing, is the SOAFEE project is collaborative, it's open, and there's many vendors who are in the automotive space are collaborating. And so there's a technical steering group that is able to propose blueprints of here's the technology that's needed to solve a particular problem.
Okay.
And within so within the SOAFEE group, we've got the structure to organize the requirements, what each of the vendors need, and how to get it out into the market.
That's great. So what's maybe an example of that? Something that maybe we can visualize with SOAFEE. Maybe something that you see as a blueprint.
One is Project Iceberg.
Yes. Okay. All right.
So, Project Iceberg is one of the first blueprints that is being contributed to the SOAFEE Special Interest Group. So it's a set of services, a set of middleware and application code that retrieves all the data from the sensors in a car that can do local real-time processing, machine learning inferencing of these sensor data, and then can transfer it to the cloud where you can do further analytics and further machine learning in the cloud. And if you think about it, it opens up, it adds intelligence into the car, and you deploy these services as containers during the life of the car, and you can have third parties, software service companies that deploy new services. And you can think of the buzzwords, predictive maintenance. They can detect crashes and call for assistance, medical assistance, technical support. But you can also think of new innovative business cases like pay per drive. Imagine an insurance company and you can do pay per drive because you look at all the sensors and, you're a good driver, we will give you a better price. Or maybe even like a black box of a plane in a car. So there are endless possibilities. Where the cloud native approach adds huge value is that you can develop these containers that shall run into the car. You can
chair failure.
Auto eject from the car.
Yeah, there you go.
So you can develop these containers in the cloud on a Graviton instance.
Yeah.
And thanks to SOAFEE, thanks to technologies, you have the confidence that those containers will run the same when on an embedded hardware in a car. So that is where Linaro fits in this picture, by providing the baseline software, by providing the technologies that Grant will hopefully describe for me.
Yeah, we're going to.
And so Linaro is providing all these layers and technologies, and helping ensure that there is coherence between what runs in a cloud-native environment and what runs in a real automotive hardware. Because we are setting up an integration lab.
Yeah. So yeah, what is Linaro's role in this, in SOAFEE and in Iceberg exactly? Like, what are you providing?
So we are coordinating the development of the baseline technologies.
Okay.
Coordinating the porting and testing of these technologies on multiple SoCs.
Yeah.
And we are coordinating as part of the wider SOAFEE special interest group in driving some of the groups and some of the technical activities.
Yeah.
And
yeah.
And the technical bit.
Yes.
And Linaro's had experience with this type of thing, with other projects as well, right? Yeah.
This is what we do.
Yeah.
So Linaro, we take on the big software problems, the big technology problems that are industry-wide, that no one company is able to solve on their own. So
even big companies.
Even big companies. And the reason they can't solve it on their own is it's not a problem of engineering. It's not a problem of having a bunch of engineers on a problem, though that is part of it. But it is one of collaborating. It's one of working out what the best solution is so that it works for the whole industry. In Linaro's history, we were set up initially to solve the Linux on ARM problem. And at the time, Linux on ARM, quite frankly, was a mess. A lot of engineering types like me, we had great fun with it.
Yeah,
but
lots of ports and lots of
you were messing it up.
Yes, we liked the word. So it was a lot of engineering.
So you created the problem that you went on to solve. That's fantastic.
I don't like to put it that way. But what it ends up being about is interoperability.
Yeah.
And so with fixing the Linux kernel, we were now able to run an unmodified Linux kernel on a whole bunch of different boards, a whole bunch of different platforms. It's similar in SOAFEE. It's similar in the automotive space. Because there is such a massive shift in architecture, both in the consolidation down to central compute for a lot of the functions in the car, and also in needing that software to be portable, to run in different places, right? For a vehicle vendor with the current development practice, you would develop the same dashboard application multiple times every time you do a new vehicle.
Yeah.
So with things like SOAFEE and the testing lab, it's about interoperability. It's about one company's products, one company being able to sell their product to another company as in the process of building up all the pieces that go into the car and having those components work well together.
Yeah. And you can see, this is in some ways consumer driven, right? There's an expectation that your car is as good as your smartphone or your other things, and maybe some of the lag that's happened in the automotive industry, is because maybe they didn't have the same tools.
Something. And this is also where the technology comes in. Why is automotive different from, say, existing cloud native development that we're doing? The automotive markets, right off the bat, people die when it goes wrong.
So safety is a huge issue. Okay.
The way that auto vendors build their vehicles to make sure they're trustworthy, to make sure that they are safe, that they are good products for consumers, requires certain engineering practices. And
that's great. It's awesome. It's a really good thing.
It's awesome.
Yeah.
But what that means is that we can't just lift technology and land it in automotive. It means that we can take concepts and approaches there, and the vision for that is good. But now we need to adapt it and make it specific to the automotive requirements. And what that means is the vision is there, but the technology required to make the software-defined vehicle a reality doesn't exist yet, or it's not mature yet in the core common software.
Okay.
And that's right.
Yeah, that makes a lot of sense. Okay, so and what's really cool about that is you can start working on the software for this car, this template of a car, let's say, and even without, say, the hardware choices and things that ultimately will come. Is that right?
Well, and it starts to drive some of the technology of what we need.
Okay, yeah.
So to make this work, if we're trying to build a software-defined car, time-sensitive networking, TSN is a critical component.
Yes.
So we need to make sure that the TSN features are plumbed all the way through into the applications that are running as virtual machines or as containers. Another of the key technologies to make this work is VirtIO. And VirtIO is like in virtualization, that technology is already there.
Okay.
But it's been designed for cloud systems. It's been designed for regular typical virtualization on data centers.
Yeah.
What we need is that same VirtIO technology, but adapted in a way that's suitable for automotive,
Yep.
and that has standardized interfaces that make sense for the vehicles, right?
Yep.
So a driver alertness monitoring system doesn't have to go and change its back end every time you plug into a new vehicle.
Yeah, or you don't need to restart your software development on a piece of hardware that you've chosen because you don't have the hardware yet. Yeah.
And when you're running in a cloud testing environment, you're able to test that software in a whole bunch of different scenarios by simulating the input through that exact same interface.
Yeah, that's
and
great.
You get the same timing, you get the same behavior out of it.
One thing that really made me fall in love with the vision from AWS, from Stefano Marzani, who was in one of the previous podcasts, is this concept of cloud native development, where if you think about it, you're running on an instance in the cloud. But if you look further, in a mixed criticality workload setup in a car, in a software-defined vehicle, you have different VMs for different software domains. You have the infotainment, the digital cockpit. You have early functions like the remote camera, or these are all different VMs.
Yeah.
The power of the cloud native vision is that you could run each VM in a different Graviton instance. Think about it. You are not simulating the entire chip.
Yeah.
You are breaking it. You're breaking it apart. One VM runs on one Graviton instance and is the infotainment or Linux or Android Automotive, and you develop it in that environment.
Yeah.
The real time will run with a real-time safety certified OS, for example, will run in a different VM. And if you have an ML accelerator and you have a model that runs in an emulator, you can run it in another instance. You have a Cortex R, you have a microcontroller with a QEMU model, you run in another instance. And suddenly, the power of this vision that is so fascinating from AWS, from Stefano, is that the VM, in the early car, you had ECU to ECU communication via CAN bus.
Yes.
In a software-defined vehicle, it becomes VM-to-VM communication via a hypervisor infrastructure.
Yeah.
In a cloud-native environment, it becomes instance-to-instance communication via a port.
Yeah.
It's unbelievable.
Yeah.
I fell in love with this 1.5 years ago.
It seems logical, right? You have encapsulation and you have modularity, and that's very important with software design and system design.
It's so powerful.
Yeah. So this may surprise a lot of people actually, that we're making it sound like vehicles are little data centers, but in fact they are, right?
They are. I'm going to moderate that just a little bit.
Yeah.
Where it's true that there's a lot of compute that's going into cars.
Yeah.
It's also true that they're cars.
Right. Yes.
Right.
Of course.
And so the analogy helps us to a point, because it's that those are the concepts that we want to pull in.
Yeah.
But at the same time, those concepts, we need to be doing something that's suitable for automotive.
Right. And that's the important aspect of it. Okay.
Yeah.
Well, great. So anything else we want to mention about SOAFEE, about Iceberg, about VirtIO?
Yes. So I think it's important to talk about. We've got the idea, we've got the structure on what needs to happen here, and blueprints that are showing up in SOAFEE that describe what needs to be done. The next step is very much about engineering.
Okay.
It's about going from, we've got this concept and the sizing of what we want to do and what a roadmap of next steps. To fund that engineering is the challenge now. And so we're setting up proof of concepts, we're setting up projects to actually build and demonstrate the pieces that are needed and start getting the code back into mainline.
Okay.
So for anyone who's working within automotive and are wanting to know how to interoperate, how to work with the other vendors, how to get their products ready for a software-defined vehicle, please do come talk to us at Linaro. This is what we do in terms of collaborative engineering. So not just having access to the technology and the source code, but being able to work with the other industry leaders and have defined projects where we complete and we get it out there at the end.
Yeah.
And we get real work done together. It's not just chatting or conferences, it's getting real work done together.
Yeah. So it's real collaboration.
Yes.
You're not just
We're an engineering company.
Yeah.
We like to build stuff.
Yeah, there you go.
We're
And we can help.
We're geeks.
Yes.
Yeah. Oh, that's great. Yeah, this isn't just something you're talking about. This is something you want to active
This is
participation.
something we are building.
Yeah,
Yes.
exactly.
Yes.
Okay. Well, great. Well, I think we're winding down on time here, but it's been really great having you both here. I really appreciate your time. Anything else going on at Embedded World quickly that would be interesting?
There's lots. The big thing that I'm excited about is System Ready that over at the ARM booth. And so anyone who's within the ODM or OEM space, System Ready is starting to bring together, taking that next step of standardization. In fact, all the SOAFEE stuff is built on that, so that an OS vendor doesn't have to do a whole bunch of work to get their platform running. So I would go, anyone in there, I'd suggest go and take a look at that.
Okay, so check out the demos. Come to the AWS booth here in Hall 4 at booth 550. We've got demos around.
I think Project Iceberg is also around
It's over
here.
here.
As a proof of concept.
Yeah, so
It's right next door here.
We have Project Iceberg. You can't see it, but it's right there. Thanks again, guys, for
Thanks for having us.
Yes, thank you for the invite.
Absolutely.
This was fun.
Thanks for taking the time. Okay, we've got more sessions coming up on IoT Builders live from Embedded World. Stay tuned. There'll be more great content coming. So long for now.
Hey everybody, welcome back to Embedded World livestream. I'm Nenad. I'm joined here with Walt and Jan-Simon, and we will be talking about how to build automotive grade Linux for AWS. So why don't you guys first introduce yourself, and then we can jump into the topic. So Walt?
Sure. My name is Walt Miner. I work for the Linux Foundation. I'm the community manager for automotive grade Linux. I've been doing that for almost 9 years now. And as I wrote in my bio, as a child, I dreamt of being a Major League Baseball pitcher, but unfortunately, I had no talent and didn't work out. So instead, I settled into being an embedded software engineer. So,
Jan-Simon?
Yeah, hello, I'm Jan-Simon Möller. I'm the release manager for AGL, also working for the Linux Foundation. And I'm actually an ham radio operator in my spare time.
Excellent.
And that's where the interest for the electronics comes from.
An embedded systems.
Of course.
Right?
I'm more of a ham. He's a ham operator.
Ham operator.
You get it?
Yeah.
See?
So now I see the connection. Okay, cool. Excellent. The topic is not ham radio and that stuff. Like what we want to talk is automotive grade Linux. So I would be interested to see what that actually is. What does it mean?
So automotive grade Linux, we have 155 members of our 155 member open source community underneath the Linux Foundation. And of those 150 plus members, we have 11 automakers. We have a large number of tier 1 suppliers. So automakers like Toyota, Mercedes-Benz, Mazda, Subaru, Suzuki, and then tier 1s, all the big names like Bosch, Continental, Panasonic, Denso, and then a large number of tier 2 suppliers, all working together on building a single code base called the Unified Code Base that's available freely for download by anybody who wants to. We make a large number of demo and reference applications available for IVI systems, for instrument cluster, for telematics. We've had, I think, 15 major releases now. We do about 2 releases a year. They're all named after fish. And our most recent release was the Optimistic Octopus release.
Oh, okay.
Yeah, we named them, after fish. So
Nice. And so just for me to understand, more or less, this idea came into from the automakers that they can contribute to one code base and have a unique platform so that they can build things on top, right?
Yeah, the idea is that AGL will work on the non-differentiating features that everybody has to do over and over again, like maintaining the kernel, maintaining user space things like Pipewire and Wire Plumber for audio. Everybody will have this, everybody would then have the same base version of all that, basic plumbing that you need to build exciting differentiating applications. And then on top of that, we could build, and we have reference applications for Qt, for Flutter, for web apps, and based on Chromium. So we've got, if you go to our booth, you can see we've got a wide variety of different applications that are available, and you can see all the different environments running in a single demo app over there. Also, we also have a containerized version of our instrument cluster and IVI, and also we've worked a lot with Panasonic on VirtIO and virtualization. So we've got a KVM version that's available publicly, but we've also got a Zen version that EPAM has worked on. OpenSynergy has ported AGL onto their VM.
Nice.
And then we can run IVI or instrument cluster in containers, in Linux containers. So
yeah, this is an excellent topic. I think even before us, we had some sessions talking about the software-defined vehicles and all that stuff. I think this is a really important topic to have that kind of infrastructure, the layer that is kind of specific to, let's say, board support packages, and then it goes on top that you can build applications as well. And then having that abstraction layer of VirtIO as well makes a lot of sense to test things in the cloud as well. So that's an excellent thing. But so this project also uses Yocto to kind of build all of that. So what's the relationship between Yocto project and the AGL?
Yeah, so AGL is building the images that we create using the Yocto project. So we are essentially a superset. We take the Yocto project, the stable version that's released there. So that's currently Kirkstone. And we add the layers for the reference boards, for the boards that we use. We add the layers for the UI toolkits. You named it already, Qt, Flutter, web apps. And we basically integrate that at Automotive components like the vehicle signal specification. The implementation that we use is called CUPSA. So we pre-integrate Automotive components there, and essentially it's then a distribution that you can use and build upon for different functions in the car.
Yeah, excellent. So you have like different meta layers that go on top, and then you can kind of build your own either a reference, use the reference board
applications,
or,
yes,
yeah.
or the reference boards and the reference applications to try it out.
Yeah.
But you can take that base and pick it up and build your product out of it.
Yeah, that really, I mean, from that perspective, it kind of speeds up the development, and you can always, since you're kind of maintaining that stack, it's easier for developers to kind of, have the base that can start building things.
Yes,
And
you don't have to start from scratch. You already have a base that you can use and build upon.
And you mentioned, so who is actually driving this development, and who is kind of like, how does that work, the decision on like where the development is going with certain, meta layers and whatever it is?
A couple of things. So one thing AGL, we'll get to specific meta layers. One thing AGL really advocated for within the Yocto project, we've been members of the Yocto project for quite a number of years. Jan Simon sat on the advisory board there, and we really advocated for a long-term support version. Prior to a few years ago, they only would support a release for 6 to 9 months.
Yeah.
Now, the Dunfell release has been actively supported for nearly 4 years. AGL we still maintain our own long-term support version, Lucky Lamprey, 14.0.x. I'm sorry, 12.1.x at this point. And basically, whenever the Yocto project releases a new version of Dunfell, within 2 to 3 weeks, we then release a new version of Lamprey.
Got it.
Okay, and then we've done the same thing with the Dunfell version, whereas the Dunfell version has been declared to be a long-term support version. We'll continue to support that as well. So that's one of our big interactions with the Yocto project has been doing that. And then Jan Simon advocated for a lot of work to be done around reproducible builds and the PR serve. And
yes. So we actively work with upstream Yocto. So AGL is also part of the Yocto project CI infrastructure. So beside of our own infrastructure, which we use to test our own code base, our own additions, we also have a next branch that is included in upstream. So we are trying to also look ahead and make sure that even the next version of Yocto, which will become the next stable Yocto release, and we will then use it, that this is already working by the time we start to use it.
Yeah, no, I really enjoyed that. Was on your talk, we were talking about the reproducible builds and the SBOM and so forth. I really enjoyed your talk there. As I think I mentioned this to you, like when I was originally pulled into Yocto, like I thought that's the promise of Yocto is like this reproducibility. But then, like you pointed out, a couple of things that needs to be in place in order to make this happen. And then as well with like SBOM generation, it's like not so straightforward. There are some tweaks that needs to be done. Maybe you can just briefly talk about that.
Yeah. So the Yocto project has strong support for reproducible builds. In short, what does that mean? If you do a build, let's say today on machine A, a reproducible build means that tomorrow on machine B you will get exactly the same binary output. Now it might sound easier as it is because somewhere there might be a path hidden, so you get little differences, a date, And if that slips into the build, then it becomes not binary identical. But that's actually what we want. So Yocto project upstream is now essentially 99.9% reproducible. And we are building on that code base. And we are working towards having our own layers, our own software, reproducible in the same manner. SBOM, software bill of material, is a topic that is more and more important and will become a requirement.
Yes.
So we are supporting upstream in that we have it enabled in our trees. So for our code base, there is an SBOM available by default, and the generation can be turned on with a simple flag. So it is already there and can be reused and produced.
No, this is really good. I mean, you know, when you say bill of materials, you always think about hardware, but like nowadays, based on like all the security problems we had, it's also important that you have like this software bill of materials so you can track and say, okay, I know exactly that based on this software bill of materials that my device has a software that has a security issue, so that we can kind of instruct and then deploy it.
Yes, and that's where an SBOM is really useful, because once you have your binary image, it's hard to track that.
Yes.
And with an SBOM, there are tools that are being developed right now, and I tried a few of these. They let us basically query if our image has a CVE now or tomorrow, and they will give us that information without us digging back into what source code was this, was it patched or not. So this is extremely useful.
As an executive at a company, you don't want to wake up and read the paper about some new amazingly bad software bug and ask your team, hey, is this a problem for us? And they have to spend days figuring it out. Now, maybe. But now with an SBOM, you know, you should know within a minute or two. We don't. Yeah, we're clean, or no, we've got this version and we've got to go implement the fix. And having the reproducible builds will let you more easily go implement that fix, because you can guarantee that your starting point is exactly the same as maybe when you released that product 2 years ago. So I think it's both of those are really
they really go nicely together, because with the reproducible builds, you can say, okay, everything but whatever I had to change is the same, and I can say, okay. You could even say, okay, this is the original SBOM, and we just changed this single element.
Yeah, excellent. And this brings me to this other questions, like functional safety. I mean, when you have that kind of infrastructure and environment that you're kind of building all of that, and you know exactly, you know, what goes into that binary, I suppose that then working against functional safety becomes easier, or?
It's a functional, SBOMs are a really critical part of functional safety, and the effort that the Linux Foundation is making with the Elisa project that AGL is also part of the embedded Linux and safety applications. And so, Kate Stewart's done a really great job of pushing the SBOM stuff, SBDX stuff forward. And now with us having that available, it's really going to be key going forward.
And then what is the process? I mean, from OEM going through this, they had to go through this functional safety. Like, what is the general process? How does that work? What are the actually guarantees from the Elisa project, and how does that work?
Well, so functional safety in automotive is governed by ISO 26262. Yeah. And there's some levels of automotive safety, automotive functional safety, like ASOL A, B, C, and D. Both AGL and the Elisa project within their automotive work group are focusing on ASOL level B, which would be appropriate for an instrument cluster or a telematics unit, right? Not something that's deeply embedded, maybe controlling your brakes or something like that. We've worked through in the automotive working group of Elisa in conjunction with AGL a use case for Telltale monitoring on an instrument cluster. So if your instrument cluster display dies, you can still see if there was a warning light or something like that light is still seen, or if there's a case where that light can't be seen, there's a path that's clear to the user that there's a safety issue.
Got it.
And I'm not a safety expert, and I'm probably explaining that a little bit wrong, but and what we've worked through with the Elisa project so far is you can do all of that monitoring outside of the Linux system. You can do it with a watchdog or with a processor that is basically a safety processor that is sitting outside of the Linux system. We're also actively working on what needs to be done to certify a Linux-based system. But right now, all of the work so far has pointed us towards the safety use cases that we've evaluated. We can satisfy with a watchdog or something outside of the Linux system.
Got it. But the system that's built using AGL and so forth needs to allow that interface or that kind of like that external processor or whatever it is can interact and make sure that the right points are hit, right?
Yeah, exactly. So if you see some of the architecture diagrams that we have in the booth, both with the Elisa project and with our instrument cluster expert group, you'll see that there's clearly a silo where functional safety is isolated and separate from the Linux environment and basically
excellent.
watching over what that Linux environment is doing.
Well, that's excellent. And maybe I think we have a couple of minutes. Maybe we can just briefly chat on like where is the booth and then what's on display there. I know I have a demo there as well, I mean, from AWS. But what are the other ones?
Yep. So you will find us in Hall 4. It's booth 171. And that's the corner towards Hall 4A. Find us there. We have demos from AWS. We have Panasonic. We have AVL and Igalia beside our open source standard demos.
Yeah, we have two demos, AGL demos. One that's
I'm interested in that one to hear more. Yeah,
one that's our famous Green Machine.
Green Machine, yes.
Yeah, and that's basically the bare metal AGL demo. AGL running on the AGL reference hardware, R-Card, Renaissance R-Card H3, and then the instrument cluster running on the Raspberry Pi 4, and they're interconnected via CAN with a steering wheel that's connected to both of them via CAN, and the steering wheel interface goes from the IVI to the instrument cluster. Then we've got a second demo that's pretty exciting that was put together by our instrument cluster team. There, the reference hardware is being used to drive two displays, one for IVI, one for instrument cluster. Instrument cluster is running a Qt version of the instrument cluster in a container, in an LXC container. And in the other one, we've got our Qt, our Flutter, and web app IVI demos running in 3 containers. Now you can only display one at a time.
Yes.
So what we do is we have a little keypad that we wired up.
Oh, I was wondering what that thing is. Okay.
Yeah. So there's a button labeled Flutter, and it'll hit Flutter. It'll tear down the IVI container, and it'll bring up the Flutter container, and you'll see the instrument cluster is completely undisturbed. And so you can switch between the different IVI containers. So it allows us to show both, containerization and, how you can run them in parallel, and also show the different environments that we have for application development and see what you can do with those different environments.
So, I mean, those environments are for the people kind of to build additional applications as we talked earlier. So, showcasing them, and then they can interchangeably. So one day they wake up and they say, oh, no, what? Let's use Flutter instead of Qt. They can do that, right?
Yeah, and what I want to do through this year is we have a KVM version of the demo running instrument cluster and IVI that we showed at CES, but we're not showing here in the Green Machine. And what I'd like to do is a similar thing where we have a keypad and we're basically tearing down virtual machines and bringing up virtual machines. And then you have your choice. You want to use a container system, you want to use a VM, you're good to go either way.
Yeah, Panasonic is having this kind of demo as well, where they have multiple virtual machines. This is a really cool demo. I think we will talk about that afterwards. But I think that we are running out of time. Anything else you guys want to mention, talk about?
No, I think Embedded World's been great this year. It's good to see everybody back. I really feel like the crowds are back to their old timey size.
Yes.
Really excited about this year.
It's meeting with people, after a long break.
Right, exactly.
Yes, exactly. Excellent. Okay, this is awesome. Thank you, guys. That will be it for today.
Thank you, Nenad.
Thank you, guys. Hello and welcome back to Embedded World livestream. I'm Nenad. I'm here joined with Isaac, who's from OpenSynergy, and we will talk about how to develop automotive solutions with hardware abstraction techniques. Isaac, you want to introduce yourself?
Yes, I'm Isaac Trebs. I'm the product manager for our Cocos Hypervisor SDK at OpenSynergy, based in Berlin. Our Cocos Hypervisor SDK is essentially a solution that allows you to virtualize automotive platforms. So do virtualization in the automotive software space.
Yeah, that's pretty cool. I mean, I'm quite familiar with this technology, but maybe for our viewers, can you explain a bit like what are the benefits of that virtualization in the automotive context? I mean, we all know virtualization in like cloud environments, but like what is it? What's the benefit in the automotive?
Yeah. So looking to the big benefit that I want to talk about today is really the bringing the automotive and the cloud together, right? So now Amazon is building a service around developing automotive software in the cloud, so cloud native development. And that's great because you don't need any of the hardware early on in a project, and you can really scale your development activities up. You know, the sky's the limit, right? You're not limited by the hardware availability anymore. And, you know, by providing ARM hardware as the basis for the cloud offering, of course, you get that binary parity between the cloud and the vehicle, right? So now you can run software in the cloud and you can take that software and run it in the vehicle to a certain extent, right? Because you have ARM in the cloud and you have ARM in the vehicle. And we're definitely seeing ARM as being the big, let's say, winner in the automotive space as far as you know, compute power and compute technology goes. But I guess the one thing that you're missing with the binary compatibility is still, if you use the same exact hardware in the cloud, like the Graviton 2 in the cloud, as in the vehicle, then you're gold, right? Then you can really take the same exact software, the whole software stack, take it from the cloud, run it in
Starting
the
from
vehicle.
like a bootloader, Linux kernel, user space, all that stuff.
All
right?
that stuff. But if you want to use a different hardware in the automotive edge, which is often the case because there's a lot of hardware out there, OEMs want to optimize for cost. They really want the hardware that does exactly what they want to do.
Specialized SoC with certain, GPU or whatever.
Exactly, or number of CPUs, or maybe even cost is a factor, whatever. So you want that flexibility to use whatever, let's say, at least ARM-based hardware on the automotive edge that you want to use. And to be able to do that and have exact binary compatibility between the cloud and the edge, you also not only have the CPU architecture and the CPUs, but you have the devices.
Mm-hmm.
For example, the GPU. For example, the block device, input, sound. So that's where our solution comes in, and the solution VirtIO comes in. So let me talk a little bit about VirtIO. It stands for Virtual I/O. It's a technology that is coming from the cloud space.
I was about to say that. That's like a, technology that's been here forever.
It's been here forever since the 2000s, really.
Yeah.
So in our industry, really a long time.
Yeah.
And Amazon, of course, offers some VirtIO devices in the cloud already. The ones that are most critical there, network and block device, which in a cloud setting you would need. So that basically you don't care what hypervisor you use. Any operating systems or workloads can see the same interface for the network and the block device. So that's great, but in automotive use cases, you need other things too. You need to virtualize the graphics. You need to virtualize input, right? Otherwise, you have no IVI system. Sound is a big one. The first car radio came out in 1929, so people expect a car radio, now to have sound, for example.
Yes.
So you need all of these things. So what we have done with the OASIS Open Consortium, which is responsible for this VirtIO standard, is add devices that you need for automotive use cases. So VirtIO GPU for the display and the actual GPU, VirtIO sound, et cetera, et cetera. So what that allows you to do, now we get to the software-defined architecture, which is basically, it really allows you to create a binary workload. And when I mean a binary, or a piece of software that is an operating system and all the applications, and that operating system and the applications, you can just take one-to-one and put them on any hardware, be it an SoC from vendor X, Y, or Z on the edge, or even the Amazon cloud. And the way you do that is you provide in a virtual machine an implementation, which is nothing more than a bunch of applications that broker between the VirtIO interface and the actual physical hardware of the device, right? So you basically serve up in a virtual machine a VirtIO interface to all of the other virtual machines on the system, right? So now, since another guest running on that system only sees VirtIO, they don't see any other hardware driver, now you can take that operating system and run it anywhere where there's a VirtIO implementation, right? So that's really cool. And now you may say, well, what operating systems support VirtIO? And currently any Linux operating system is going to support VirtIO, because VirtIO is the VirtIO drivers, which, if you will, are the VirtIO clients, the ones that consume the devices served.
There's like a backend.
Exactly.
Well, right?
So what we've put into the Amazon cloud and also on the automotive edge are essentially the VirtIO backends. Right?
Nice. It just occurred to me, like, there could be, like, when you're testing this as a backend, you can have like some data in S3, and then you can have like a Lambda function that provides this to the VirtIO backend driver, so you can test your application starting from like a kernel space and application. All of these things that you can simulate quite nicely. Yeah, that's pretty cool.
Exactly. So that's what we've done, and we think that VirtIO is the best abstraction to use because it's a standard. As you said, it's been around forever, and the industry has really jumped on top of it. And we're also seeing a lot of traction now. In the cloud space anyway, it's established, but now we're seeing a lot of traction now in the automotive space. For that. And really what it does is it allows us to get to that software-defined architecture where it is what it says, nomen est omen, right? where now the software defines what it is, right? It used to be you picked out a hardware in the automotive space, and then you had to kind of get the software that went along with that hardware. But now if you decouple the software from the hardware, you can pick the software, and now you just need to get the hardware that that gives you the compute power that you need. And again, getting back to the Amazon cloud, now you can also develop that hardware, you can develop that software, let's say 80% in the cloud, and just move it one-to-one over to the automotive edge, and it will run. Now, of course, you still will need to do some final validation for things like a timing behavior, which will be different in the cloud than you would have on the automotive edge. And of course, you always have to do in our industry the final validation in the car, otherwise nobody believes it.
But 80%, as you said, is like a big chunk of it, right? So it's easier to focus and make sure that that works properly and test it out before you get it to the hardware, and then focus on those 20% and tweak it and so forth. It reduces the time. So, I mean, from that perspective, having like different iteration cycles, and I think we talked this even before, like you have mechanical engineering that goes into the car. It's like iteration cycles are in years, electrical engineering, hardware engineering, like all that is like measured months, years, and you can do this like board support packages and the system that engineering that is maybe measured in months, but now you're like focusing and allowing these iteration cycles to be even reduced, and then allowing people to develop software and measure it in like weeks, right? Because of this.
I mean, it's definitely going to shorten the cycle, because all you have to do is go to the cloud, drop your software in there, any VirtIO operating system, for example, automotive grade Linux or Android. There's a launch target called Trout, like the fish, which is made for VirtIO. So you can take that from AOSP, you can drop it on the cloud, and you can start your development. And you can make your modifications, and you can deploy them directly to the automotive edge target. And we have that solution running at our booth here, the other end of the hall, where we show an automotive grade Linux, the same exact automotive grade Linux, and you can change the color of the clock and then beam that to the vehicle, and it's instantaneous. So it really decreases that round trip cycle, and it's going to decrease.
I saw that demo. It's like you have like a Cloud9, and then you have like a CI/CD pipeline. Well, Cloud9 is like just an IDE in the cloud, right? And then you have like you revert the commit or something, a Git commit, and then basically you build a new image throughout the CI/CD pipeline, and then the device picks up that image instantaneously, changes, and you can reflect the changes. Basically, you see that in the clock color or something like that. It's like amazing. Yeah, it's amazing. And then you use this. So this is in the cloud, but you use the same binary and then have it on the device, and then kind of like see the changes there. That's Yeah, and
you can see in our demonstrator, really, if you look at the build string, that it's exactly the same. So the binary is bit for bit, one for one, exactly the same thing.
Yeah, I can just think about like functional safety and certification. Like if at least that piece, it can go through the testing in the cloud, that piece is kind of like working as expected, and as you said, focus on this 20%. But I mean, is it all great? Like, are there any like limitations when it comes to VirtIO?
There are a few limitations. So the VirtIO standard is evolving, and we're pushing it. And the more help we get, anybody can get involved in the Oasis Open Consortium. But there are some gaps right now. So machine learning is still a piece that is missing, that is, let's say, under work. So you see with autonomous driving, there's a lot of machine learning going on. These automotive edge devices have often machine learning accelerators to do like neural networks. So that's a piece that's missing still. Access to trust zone trust zone is still something that is not standardized. Everybody's doing their own thing. So some of the newer use cases like watching Netflix or Disney Plus, this digital rights management are still under work, I would say. So that's maybe a bit of the 20% that you can't get in the cloud right now. Also, you mentioned functional safety, the timing behavior, so you can do all the functions, make sure that your functions work. The timing behavior is also something that, of course, you have to do on the actual embedded edge, because it will be different in the cloud.
Yeah, no, this is really interesting. But I mean, what are also the costs, like when it comes to like developing this? How do you calculate the cost of compute and performance? and how you pay all this.
So essentially, by putting this VirtIO layer in there, it is what is called in the virtualization lingo para-virtualization.
Virtualization, yeah.
Right, where basically, an operating system doesn't talk to the real device, but it's talking to another virtual machine that is talking to the real device, right? And so that does come with a performance hit, but the performance hit is pretty small because you are essentially, your control plane is definitely going from virtual machine to virtual machine, but your data, you don't transfer. For example, if you want to draw a graphics buffer every 60 seconds, right?
Yeah.
That data isn't going across as, you're not pumping that data between virtual machine and virtual machine, but you're essentially pumping references to the memory, and then the memory is imported directly into the device using what's called a DMA buffer for Linux wonks out there.
Yes.
So essentially, you're just putting memory references going between virtual machines. So the overhead, is quite small because of that.
Yeah, I remember this demo as well, where it's like a shared GPU through VirtIO. You had like a couple of screens, and then all of those screens were actually connected to different machines or different SoCs. But then there was the one that had a powerful GPU, and then I think this was shared via the network.
So you can do that as well with VirtIO. You can also share devices from one device to another. In fact, you can even take that so far to say, well, I'm going to render my operating system, my Android, in the cloud. And now I'm going to pump it via VirtIO into the vehicle. That's something that could come into the future, where then you really wouldn't have to worry about all this update and deployment of the vehicle. But if you want to update your hardware, your software, you just update it on the cloud, and it's instantly deployed at runtime to the vehicle. So that's something you can do. But also in the vehicle, you could have, for example, a device that maybe has a lot of compute power but doesn't have a good graphics power, maybe a central computer, and you could then pump the graphics data over VirtIO to another device with a powerful GPU that will then render it maybe to the driver, that game, or that that navigation visualization that you want to show to the driver on a device that maybe has less compute power but a big powerful GPU. So it really opens up all kinds of doors to new architectures and to the software-defined architecture. You're not so worried about the underlying hardware anymore, but it's really about the software and what is the software and what are the needs of the software, and that's the hardware that you need to deploy, but not the other way around.
So what are the VirtIO drivers, as you said? You've seen. You said sound, input, GPU. You mentioned machine learning, so I guess this is like a different type of. What is it, NPU or something that's
yeah, so these are often called, NPUs, like neural processing units, or I've heard also CDSP, like compute DSP, used for these units that are coming around. So, VirtIO machine learning would allow essentially, I guess, like an Android to seamlessly use, machine learning for its machine learning algorithms, which of course are becoming more important even in the IVI space. For example, you may want to identify the driver to personalize the system, or these kind of functions, or drowsiness warning is a big one, right? Is the driver falling asleep? So these are the kind of use cases where you would need machine learning. Other VirtIO devices that are out there is a random number generator, which is trivial, but you need it to run. Android won't run without it, for example.
I remember that.
So those are the big ones. Yeah, basically the ones that you need for automotive use cases. We also have one called, based on the ARM standard, SCMI, which is a standardized way to provide sensor data to a virtual machine. So, for example, the accelerometer, these kinds of things, the gyro. So, you can go to oasis.org and look at the current standard, and you'll see there's a whole bunch of devices there.
Nice. That's pretty cool. Excellent. We are close to the end, so anything else you wanted to talk about that we didn't cover?
No, I guess just to call out to the industry out there to really, keep going in the direction of VertIO. You know, when we started down the road of VertIO, we were really looking at it as a way to abstract away the edge hardware, and then the opportunity with Amazon came along
accident,
to move into
right?
it was
Like,
kind of
yeah,
by
we can
accident, like
use
this whole
yeah.
use case of, wow, we could actually use this to shorten development cycles and really take away the headaches that any project manager has at the beginning. Where would I get prototype hardware?
Yes.
I've got an army of developers and they don't have hardware, or the fights over boards that you have. For example,
like
2 more minutes. I mean, for example, on Android, you'd like to run the compatibility test suite. It takes like a day. So, run it in the cloud. You have unlimited compute power there.
I remember in the office, it's like, there was 2 boards prototype coming, and we were supposed to do the board support package and like bring it up and all that stuff. And then it turns out like both of them had a faulty memory, and then it's like, oh, okay, we now need to wait for 3 more months.
Exactly.
We couldn't start development, right? So yeah, it's things like that. That's pretty cool.
Yeah. And I'm assuming the Amazon cloud won't have a faulty memory. So really, yeah, as a kind of a final, the message that I want to put out there is really the marriage of VertIO and the Amazon cloud for automotive to really shorten those development cycles, to really get these systems developed and seamlessly deployed to the edge. And I think it's going to revolutionize the industry.
Yeah, definitely. With this, as we talked about, this SDV, software-defined vehicle, which still we don't know the proper definition, but it's going in this direction.
Yeah.
Definitely.
So again, our definition is basically abstracting the software away from the hardware, so that the software knows as little as possible or nothing about the hardware, so that the hardware is there to serve the software and not the other way around.
Excellent. All right, great. It was a pleasure talking to you.
Once again. Yes.
Thank you so much for coming in. Yeah. So thanks everybody. That was it for this session. Bye.
Bye.
Hi, thank you for joining us for this session where I'm joined by my guest, and the session is with PHYTEC. PHYTEC SOM for rapid development of cloud-connected industrial machines. So, True?
How's it going? Hey, everyone. Yeah, my name is True Lone. I'm an applications engineer with PHYTEC America. I'm over here representing PHYTEC America, meeting up with our PHYTEC colleagues here in Germany. So PHYTEC actually manufactures all of our products out of Mainz, Germany, and that's where our company headquarters is located at too. So happy to be here at Embedded World.
Awesome. Great to have you. So, give us a short snippet about what actually is PHYTEC. What do they do?
Great question. So PHYTEC's real bread and butter is system on modules, or SOMs for short.
Yeah.
So if you're familiar with integration of processors into our embedded and connected world, IoT, so processors typically will, one processor chip, accompanied with some RAM, power management, some flash memory. What PHYTEC does is we take all those integral pieces to an embedded system and we modularize them onto a PCB that's about the size of a credit card or smaller. And we put high density connectors that allow you to interface that module into custom carrier boards. So the idea here is you can increase or decrease the time it takes to deploy a new and novel embedded system by just reusing a well-defined and verified core compute module, which is the SOM, and share that across multiple designs. Thus, you can leverage PHYTEC's previous knowledge and skip DDR layouts, essentially shaving 6 months to a year off of your development timeline by reusing these well-known circuits from PHYTEC.
Awesome. So, give us a snippet. Tell us to our viewers. I mean, I know what SOM is. You know what SOM is. Mm-hmm. Let them have it.
Yeah. So the system on module is going to come in multiple form factors depending on the processor. Today, we're going to talk about the 5-core AM64X. This is one of our latest and greatest system on modules. Generally, they're going to incorporate an ARM processor. This one is a 64-bit ARM processor from Texas Instruments. They typically will come in very high-density connectors, or a direct solder connect, where you can essentially use a pick-and-place machine to drop these compute modules as a individual component during your pick and place assembly production, SMT production.
So if I understood this right, for the benefit of our viewers, having a SOM, right, basically gives you the flexibility to actually pick and choose, because obviously we knew there was a shortage of silicon a while ago, right? Mm-hmm. And right now, if you're basically building a product, right, and if you don't actually need Bluetooth on it, all you need is just basically maybe GPS or maybe a Wi-Fi and stuff like that. Mm-hmm. This is where you will say, okay, you know what, I'm going to go ahead and build it, but I just need those 2 modules. And that's what I want to go for. Is that where we're getting to when we're talking about SOM?
Yeah, well, you can essentially look at our product portfolio and choose, okay, here are my application needs. If you're designing a new product, I need Bluetooth, I need Wi-Fi, I need X, Y, and Z. Yeah. You can look at PHYTEC's SOM portfolio and essentially choose from a list of processors that give you the interfaces you need, the capability, the processing power.
Yeah.
Certain SOMs will support like up to 4 gigabytes of RAM, but that won't be necessary for everyone, nor would it make sense from a cost standpoint.
Yeah.
So you can essentially choose the configuration of the SOM that works best for your application. Yep. And you get to skip having to design it all. PHYTEC will also support Linux by default, so you'll get a Linux kernel to start from and schematics to use as reference. The carrier boards that actually plug the SOMs in, those are schematics that we provide to our customers, and we fully encourage our customers to copy and paste known good circuits. Yeah. Again, to underline what PHYTEC is all about is accelerating that development timeline and getting your products to market faster.
So, you talked about SOM, right? And you also mentioned, one of the questions would have been that, okay, what are the benefits to users? You just already mentioned it, right? Mm-hmm. Yeah. So, and you also mentioned AM64 SOM, right, for PHYTEC. Tell us a little bit about its feature sets.
Yeah, great question. So the 5-core AM64X system on module incorporates that AM64 SOM SOC system on chip from Texas Instruments.
Yeah.
And that particular processor is really well suited for industrial automation.
Yeah.
So it has many real-time cores, which are kind of labeled as PRU ICSSG. So these real-time cores are actually dual-core programmable real-time units, and you have 2 of those. So essentially 4 highly capable, super high speed real-time cores that you can bit bang pretty much any communication protocol you'd want.
Yeah.
Our standard Linux offering can enable gigabit Ethernet on each of those, so you can get up to 6 gigabit Ethernet ports on one 5-core AM64X SOM.
Right.
And then we'll get into this a little bit later as well, but we can also do real-time industrial Ethernet protocols for motor control, and that's probably the industrial cloud-connected factories and industrial machines.
So we had a discussion where we talked about that you actually have offering where we have a cloud-focused product for PHYTEC, and one is a non-cloud-focused product. Tell us a bit more about those two things.
So actually what we've done is we built a demo around the 5-core AM64, and we've leveraged the Texas Instruments in MCU Plus SDK, which is their RTOS offering. And what we can do there is we can use their pre-integrated industrial Ethernet stacks to enable EtherCAT, Profinet, and Ethernet IP. These are very common industrial Ethernet protocols deployed in factories across the world.
Okay.
What we can do there is we can enable those industrial Ethernet protocols right out of the box on these system-on modules, the 5-core AM64 specifically. And then we can make machines that leverage real-time motor control. So our demo at the PHYTEC booth here at Embedded World, actually, we have a machine that draws pictures, and we have multiple axes of motor control, very much like a 3D printer. It's a pen plotter, and we are over-engineered it a lot, and essentially we're leveraging EtherCAT to pass G-code between the primary controller and a secondary controller. The secondary controller essentially handling all real-time control, and then the primary controller essentially runs Linux. And so it's kind of the high-level controller for the real-time system. And what we did in the second stage for this demo is we also integrated AWS IoT Greengrass,
right,
enabling our real-time systems to communicate data to the AWS cloud, where we can then generate metrics, visualize the performance of our system in a time series database, and then we can trigger very optimized maintenance with informed data.
Nice, very nice. So you mentioned AWS IoT Greengrass. We actually have official AWS IoT Greengrass workshop. The link should be on your screen right now, and it is greengrassworkshop.com. So go ahead and learn about Greengrass over there. Coming back to your demo, right? People who are actually not here on Embedded World, you mentioned there are two types of demos you have done. One is cloud focused using EtherCAT. The other one is non-cloud focused and then cloud focused, right? So EtherCAT, this is where I think we're talking about industrial machines connecting to these devices and basically sending data locally at the edge.
At the edge, yeah.
Yeah, and carrying out the compute as need be. Okay, and people who are basically connecting to the cloud, this is where, you know, the demo you're talking about will basically have AWS services connecting to the cloud, such as AWS IoT Greengrass, sending the data, computing at edge, and probably even carrying out machine learning inference at edge, and then obviously sending the data to the cloud for business analytics purposes and whatnot. Right. That's really good. That's really good. So let's talk about any evaluation kits do you guys have, or any development kits you have, which our viewers can obviously buy, where they can get started having the SoC, where they can obviously start putting in Greengrass and get going on the real hardware.
Yeah. So the 5-core AM64X system-on module, the SOMs by themselves don't have what's necessary to actually boot and run Linux. You would need a baseboard to provide power to these things, and then also bring out the I/O to, you know, your Ethernet jacks, the RJ45 jacks, USB connectors. So really, the carrier board has to be used in tandem with our SOMs.
Yeah.
And we currently have a development kit. That's how we kind of brand our carrier board plus SOM packages. It's a development kit to help you get started integrating your SOM into a custom system. And like I mentioned before too, we provide the schematics for those, where you can copy and paste those carrier board schematics, leverage PHYTEC's known good circuits, and then you can design your own custom carrier board where you could add a few more features, remove features, and cost optimize, and bring your SOM into your product that much quicker. To clarify too, we did one demo, and we did the real time on one side, and we incorporated cloud on top. And that the advantage there is AWS IoT Greengrass is very easy to support in embedded Linux.
Yeah.
And so by adding AWS Greengrass, we're able to connect our local real-time Ethernet network to the larger network in AWS Cloud. And so we can generate those metrics like you mentioned. And another cool thing that we have yet to do on the demo, but we could, and I've actually tried it out myself, we could push over-the-air updates to our projects. Right now, there's only one or two plotter. It's called the PHYTEC pen plotter, this demo, by the way.
Yeah.
We could manage a fleet of them, up to thousands, millions with AWS IoT Greengrass.
Yeah.
And we could push updates to improve functionality or change functionality. In the case of our pen plotter, we could change what it draws from the cloud.
Yeah.
And which is a really powerful feature of Greengrass. And if you get a development kit, we have a quick start to get started with booting into Linux, and we also have a guide for getting started with Greengrass. Actually, the FiCore AM64X System on Module and Development Kit is a Amazon partner device, a certified device. So it's actually currently present in the partner catalog with AWS.
Right.
So yeah, you could get started with AWS Greengrass on our development kit right away, right out of the box.
That's pretty awesome. So let's put in perspective, right? You talked about you're thinking of basically building a demo where we're talking about over-the-air update of your components, right?
Mm-hmm.
So if I'm understanding this right, when we are basically doing Greengrass updates, we obviously have AWS IoT jobs, which obviously updates the Greengrass nucleus and other components, right? So when you're doing the over-the-air update, are you basically utilizing the benefits of AWS IoT Greengrass, triggering the jobs, which is AWS IoT jobs, taking the package from S3 bucket and basically downloading it and pushing it on? Is that the process you're referring to?
Yeah, exactly. So we could store Python is very easy. I think there's demos with AWS Greengrass and leveraging the S3 buckets for storage.
Yeah.
And then the whole layout of the suites that we've used for this particular project. So we have that demo in S3. The IoT Greengrass core on the target actually communicates MQTT, encrypted MQTT messages out to IoT core, where we have some rule message routing rules that send that data to an asset in Sitewise, where we can model our project and then of course maintain like an organized database of many devices in a fleet. And then we could connect that to TwinMaker and have a simulated digital twin of our systems. And then we can visualize all of them in AWS managed Grafana as well. And we actually have that running. In case you're not at Embedded World, we have the visualization and the digital twin present at the PHYTEC booth. And you could see real-time temperature data, and you could extend that to motor positions, vibration, to kind of get an insight on the system health, and then have optimized maintenance on those systems.
Awesome. So if you're in Embedded World, do check out the PHYTEC booth. For those of us who are actually listening and wondering what is actually AWS IoT jobs, how would I get started? There's also another workshop, and the domain name for the workshop is getstartedwithawsiot.com. That workshop basically will take you get started by using AWS IoT device client. We will walk through by setting up jobs, how you can basically do updates on jobs, follow the process, the mention we talked about earlier in terms of how to do update of components and so on. So do check out that website as well. So I guess we are heading towards our end of time here on this session. I love the enthusiasm. I love the energy here, which you brought in here.
Thanks, Ed.
True. So you mentioned about pen plotter, right? So how can our developers and IoT builders out there who are listening to this, how can they basically get started by using these demos or pen plotter or similar demos like that?
Mm-hmm. So you can purchase that development kit right, like a shopping cart style, right on the PHYTEC.com. And once you get a development kit, just follow our Greengrass guide to get started. And then from there, if you have any trouble, you can always reach out to me. I man the support portal at PHYTEC often, and I also do custom software and hardware integration for our customers. So I'm very experienced when it comes to meeting my customers where they are and helping them get started with any type of development, whether it be a new project and starting at specification, or if we're going all the way out to a legacy product and we're doing lifecycle maintenance, second source components, upgrading your systems to better functionality. These are all things I get involved in, and I'd love to help.
Very nice. So here we go. So this is where, you are actually personally offering all our developers, builders, IoT builders, and listeners and viewers out there that you have direct line support to True over here. So I guess that question just popped up. I know I said it's the last question, but one more question popped up into my head, is that when we are actually using SOM provided by PHYTEC, right? And what sort of support can our viewers or builders, IoT builders, can expect when they buy the product?
So one thing that PHYTEC is always all about is top-notch support. So when you purchase a system on module, we'll encourage you to actually copy and paste those circuits to implement the SOM into your own custom design. PHYTEC does free schematic reviews to ensure that when you go to production with your custom carrier board, you have as few respins of your carrier board as possible. Again, kind of ensuring that you get that product to market as quickly as possible, shaving development time off.
Yeah.
And then from there too, PHYTEC preemptively will do lifecycle maintenance on the SOMs. And and we also do design services too. So if you have us design your carrier board, which we can do for you as well, we would do the lifecycle maintenance in the case that we have a die shrinkage. If let's say some flash memory goes EOL and you need a compatible replacement, we'll identify that replacement, and we can also do the software integration to ensure that your product stays on the shelf and you don't have to skip a beat when collecting revenue with your novel and new product. Yeah.
There you go.
One-stop shop. PHYTEC.
Yeah. So there you go. The buck drops there. So I guess the question you just came back and you just basically gave me another question to ask you.
Oh, hit me.
Is that
I love it.
We're talking about schematics. So is there any open source schematics or open hardware schematics where basically our developers and builders can look at it? Because I know there's a lot of embedded developers out there who have usually 3D printed machines, right? And they might actually just go ahead, use the schematics and build one themselves, right? So is there a portal or GitHub or any open source repository where they can basically, you can point it to them and say, okay, have a look at that, get started with that, and boom, you can print it.
Generally, with how PHYTEC manages the schematics, we'll provide you those all the schematics, the SOM, the carrier board, once you purchase the development kit.
Yeah.
So we will provide those with like a restricted user agreement. We don't want to share those freely online because that's kind of our IP. But again, we want to enable our developers, our customers to have as much success as possible. So we fully share those with anyone that purchases a development kit. You can just buy one and make a prototype of something cool. We'll give you those schematics and we'll support you in that.
That's awesome.
It doesn't matter if you're buying 1 unit or 10,000. We like to treat all of our customers the same. And the advantage of a SOM is when you buy one SOM, you actually get pooled with the other customers purchasing that same configuration because they're shared parts of the same system. So effectively, all of our customers look like one big customer when PHYTEC places an order with our silicon vendors like Texas Instruments, NXP. In this case, with the PHYTEC pen plotter, it's a Texas Instruments SOM silicon.
Yeah.
And so we fully enable our developers to get started. All the Linux source code is open source. So that is available on GitHub.
Yeah.
But we'll provide those schematics as soon as you buy the development kit.
That's pretty awesome. So technically, buy one development kit and obviously get hold of the support and the schematics to get going and obviously start building. Any final questions or any final comments to our viewers?
What do I want to say? Well, at PHYTEC, we embed your ideas and, get started with a SOM, get your product to market very quickly.
Right. Awesome. So with that, I hope you enjoyed the session. You stay tuned for more sessions. And for now, goodbye. Good job.
Thank you, Syed. That was so
Hi, IoT Builders. We are back from Embedded World 2023, and we are live here at the AWS booth. I'm looking forward to this very nice and interesting episode with Joseph here, and we're going to be talking about embedded Linux system updates and using Mender. Hi, Joseph. How are you?
Yeah, I'm fine. It's been very, very busy, so I'm super glad that you found the time and occasion to invite me here. So I'm very thrilled too. Thanks.
Very nice. So, nice hat, first of all. Really charming, looking on camera as well. So, yeah. So tell us a bit about your role at Mender, Justin.
Okay, so my background is actually completely non-Mender. I did embedded systems, industrial controls for 15 years. And from there, I grew into like the embedded Linux ecosystem. I did a lot of Yocto. I grew there. I was finally ambassador, and it turned out I wanted to talk to people. And from there, I went to Mender as head of developer relations. And that's why I'm here to you. And we're talking.
Very good. Very good. So you're at your best in your element, and we love that.
Hopefully.
Yeah, for our viewers, if you have any questions, please feel free to leave them in the comment section. And now I'm going to ask Joseph about firmware upgrades. So, what is a firmware update, and how is it different from an application update, and what do we as developers need to be careful about?
Okay, so the main thing about firmware or system updates is that you literally replace what the system consists, like kernel, device tree, sometimes even bootloader, usually the whole file system. And if you're doing that, you can break a real lot of stuff, as opposed to things like application updates, where you sometimes just replace one statically linked binary, a directory, or an archive of assets. And that's where the big difference or distinction is. I wouldn't say it's completely clear cut. There's a lot of variations in between. For example, if you're updating a container or something like that, it happens a lot in embedded by now. But I'd say the system updates are really at the lowest layer and therefore require an extreme high amount of robustness.
Okay, so what is robustness? I mean, why do we talk about it?
Robustness means that your device is still functional, even if something goes wrong. I mean, we've been doing embedded for quite a lot of time, and we all know the term bricked.
Yes.
And I mean, I love bricks if I'm building a house. But if I'm building like IoT, then bricks are not exactly what I want. And a bricked device, I mean, that's engineer slang, and it means that your device is as useful as a brick. And this happens when your update goes wrong. And a robust update avoids this by having a partitioning scheme, usually like AB updates. It keeps the last known good state, does the update. If something falls over, then the mechanism can detect it, roll back, and therefore you have a still functioning device and not a brick.
Okay, I see. So is this something that only devices take care of, this AB partitioning, or does Mender have something also in that space?
So I'd say it's mostly the device integration. It depends on the device. Mender uses it, but in order to actually have Mender use this capability, you have to prepare it. This is why integrations for this kind of updates are so crucial. It is not just installing a client there, because like apt-get install Mender. No, sorry, then you just have like the non-robust version. This is why system updates require integration into the firmware architecture, usually at the bootloader level, to be able to do the flipping and the partitioning. And this really applies to all kinds of devices that do this, ranging from microcontrollers up to the highest powered embedded Linux boards. If you want this robustness, you have to take care of this.
Okay, I see. Okay, so how does the device management decide what device gets the update and how devices get the update?
Okay, the main point about this is the device inventory. Device lifecycle management, I think the key word here is management. And in order to manage something, you need to have information about what to manage. In updates or in OTA, this is called the device inventory. This is not only for Mender. I think this is a universally known term by now. Okay. And in the device inventory, there is all kinds of information about the state of the device. This can be very simple, like a geographic location or just a version number. It can be very complex, like a time zone, Beta channel activated, yes or no, how much space is left, what version of the bootloader is running. And based upon that, the management engine, the backend decides, okay, these are the devices that really should get an update now, or later, or maybe after staging. So it's the matching of information from the client to a bigger strategy, and that happens in the backend and not in the client.
Okay, I see. So this kind of data that you're talking about, that's what machine data is, right?
Exactly. I usually call it machine data. You might also call it device data, management data. It really doesn't matter. The important thing is that you understand that there are two kinds of information. There is information about the device itself. If we are talking about just an embedded Linux device, these are the metrics or the data points that I just mentioned. If it goes one step further, it might also be like the manufacturing year of the machine that it is actually in or such, but it is relatively static information that you need to manage the device, as opposed to dynamic or highly dynamic data, which I usually call process data. Because as we know, IoT, it's of things. It's not just about the internet, it's also about the things that we actually control. Nobody builds an IoT device just for the fun of it. Most of us build IoT devices in order to actually do something useful. Example is a heating control system. Your heating control system, it actually consists of pumps, of a heating chamber, of valves and everything. And the state of this physics, of this process, is something that does not relate to the device management. It is actually the process. It is dynamic data. The temperature is going up or going down. And this process data is something that should go somewhere else. It is a completely different thing. And this is where actually Mender then hands off or interacts with other partners.
Right. And this is a perfect transition for us to thank you very much, Joseph. Really appreciate it. You're making my job here really easy. It's great. So now let's actually talk about this processing data, right? This process data. So how does this data get into AWS, for example? So imagine that I want to build a solution showing the dashboard with a nice chart about the temperature device. And how do I do that?
Okay, so in the classic sense of the meaning, you would sign up for AWS, then you would register your devices there somewhere, then you have like an example that means run this MQTT client-ish thing to push data into the cloud. But this does not correlate in any way to the management data, and this is where an integration really comes in. And guess what? We have such a thing for AWS, and it means that the flow is you just set up your Mender device as usual, and you register the Mender integration with AWS IoT. That's really just two snippets that you have to put into the management there. It's, I think, a role for the permissions to create objects and register and deregister them. And you have to take the secret back to Mender in order to actually authenticate. And from there, when a new device gets registered to your account, Mender automatically creates the device on AWS and takes the certificate and the ID string back to the device, so your application can directly look at this data and start pushing data straight out to AWS, usually through MQTT, as far as I know.
Right. Okay, so that's really cool. So this means then any kind of system update, Mender takes care of it. Any kind of processing data goes into AWS based on this seamless integration that is possible.
Exactly, and that's where the mentioned dashboard or the visualization and even the value of an IoT application is then created, because the management data that I just mentioned, it is interesting for the device manufacturer, but not for the end user. End users do not see fleets. End users see the value of their own application, the heating as it goes up and down, as it makes your home warm, and it saves energy or something like that. So this data is going through AWS, for example, and there you create your dashboard. Example, you pre-process and ingest the data by time stream, and from there you have a classic time series visualization, either something custom, or if you really want to get up to speed as quickly as possible, you go with Grafana. I mean, it's battle proven and it just works.
Right, exactly. Really cool. So for developers who would like to get started with AWS IoT and Mender, how would they get started? Like, where do they find some material? How does it go?
It works like this. You sign up for Mender. We have got a trial that is super generous because you get 10 devices for a full year, and we ask no questions how many updates, how many things you do. You just go for it. And then 2 clicks later in documentation, integrations, there's how to set up with AWS, there's screenshots. It says exactly, put this permissions in there, because I literally tried it last week to make sure it really works, and it does work. And then you're good to go. I think if you have like some experience in embedded, it should take you no more than 20 minutes until your object shows up and you can really start pushing code out.
Wow, really nice, cool. So I see you brought us a little present here today. So you've got some.
Oh, okay.
So.
I have to say, 15 minutes back she said, I can show it. Now it's a present. but Alina, you can keep it if you really want.
You know I can't say no to this, so it's like.
Okay, no, this is really one of the super new and shiny things at Embedded World today. I'm pulling out one time. So this is an ESP32. We were talking about embedded Linux quite a bit in the beginning, about user lands and kernels and everything. And yes, this is where Mender comes from. Our roots are in the embedded Linux space, and especially my roots too. But you know, sometimes people step up to you and say, I can see this being useful for something else. And this is what happened here. A very enthusiastic, young, energetic guy. He stepped up to me and said, like, I like Mender, but I think I can also make it work on an MCU. And I said, like, that sounds great, man. What do you need from Mender to make it work? And he said, like, oh, actually nothing. I just wanted to tell. And 2 weeks later, I got a mail, and he said, like, oh, Joseph, now I've got it working. And I said, like, man, that's awesome. Are you okay if I show it around, if I give you praise? And he said, like, well, I'm rather shy, but actually, so Joel, this one goes out to you because you made it possible that I'm here in the AWS booth showing the first client that deployed Mender-powered updates to FreeRTOS-driven device.
Very good. Yeah. So, so what I hear from you is that it's easy to integrate, it's easy to configure. If you've got some embedded background, then great. If not, you know, you will learn by doing it.
Very much so.
Very good. Well,
and if you're stuck, then you kick me, because then I obviously did a bad job. Yeah, seriously. I keep telling people that I'm such an easy go because I have so many weaknesses, but I try to do better, which means I try to help people. So if you run into problems, either with the integration, with Mender, with the ESP, or if you just want to talk to people for no good reason, you kick me and we'll set something up, I would say.
Very nice. Yeah, so, I mean, we do have a little bit more time, so I'm not going to let you go yet.
Okay. Now comes the fun part of the interview, right?
Yeah, definitely. So, I mean, I do want to talk to you a bit more about the developer journey, right?
Okay.
So, what is the developer journey to put in place a firmware upgrade? Let's say we have 10 devices. No, let's say we have 50 devices.
Okay, 50 devices.
50 devices, yeah. How do we do it?
Okay, now because that takes you beyond the standard like trial. So if it's you specifically, your personal developer journey, then you say, Joseph, please give me a good account for it.
Okay.
Okay. But the general developer would probably just we have a relatively big list of supported devices that gives you integrations for all kind of usually Linux-based boards that you can just grab straight off GitHub and build for it. You should have a little bit of Yocto experience. Okay, but you just run that build, put it on the board, and then story point 1 achieved. Then you change something, do the second build, and then you already have everything that you need that needs to go to the board. The last thing you need is the Mender account. As I already said, the trial is out there. If you have 50 devices, then I'm really sorry. You will have to get out your credit card and sign up at least for the basic account, because somebody has to pay me, which means hosting is our business model. You asked for it. Okay, and that's how you get to 50 devices. But then you're good to go. Essentially, have an account and have actually a starting image, and also have something to deploy.
Right.
Because you can't do an upgrade if you don't have anything that actually is the upgrade.
Yeah.
So if I can add one last step to it,
Sure.
because that is really step 0, then the step 0 is head over to the booth there, which is the Yocto project, and make sure you really understand what embedded Linux is about. Because embedded Linux is everywhere. It runs this planet, and the planet just doesn't know about it. And yeah, seriously. I mean, I have got a list on my phone, which is semi-public, that tells you where Yocto area is. And I know of coffee machines, I know of air compressor stations, I know of medical stuff, I know of cars, I know of industrial lights, I know of heating systems. It is everywhere. And you really can make a difference for your career and for your company if you understand that embedded Linux is not just grab Debian and put it on a device and then hope for the best. Embedded Linux means, and IoT means, maintenance. That is the stuff that really sets us apart from desktops and servers. Because a server you roll out and then it's there, and the software goes like a general purpose way. In IoT, the stuff has to not live for 5 years. It sometimes lives for 10 years. It lives for 20 years. I personally have seen devices that have come back after 25 years in the field, and they were still functional. And this is where it really sets us apart, by understanding the demands of this industry, that they are fundamentally different, and they need a different mindset in order to understand and actually maintain properly. This is how you really can provide value to you, to your career, but also to your customers. And I would say, and I hope we all agree on it, that partners like Amazon on the one hand, Mender on the other hand, and of course the bigger embedded Linux ecosystem, they really make this possible.
Right. So thank you very much.
Thank you very much too.
Do you have any last words? I mean, I know you've said a lot, but what's another piece of advice for the developer community out there, other than learn Yocto, understand Yocto, and visit the booth, the Yocto booth, if you're at Embedded World? What else?
Have fun.
Okay, that's good. It's good.
I think that's the most important point, because as we all know, nerds and especially programmers, they are all just like kids that are a little bit older.
That's true.
So don't forget to have fun with the stuff, even if it's boring and industrial.
And I'm going to keep my present that you've
Of course.
said so nicely. quickly, give me my bag.
That's it, I would say.
All right. Thank you very much, Joseph. It was a pleasure having you here, like always. And yeah, to our IoT builders out there, tune in. We are going to be live again really shortly.
Hi, welcome back. So in this session of today's session, I'm actually joined by Joseph from ClickerTech. You guys already know me. I'll just give a quick intro myself. I'm Syed. I'm a senior developer advocate. Joseph, tell us a bit about yourself.
Great. Thank you. Thank you for having me here today. So I'd like to welcome the audience to the AWS Device Defender Framework IoT Solutions presentation at the IoT streaming event here at the Embedded World event in Nuremberg. I'm Joseph Zolliker. I'm head of business development and global alliances at ClickerTech. ClickerTech is an advanced consulting partner. We focus on IoT, big data and analytics, and DevOps.
Yep.
And today we'll be talking about how people and how our customers can actually use Device Defender, right? And the framework that's been developed to validate IoT devices, to provide really reliable and secure connectivity with AWS IoT Core before you put those devices into production.
Yeah.
So ClickerTech, we are roughly a 300-person team of mainly 85, 95% all developers. Our primary objective when we work with our customers is really to aid clients in terms of how they integrate technology to solve their business objectives. The team really possesses a lot of the capabilities, the experience, as required of an AWS consultancy partner to comprehend our customers' business requirements. We love to co-create with our customers in terms of that, working with them alongside to really find what it is that they can bring out the best. Think about it as, have you thought of, have you considered, what is the art of possible, and really help them deploy this, very, very simply and efficiently. And our areas of expertise are both cloud and embedded, which puts us in a very, very unique category of partners to be able to understand everything from the firmware and up to the cloud. But at the end of the day, we are working with our clients and other partners as well to design market-ready products and solutions.
So you are actually, as a ClickerTech as a company, you are actually advanced consulting partner with AWS.
Yes,
right?
yes. And as you know, right, there's a lot of requirements and certifications and customer case studies that you have to demonstrate as far as evidence of validation to really earn that. So it's a program that we really like, and I think that our end customers really appreciate the program because they know when they're looking at partners, they do have the chops to be able to do this work.
So that's actually quite good. So, you work with customers, you work with a lot of AWS customers, we know that. So what are some of the challenges do you actually see customer experience building connected products?
Yeah, so one of the biggest things that we actually do see is how to actually, when customers embark on this, how do they actually build and deploy edge devices that can operate reliably connected to the AWS, core cloud. And what we'll see many times is we have worked with customers who have created embedded products before. They know how to build those.
Yeah.
Now we're talking about this whole new thing about getting it securely connected to a myriad of different network topologies and protocols.
Yeah.
As well as all the other elements, back end, front end, et cetera, et cetera. So it is very, very difficult to make sure that when you build this, you can actually deploy it and maintain constant connections. And customers really struggle because this is very much out of their expertise. Right?
Yeah.
The other thing too with IoT, and I always kind of use the expression, is that in IoT, there is no Angry Birds application. And what I mean by that is there's no big lump. IoT is a long tail sort of a thing. And the thing is that with that, the challenges that rise is like, if we were to talk to people here on the floor, which hardware, which operating system are you using? Well, I may have Intel architecture, I may have ARM, I may have, so there's all these choices and all these protocols and stuff. So to get like IoT devices connected, there's a lot of effort that goes into that edge to really make that happen, right?
Yeah.
And it's not like, I just pick one thing, Ethernet, it's a standard and it works, because it's not like that.
Yeah, exactly.
When we look at the cost of development, cost of software development costs going over and over again, whereas historically customers may only have worked on a non-connected product, embedded based. Now they have all this other stuff they have to do, securely connect to the cloud, make sure everything's working. There's a lot more testing. So the software development, the software test, and making sure these things operate in all these environments makes it extremely more challenging, but also more costly. So we got to look at ways to help customers kind of reduce some of the cost of development. And then, of course, post-maintenance, we all know that with connected products, as we create new solutions, as we create new customer experiences, features, et cetera, we do want to push those out to the field and onto those devices to give the customers a new experience. So now we have more maintenance costs post-deployment. So these are some of the things that we're working with our customers to not only educate them about if you're building a connected product, the things they need to consider. And then as part of that, what are some of the tools that AWS provides, like Device Advisor, test framework, to really help with that.
Awesome. So basically, we know what AWS Device Advisor is, right? AWS IoT Device Advisor. You know that. For our viewers out there, our watchers out there, our audience out there, tell us a bit about AWS IoT Device Advisor.
Sure. So, like many of the services that AWS builds and provides, right, it is cloud-based, fully managed test framework, which is primarily used for basically helping in terms of verifying software development and deployment on IoT level devices, right? Is how do we make sure that when this device is done and the firmware is done, that it can connect, it can do the encryption, it can do the certificate management, all that stuff is done, which is actually, it's undifferentiated lifting, but it's actually hard if you've never done this before.
Yeah.
The beautiful thing about Device Advisor is AWS has provided a whole suite of pre-built tests.
Yeah.
You don't have to create these yourself. You don't have to go to a QA automation engineer and say, hey, I need you to create these tests, and you hope that they wrote them right. Device Advisor really provides these pre-built tests so you can validate these IoT devices, right? So you've got this reliable and this secure connectivity, with core before you deploy to device, before you deploy to production.
Right.
Device developers can test and validate any device built to connect on AWS. As we spoke earlier, right, within the Internet of Things, there is no one process or one operating system. So with all the permutations out there, it is amazing that there's this tool that really doesn't care about your hardware. It really doesn't care about your operating system. It has the pre-built test to help you kind of get your stuff done.
Right.
And again, it's the best practices, like we talked a little earlier, making sure your TLS 1.2 encryption is done right. As you're talking over MQTT, as you're doing your certificate management, these are some of the things that, again, if you're not comfortable with or haven't designed with before, this will give you the confidence that what you have created and built can be tested and you can validate. And what you've done is really, best in class.
Exactly.
It's
Exactly.
a huge time saver.
Exactly. So, I mean, we know, and for our audiences, again, purposes, that what are the general OS operating system requirement, hardware requirement when they're trying to use AWS IoT Device Advisor.
So, give you an example. So, we are here at the AWS booth here at the show. If you're here, I believe we're in Hall 4, booth 550.
Yeah.
I hope I got that right. Please stop by. But we do have a demonstration here at the booth.
Yeah.
And I think one of the best ways to describe this is, out here on the floor right now, we are showing 5 different hardware platforms and as many operating systems running. We have, for operating systems, we're running it on Linux, Ubuntu, Windows, FreeRTOS, and Raspbian, which is a operating system from Raspberry Pi.
Yeah.
From the hardware perspective, we got a very, very nice high-end Lenovo, I think it's the ThinkCenter gateway running Intel architecture.
Yeah.
We have a Raspberry Pi module. We have an ST Micro, MP1, and then a lower level microcontroller, Expressive ESP32. And again, it just covers the gamut of things. So depending upon what you're doing as a developer, the thing I like about what AWS does is it gives customer choices.
Yeah.
You don't force them to say, oh, you must change to this to use this. The way the framework is created, it supports any hardware and any operating system. And that is just a huge, huge advantage.
Exactly. So we give you the option of building blocks to basically use a variety of options. I mean, as you mentioned, rightfully so, whether it's your flavor of choice is Linux, FreeRTOS, Windows, or Raspbian, you can go ahead with it. Whether it's your hardware of choice is a microcontroller or hardware of choice is a Raspberry Pi, you can obviously go ahead and go for it. So now let's switch us again. Can you tell us a scenario on how AWS Device Advisor can help customer in real life diagnose device issues?
Sure. So that's a great thing. I mean, it really comes down to the use case with respect to it. So let's just say, and again, I'm not going to get into anything specific or any very specific customer sort of things, but let's say we built a connected product right? And we want to move the information over a communication link, store it in the back end, move the information, and display it on Grafana, right? We want to create a very nice dashboard. So we get everything up and done, we get our code all written, we turn it on, and we're trying to get the code, and we see the hardware is running, but we look at our dashboard, and we don't see anything up there. It's like, okay, what's between there? There's a lot of things, right? It's the firmware, right? It's the Wi-Fi, it's this, and this. And one of the things that how Device Advisor would help is start to help it in terms of debug that sort of stuff. So what you would do then is to start that debugging process is you would create your test suite from the AWS Device Advisor console. Set up what you're doing in your specific solution, and then look to see which are the pre-built cases that I may want to take a look at.
Right.
So in this case, we think it should be pushing information. We don't know if it is. We're not seeing it in displayed. So we might run like, okay, let's check the security policies, right? Security device policies. And this just makes sure best practices are followed. The device does what's not included in the wildcard statements, et cetera, et cetera. Okay, maybe that all looks good. Maybe we'll move to TLS Connect, right? It ensures that the device software meets all the requirements of TLS 1.2. And again, what's nice is, again, it's helping you verify that you're meeting the right standards without having to be an expert. The tool is undertaking a lot of that for you. So again, it helps with certificate, based mutual authentication. Again, these are all the things the tool does. And then maybe we go to MQTT publish, and there's a whole list of test cases. But again, for example, you can kind of see what the customer would do is they would fundamentally turn it on, get it set up, and then start to determine what tests that they may want to run, selecting by themselves which tests. Now, the beautiful thing about this as well is once the system runs and checks the hardware, it also creates error logs. So now the user can go in, click on the error logs, and do a real nice deep analysis in terms of what's provided. And again, I think it's beyond the scope of the conversation here to show you all of that information and hexadecimal information that would be in there. But at the end of the day, the built-in tool is in there to also say, okay, you ran these tests, these passed, these failed, this one failed, and here's the log. It's, again, really nice to help developers lower the cost in terms of writing code, but also debugging it.
So that's actually a great point here. I mean, you can basically take those test cases, and whether you're building an MVP or whether you're building a real world device, you got to basically bootstrap your developers to use these test cases, as you mentioned rightly so. You don't have to go out there and say, okay, you know what, I need to build these test cases to make sure I validate this is correct or not. You basically can use the device advisor and say, you know what, I got it connected, I want to basically validate it, and boom, you have a checklist to verify it's done. Right? So that's great.
And one of the things along with that is we all know that customers, and you mentioned this, right? They may start out with a POC, a proof of concept, and then they may go to an MVP, like a minimal viable product, and then they may go to pre-production. The fact that you have these pre-built tests already done, as you migrate the hardware, as you change the firmware and all the stuff that you're doing, you can actually still run that same suite of tests over and over again without having to rewrite all that stuff. And again, it's giving you confidence that the changes that you made and implemented are actually still very much in compliance. And again, you can focus on other things with your developers.
Awesome. So let's go with another question, right? I mean, we know the benefits of this using AWS IoT Device Advisor is pretty awesome. So, for the benefit of our viewers out there, how can they get started?
Yeah, so I mean, one thing, and maybe we can talk a little bit about, as we talk about, how to get started. I mean, we can kind of walk through that. One thing I was also going to say in terms of some of the other side benefits, as far as Device Advisor. I mean, really, at the end of the day, this is going to provide developers with these best practices for reliable connectivity using AWS IoT Core. It's just a few clicks. And really saving a lot of development time. I mean, again, it sounds somewhat, like, I'm not saying we're repeating ourselves, but I can't underscore the importance of having pre-built tests that can ensure this sort of compliance and the amount of time this saves. I mean, I know for us, ClickAttack, when we're working on customer problems and we have issues, we use these tools, and it saves immense time for our customers in terms of helping, in terms of diagnosing that. So, we talked about the detailed logs and all that stuff, enabling faster troubleshooting and all that. So these are all positive attributes, with respect to the service. So you did ask the question about how to get started, and again, I think AWS is best with with this sort of stuff, right? So basically you can test any devices we talked about. you can access the device advisor from the core console. So that's the simplest way is go to your AWS IoT console. You go to your device advisor, and then once you're ready, you configure your tests, you run it, you register your devices, et cetera, et cetera.
Right.
And then again, customers, like we said, can pick and choose based on what they're seeing, what tests that they want to run.
Right.
And it makes it very, very easy and seamless. Again, I don't have to write this. I don't have to create all this. It's all there for me. It's very menu driven. I can select, I can run, and very self-service.
That's great. So what are the costs? I mean, when we talked about our services and the developers are getting started to use this, let's surprise them.
Sure. Everybody likes something for free, right? Everybody loves something for free. So, and actually with Device Advisor, Core, there is no cost with respect to using the service. And again, I just think, AWS thinking about this, again, from a customer obsession perspective, right? How do we make customers more successful? Here's a service that they're offering to allow customers to really accelerate development, but also making sure that the customers use the more complicated services and features and functions appropriately and within guidelines and specs, right? So that they don't leave a security door open, they don't do a certificate problem or whatever else that will come back later on and cause additional problems.
Exactly. So I will take and proliferate exactly what you said. From AWS as a whole, we are focused on customer obsession, as you rightfully said, and we basically give building blocks for you to basically get started and go ahead and build the product which you want to go ahead and build it and get started with AWS IoT. So being free, giving you the capability to test it, verify it, and go to market. So we are coming towards the end of our session, and I would ask if you have any message to leave to our audiences out there, what would it be?
So I would say a couple different things. One is, again, the tool is here. If you're creating a connected product using AWS IoT Core as an example for secure and simple communication to the cloud, use this tool. I don't care how seasoned or how experienced you are. I think this tool, again, as the teams continue to evolve it, there'll be more capabilities, more functionality, more testing. I mean, it just gives you peace of mind. So I would say no matter what, and even like I said, with us, as we develop connected products for customers, we always use these tools. It just again, peace of mind. You sleep good knowing that full well that you didn't leave a security door open or anything else for our customers. But on the other hand, right, not everybody necessarily wants to go ahead and do this themselves, right? And again, while AWS provides through the console a very easy way to do it, set it up, not everybody wants to go ahead and you may be resource constrained, you may not have the confidence, or you're unsure about what this means. So that's where I think the AWS partner network and partners like ClickAttack can help, where if you do want to go ahead and get this up and you're unsure, you can certainly contact us. We're happy to consult with our customers, help them set the test cases up, put all that together, show you how to run it, show you how to debug, and then the next time, when they build something new, they have all the right test cases. They've seen how to do it. They've seen how to access the logs. They should be able to do it on their own. But again, as a full service partner, as AWS, we're happy to help the customers, that, quite frankly, are like, this is beyond us and we would like somebody else to do it for us.
That's great. So, I mean, if you are here in Embedded World, ClickAttack is right here with the booth. They're demoing their logistic and tracking demo. So with that, we are towards our end of time, and I'm going to say thank you very much for watching our session. Watch out for next session where I will actually have a functional safety discussion. And till then, go and grab some coffee.
So awesome.
Thank you.
Thank you for having me.
Thank you.
Thanks for having ClickAttack. Appreciate it. Thank you.
Hi, welcome back. I'm Syed Rehan, and I'm a senior developer advocate with AWS IoT Service Team. So this session of functional safety tips for developers. You may have seen some of my videos on our YouTube channel regarding functional safety. Today, I have an expert who's basically a managing director for a company. His name is Andrew. Andrew, what would you like to say about yourself?
Good afternoon. My name's Andrew Longhurst. I'm Managing Director for Wittgenstein High Integrity Systems. I've been with the company now for 22 years, and I've predominantly have a engineering safety background. Wittgenstein High Integrity Systems is predominantly known for SAFERTOS, which is a safety critical real-time operating system. It's available pre-certified for 26262 ASIL-D for automotive, IEC 61508 for industrial, and 62304 for medical devices. And we're also working towards DL178C DLA certification for aerospace applications. So it's widely used in safety critical applications. So
awesome. So, I mean, for our viewers out there, I mean, I know what functional safety is. You are obviously expert in functional safety. For viewers out there, do you want to give it a little bit of snippet on what is actually functional safety? We know safety, but what is functional safety in this instance?
Okay, for me, functional safety has two elements. One of them is the device acting as the device should act? So you have a context where a safety system works in. And within that context, when you give it a certain input, there's a certain output that has to happen within a time frame. And if that output doesn't happen, we have to inform either the application, if you're an operating system, or if you're an application, you have to place the system into a safe state to make certain it's sort of safe for the users who are using the vehicle or machinery if there's a fault with the machine itself. So that's one side of it. The other side is the compliance side. So earlier I mentioned the long list of standards, and each one of these standards has various activities you need to do to conform to certain activities which auditors are expecting to see. So before we start any safety critical development, we need a development plan. And the development plan will actually list all the activities you need to do. So requirements analysis, how do you do the architecture, how do you do the design, your coding standards, and all the configuration management and test description documents. It's all got to be planned meticulously in a planning document, usually a software development plan, to which you then take to a certification body.
Yeah.
And you usually get pre-agreement with your certification body that if you do all these activities, they go certify your product at the end. So it de-risks your whole development. And I really, really stress this. Get buy-in from the certification body as early as you can, because once they agree to it, all you have to do is follow the plan. So that's some of the development work. The other part of the development work is actually following the plan. And for that, obviously, you need engineers who are going to do the work to the plan, but you need really good quality people, you need really good SQA people. So at every gate, what you have to do, so you've got a gate going between requirements and design, your SQA people will come in, they will test to make certain that all the requirements will be done correctly, you follow the correct procedures, all the people have signed off the documents correctly, all the quality records are in place, etc., etc. So every step you build up this pattern that says, yes, here's my plan, and this independent person here has proved that I've followed the plan at each step.
Yeah.
So when you go to an auditor, not only do you have a very good QA record of every step and you've got a history of how it's all been done, your auditor is going to say, prove to me you've done what you said you're going to do, and it's finished, it's complete. So if you follow your development life cycle, you've got requirements tracing. So for every requirement we have, we trace through the system, through architecture, design, into the code, and we test each one. So for completeness, all we have to do is show our auditor that we have 100% requirements tracing, and we have 100% test coverage of our requirements. It proves we've done what we said we're going to do, and the fact we tested the requirements means it's complete as well. So
awesome.
It's really good.
That is great. That's great information. So safety now seems to be a standard for a huge number of applications, right? Why would you say this is the case?
It's an interesting evolution, I think. If you go back 20 years where safety was passive and through mechanical systems, so you'd have a valve, and you have a cable which you could pull to open the valve, but there'd be a big spring on the end. So if anything went wrong, that spring would snap shut the valve. So it's a passive system. It's all mechanical back. But as electronics has evolved and software has evolved, we moved away from mechanical passive systems into active electronic systems. So rather than having clunky mechanics in the spring, you may have a motor, and you may well have a set of control electronics to control the motor to open and shut the valve. So it makes it controllable, it makes it simple to use, it makes it nice and clean. And from that evolution, the second you start controlling motors and valves with electronics, you've got to put feedback loops in to improve the safety of the system as well. So not only are you opening and shutting the valve, you are you're putting your fallback system in to make sure the valve's acting as you expect it to and it's fulfilling the requirements of it. And one benefit of actually having an active safety system is you can test it. You go back to your passive system, it's on the spring, you hope the spring works and you hope it's not jammed as a fail system. But with an electronic safety system, you can do partial strokes and you can do fully strokes. And you can actually prove your safety system is still active and still capable of working without disrupting the oil flow through the pipe or the water flow, because you can do a partial stroke rather than a full shutdown. So it keeps the systems alive longer as well. I know it's just an evolution of what we do with electronics. If you look at cars these days, it's gone from very simple controlling the throttle with a cable to electronic throttles. Now it's a supercomputer that drives a car. There's so many complex systems that gets about. So it's just an evolution. Things are a lot more complex, and we've got the development processes and the strategies in place where we can put more complex safety systems involving radar systems, lidar systems, and vision systems. So we can do more complex things these days, and we can do make them safe as well.
That's great. That's great. I really love that. So, what market sectors are actually driving the growth in this safety system these days?
Okay, no one can ignore the automotive sector. Yeah. It's huge. I mean, there's more software in an automotive car now, executive car, than there is in fighter jets. It is absolutely huge what they do. Everything in my car is electronic. Everything can be controlled remotely from my phone. Everything's got motors in it to do the work. So there's a lot of safety systems in the car.
Yeah.
And some of the safety systems are systems you wouldn't initially think of one, like a digital cockpit.
Yeah.
You think, oh, it's just displaying some information. It's not really safety critical, but all your warning systems come from the digital cockpit. All your chimes come from the digital cockpit there. And any sort of evasive actions you have to take is coming from the digital cockpit. So even simple systems in the car where you think, oh, that would never be a problem. It's okay. Oh, caught by safety systems these days. Yeah. So cars are a really, really big device. But we're also seeing the next generation of aircraft coming up. Not so much the big wide-body jets, but your air taxis, your eVTOL aircraft. Yeah. They're very innovative. They're very clever. They're 100% software controlled. They tend to be 100% battery controlled as well. And there's a lot of software which is driving that, and obviously that's DL1 and HC we're working to, and that requires a lot of safety software as well. So it's a transport system which is really driving it. But in addition to that, robotics. Robotics, when I was taking my master's in robotics in the 90s, robotics was strapped to a wall behind a safety cage, and there was a big physical barrier between you and the robot because it was very dangerous. Yeah. Now, because of vision systems and radar systems and force feedback systems, you can interact with robots, and you've got medical robots as well doing surgery inside you, and even remote, medical surgeons remote, you can do it. So it's a lot more interaction with machines that's driving the whole software system forward. Really.
That's awesome. I mean, you mentioned in the past where we didn't have the feature set, the technology. There was a scary part. How would the machine will react, or robot will react, and could it become the life-threatening for the human? Now, the functional safety aspect of things, we are taking care of it with the sensors and actuators we have on the devices and stuff like that, telling us is that, okay, this could become a threatening situation for human. And that's where basically you're talking about, saying that now there's an intermingling of human on our daily lives.
That's it, yeah.
It's awesome. So you mentioned on our chat offline, there is a variation of FreeRTOS, FreeRTOS being open source. The variations, do you want to mention it to our listeners and viewers out there about the RTOS version we are referring to here?
Okay, so we offer SafeRTOS, our safety critical built-up operating system. But SafeRTOS is based on FreeRTOS, and FreeRTOS is one of the world's most popular embedded operating systems. It's high quality, it's available on an MRT license, and it's downloadable from www.freertos.org, and it's hugely popular. It's used absolutely everywhere. It supports a wide range of platforms. It's very easy to use. It's very well supported. Most partners, most silicon vendors have variants of their processors that work on FreeRTOS as well. And what we offer is a complementary product, and we offer a safety critical version of the FreeRTOS operating system. So what we did was we took the FreeRTOS operating system and we performed a hazard, a study where we find hazards with using the software within a safety critical environment. So what we're trying to do is identify areas of the software which we need to improve to comply with the automotive standards, the medical standards, and also the aerospace standards. And we do the HasOp to identify changes to generate safety requirements. So for instance, when we did our HasOp on FreeRTOS didn't support MPU. So as we're doing safety systems, we need to have an MPU because we need to provide isolation between code sections, and we need to provide stack protection when putting the MPU over a stack section as well. FreeRTOS has 5+ memory models. Lots of them involve dynamic memory allocation. For a safety system, we don't like dynamic memory allocation. We like it fixed, we like it sort of statically allocated. So SafeRTOS does none of the magic that FreeRTOS does. You have to pass in all the stack buffers, and you have to pass in all the any other buffers we need for our objects, so anything else we need. So it's statically allocated.
So I guess when you just mentioned the difference here, I think it was one of my next questions.
Yeah.
Differentiation between safety for RTOS and commercial RTOS, right? Which you already picked up and answered it.
Yeah.
Now let's switch up a gear. How do you demonstrate that safety RTOS, safe RTOS, I should say, complies to a safety design standard? For example, you mentioned Automotive for ISO 26262.
Yes, that's what I was saying earlier on that one. I think I may have already answered this one by mistake.
Yeah.
When you go to a safety critical development, you write your development plan, and in your development plan, you write down all the activities you're going to do, and then you get your certification body to actually go ahead and approve the plan. So all you have to do after that is follow the plan, and at every gate in your process, you have SQA coming to check that you've actually done the intentions you wanted to do.
Yeah.
So you follow what you said you were going to do.
Awesome.
Yes.
Awesome. So we know FreeRTOS exists. We know SafeRTOS exists. And we know developers are using in abundance using FreeRTOS.
Yeah.
When they're building safety critical application, right? And if they're trying to migrate from FreeRTOS to SafeRTOS, right? When would they should carry out this step? What should be the pathway they should take, and at what stage they should do this?
Okay, so I recommend anyone who's prototyping their software or prototyping the system to download FreeRTOS on the development board you require it to be, and become familiar with FreeRTOS and start prototyping the system. Then what we find is that at a certain stage within the project where you've done your prototyping, you de-risk the system, you're happy with the concepts, you can go to your boss and you can say, look guys, I've got a system I'm happy with. Now we need to start formal development. So we've got to start thinking about writing our development plan to do the safety. We've got to start thinking how we formalize the requirements and everything else. And at that point, you should come contact us. You can contact us with www.highintegritysystems.com. And on our website, you can make an inquiry and we can provide you with a 30-day free SafeRTOS evaluation license. So you can see the SafeRTOS source code and how SafeRTOS works. We provide a really good demonstration application, and it's very easy to sort of understand SafeRTOS if you come from a FreeRTOS background, because we share the same development life cycle itself.
Awesome.
So yeah, just as you're starting your formal development plan, you should come to us, contact us at www.highintegritysystems.com and talk about upgrading to SafeRTOS.
Awesome. So we have somebody basically starting off, building a POC, proof of concept.
Yeah.
They developed an MVP. Now, once they have done the MVP, are you suggesting that before they go to market, get in touch with you guys, and then have the plan set out that where they're going to do the migration?
Yeah. Probably quite a long time before we go to market to come to, because if you're doing a safety product compared to a normal commercial product, you've got to think it's going to be 4 or 5 times longer and probably 10 times the work. You've got to define all the requirements. So just at the stage where you've done your prototyping and then you've got to start your formal safety verification, that's the time you should come to us.
Okay. So before you do MVP.
Yeah.
Okay.
Yeah.
Awesome. So we talked about a variety of things here from a functional safety perspective. We know you can't have a safe system without security, right? Security is living, breathing. We got to do that because it's a connected product, right? So how do you actually combine safety and security into an RTOS?
Okay, that's quite a big question. Safety and security are very similar, but then completely different, all at the same time.
Yeah.
So I talked about a safety system earlier, where we do a HasOp on a known context, and we make certain everything works within this context. And if it doesn't work in that context, we tell the system to go into a safe state. Whereas when you do a threat analysis, a TARA, to find security weaknesses, you don't have a known context, because a bad actor we try to stretch your context in all sorts of ways to make the system misbehave. And it's really difficult as a designer. You've got to think really creatively on how a bad actor can make the system think, oh, it's this or it's that, and impacts of one, or you can put input in here just to understand it. But from that exercise, you can create a set of safety security requirements. Okay, and if you've already got a safety system and you've already done your safety requirement analysis and you've built a safety product like SafeRTOS, once you've got the security requirements, it's just a case of superimposing the requirements on top of what you already have already. So it's the same development life cycle. You manage the requirements the same, you have the safety review the same, you have the SQA the same. On the verification side, you have to do a lot more fuzz testing because you want to have random inputs going into the device to make certain you haven't forgotten something, and doing fuzz testing is a good way of sort of coming up with random data. And you have to do a lot more pen testing as well, just to make certain you've protected the system. So, as I say, in some ways it's the same as safety because it's the way it's developed in the formal sense of the way it's the same. But you've got to think really, really creatively when you're coming up with your security requirements because none of it's constant. The hardest thing with combining safety and security is the business model. Because with safety systems, you tend to do once, and no one ever touches the safety system if they have to. Once it's worked and you've got 5 years experience, 10 years experience, you really don't want to touch it. But the second you start splicing security on it, and you might be doing an update and maybe a weakness on it, and something may need fixing and patching, you then may be having 1 or 2 updates every year. And that's a lot more work for us RTOS providers or the developers we're working with. So the business model is more of a struggle than actually the technical solution, I think.
Awesome. So, I mean, safety, functional safety, and security goes hand in hand when you basically have consumer products, right? So, I guess one of the questions I would ask is that name some few auditing bodies when they basically comes to safety standards, which you basically notably work with, whether it's in UK or whether it's in Europe or in across the globe.
Okay, we work with one certification body, which is TDV Cert. It's based in Munich, Germany, and all our products go through certification for them. But of course, we sell a certified product, well, a safety product to lots of different customers.
Right.
And not all of them customers use TV Cert. They could use FAA, they can be a medical product, FDA. There's lots and lots of certification bodies, which our customers work. But it doesn't cause us too much of a problem because we have a design assurance pack that comes to SafeRTOS. And the design assurance pack contains every single design artifact we generate during the development of a specific SafeRTOS. So all the requirement documents, design documents, architecture documents, test documents, all the planning documents, configuration plans. So we are completely transparent with our customer. So the DAP contains every piece of information, and our customers can be completely independent to us, totally. So if they were to use a different certification body, their auditors will first want to review our safety manual, and in our safety manual, there's 2 tables. One for integration checklist and one for installation checklist. And providing that a competent person has completed both checklists, it's been reviewed independently by a competent person, the auditor should be okay. But sometimes auditors want to go for the design assurance pack as well. But all the evidence is there. It's completely crystal clear, really easy to follow. And that allows our customers to work with whatever certification body our customers want to.
Okay. So you are basically providing the services across the globe. It doesn't have to be just in Europe.
Oh no, we wake up, we're based in the UK in Bristol. We wake up dealing with the Far East, our Asian customers, and at the end of the day, we end up talking to the people in San Francisco.
Do you actually often find a lot of these bodies which are basically doing these function safety tests and auditing? Do you find a lot of overlap in terms of standard, or do you find that, okay, there are certain criteria based in the Asia region or Middle East region or Europe region or US region is specific to that, or you always find an overlap?
Okay, it's slightly different to that. The way it works for us is we have automotive, medical, and industrial, which we work to one internal quality system. I mean, we produce a DAP for these markets. We tailor the DAP to work for the certain sectors, but internally we work to one quality system. For aerospace, it's a completely different ballgame. It's a completely different development life cycle. There's a lot more involvement. There's a lot more interaction with the customers, and it's generally a lot more information we need to produce. But again, it's in an aircraft. You're flying at 30,000 feet. You need to be safe.
Exactly. So, great discussion, Andrew.
Okay.
And thank you very much for joining us today. So, viewers out there, thank you for joining us. Watch out. We have one more session coming up before end of the day. And till then, goodbye. Go and grab a coffee.
So hi everybody, welcome back to the Embedded World live stream. I'm here joined by Joe and Thomas, and today we again going to talk about building the AWS IoT ExpressLink demo bench part 2, and this time we'll cover like system planning, design, and manufacturing part of it. So before we jump into, maybe you guys can introduce yourselves.
Sure. My name is Joseph Julisher, and I'm a senior software development engineer on the ExpressLink project. I also work with the FreeRTOS.
Yes.
My name is Thomas. I'm a senior IoT solution specialist architect. I'm mostly working on enabling our customers actually using our IoT products.
Excellent. So, I mean, before we jump in, maybe one of you can just recap like what we covered in the previous section.
Yeah, sure. So yesterday in part 1 of this conversation, we talked about the need for such a device or for such a demo badge, and that we actually launched the product last year, right? So we needed some way of telling our customers why should they use it, how can they use it, to spread the word, spread the message, and also to educate our partners as well as our customers on how easy it is to get IoT devices connected.
Excellent. Yeah.
And as an embedded device, this is designed for an embedded situation. Having something that you can hold and wear is much better than just a cloud system.
Yes.
It's hard to blink LEDs in the cloud.
I was lucky enough that Thomas gave me one, and I was like going around and wearing it. Everybody, what is this blinking? What is this? I was like, yeah. You cannot buy it yet, but they'll probably be in stocks at some point. Maybe we can start with this, when will they be in stock? And if you know, or
so the demo badge itself is built for our trainings and for our workshops. So we built it initially for reInvent last year. So we built a couple of hundred of those devices and gave them to our participants in Las Vegas at reInvent to really run the first couple of workshops with them. And now, kind of as the year moves on, we have more and more of those events. More and more customers actually learn through other channels, through other media, like the stream, about the capabilities of ExpressLink, and they keep asking us, like, can we get our hands on a device? Can we learn more about those capabilities? So now we're trying to figure out how do we make the best use of the devices that we have, and also, of course, plan for the next gen, for the next revision, to make it even more fun.
Excellent.
So getting an ExpressLink to try out, sadly, you can't do it through the badge. Instead, here's 2 example development kits that are available through DigiKey, Mouser, other distributors. This one is a development kit for Espressive, and this is a new development kit from Realtek. So these are available today, and you can just kick the tires on an ExpressLink using many of the same capabilities that the class teaches.
Excellent. So was this included in the design process when you were designing this? Like, is this something that you started with and then came to kind of like this thing?
Yeah, so as every good design project starts, right, you make a choice on your microcontrollers and on your modules, on the chips that you want to use. That's why our partners, our ExpressLink partners, come in really handy, because all of them provide a dev kit, an evaluation kit, a development kit, such as these guys that you can plug into an Arduino Uno and can get started really easily and really quickly. So that's how you build kind of your prototype number 0, right?
Yeah.
It doesn't look like a product yet, doesn't behave like a product yet, but you can test out the capabilities, start your first couple of lines of codes, and then you actually start designing and building your actual prototype that we then kind of went into this form factor. So we came up with the idea of, okay, let's do like a badge system. You can clip in a lanyard. You might have a display in your corner, have a microcontroller in a different corner. On the back side, you might want to plug in a battery because it's a badge. You want to wear it so it's operated. And with that first prototype, or the prototype 0, as we call it nowadays, actually, we learned that the display orientation down here matters quite a lot. So as you can see, there is a small form factor for the display, a little bit above that, but for some odd reason, it points downwards. So mirroring the footprints on your PCB design and getting the left to right, up and down orientation correct is also quite important. That you learn during building your first prototype.
Yeah, I was actually about to ask, like, were there any mistakes? Or,
Always.
but
there's things that you try to think of every possible scenario, but you're not going to get that first version right. So we built a kick the tires, a fast fail with this, and said, oh, this is going to work out all right. And we went straight to this. And we thought we were going to use this larger battery. We placed it here because we had the idea that it would sit at a viewable angle on the desk, and I could see the display.
You could see the board that was used as well.
Exactly. So everything looked like this was a good idea. But as we started going through the process, it didn't look right. And of course, we made a number of physical mistakes, but those are correctable. And then we went to more of this shape. And this is a much more attractive shape, and it made our marketing people much happier. So so it's just the normal evolution of the project is as unanticipated appearances come out.
How many people were involved in this project? Just two you guys, or were there any other engineers?
There were two of us involved with the board design and
Mhm.
board layout, but we were soliciting feedback from the marketing team and other people that had a vested interest in this product working very well.
So the demo batch was always designed to be the device together with the workshop, with our training
Yeah, makes
material,
sense.
right?
Yeah.
So for the building the device, it was pretty much the two of us, at least on the hands-on aspect, and then of course fanning that out to get the distribution, the manufacturing all sorted out. And then actually building the workshop, that's where we really branch out into the larger AWS community, solution architects, other folks, to build modules, to build training material, to make use of the device that we have built here.
So initially, we only built 5 of these. In fact, when the 5 arrived at my shop, we only made this one. I mean, we had a few of this done, but when we saw this mistake was big and there's a few other mistakes on the back, there's not a lot of value in going much further. But there was value here to do the initial code. So Thomas was able to get started right away with this, getting the initial code load. But when we got to this level, this still has some issues, and it wasn't the final version, but we made more of these so we could start getting more people involved because this looked more like the product. They could start getting a better feel for how this class was going to work.
Yeah, so this is, what is it? This is 0?
That was 0.
And then this is like
And
a
that's 1.
second or first iteration. And then, is this the final one, or?
This is actually the final device, yes. So we only needed 2 prototypes,
That's
and
excellent.
then we went straight into mass production. So we sourced parts and components to manufacture over 400, I believe.
400 now.
And got them all shipped and ready, assembled just in time for reInvent last year.
I hand carried all 400 to reInvent.
That's called, I think, just-in-time delivery.
Just-in-time
delivery, nice.
Exactly, because they had to be. We were working with the manufacturing. In fact, we had a primary manufacturer and a backup manufacturer. So parts were arriving to my shop from 2 different batches. And then it turned out that some of these displays on half of them were not stuck down. So I had my crack rework team, 2 of my children, and we were up all night making sure they were all stuck down and the initial code load was applied and everything was ready to be packed in the truck and driven up to reInvent.
I mean, I'm curious, like, it's when it comes to this design process and manufacturing for like quantity of like 100, 400, thousands, 10,000s, like what is, I mean, I don't think this is scalable to have your children.
No, it's really not. And so we tried to have a contract manufacturer do both. I mean, the first one, I did all the assembly in the shop, and that's okay for a couple. And it's all you got to do.
Yeah.
But really, it's hundreds. And so now little things become big problems. Like all we had to do is apply some tape behind the display and stick it down. But then doing one is no big deal, but doing hundreds so they look the same and they look good and they're not too tight. And, these issues become repeatability issues and it becomes a big problem. Many of them I had to actually give myself a little bit more slack by unsoldering and resoldering the connector on the back. And these are the kinds of things you run into when you go beyond a few to many.
So the other aspect to that mass production aspect is, well, the device itself is one aspect, right? Most of those components that we have nowadays are surface mount. So they can easily be pick and placed with a machine. They can be soldered down automatically. But then there are always these one-off components, for example, that we have on our production versions, like a battery socket here. That one is a through-hole component.
Yes.
That might not be available on every pick-and-place machine. So that might be a human operation, actually. And doing that 400 times, okay, might be expensive, but doing that 10,000 times, you really don't want to do that.
So you have to design in that way that you have to think about the manufacturing process. Then.
Exactly.
And we had to go through some of these components and provide alternate layouts. The ambient light sensor is just a photo transistor, but we were seeing that maybe the volumes on one particular part was not available. So we actually have a more complicated footprint. In fact, these 2 boards are supposedly the final production, but they have different sensors on them. But they're interchangeable. For the purposes of the class, we didn't have to calibrate to a particular light level. We just needed to see a change when you shaded it with your hand. And both of them, for the purposes of the class, were acceptable, and it worked out okay. But we had to plan ahead with a footprint that could hold either one, and we had to authorize our manufacturer to switch if they needed to.
That's pretty cool. And then, I mean, here, so I assume like this part is you can readily available. You can just get it as it is, so you didn't need to.
Yeah, so that's the other aspect, right? As Joe just mentioned, finding alternate components to do the same job for you. And that's one of the challenges that we saw over the last years, actually, with all the economic changes in recent years. Finding components, sourcing those components, and getting the delivery dates agreed on. That's a big challenge. So for some of those components, those are really bread and butter components, buttons, switches, like you can buy them in the millions, no problem. But if you go to a little bit more, let's say, specialized parts, like a microcontroller and a very specific selection and type and flash size, that's where you really need to figure out, okay, do you have 10 in stock or do you have 400 in stock? And we made the choice because we were short on time last year and reInvent was approaching. Okay, let's take an off-the-shelf module that bundles all of those components together. Microcontroller, flash, USB interface. So that really sped up our development process because we said, okay, we have one uniform footprint. There are 3 different manufacturers for that type of model. We can buy from any of them. And then we just saw, okay, we can get 200 from you, 200 from you, and can also hedge our bet basically on where to source those parts while still keeping them compatible and interchangeable between each other.
But then if going into like thousands and whatever not, then it makes sense to have that separate.
Well, if we went into more than say 500, we would not have used this module.
Yeah,
This was the most expensive component on the board, so it was an acceptable bet for the way we did it, for the numbers that we did. But going beyond that, we would start revisiting: can we put these components down on the primary board and save the money? And each of the alternates. This one, we were lucky; we were able to buy all of them with this particular brand of module. But had we needed to use the alternate, it would not have had a battery charger, for example. This one has room for a rechargeable battery, but we also planned for a non-rechargeable battery plugged into a different, this is a prototype that's kind of hacked in there. But this other connector is for a non-rechargeable battery. So we had different options depending on what went on.
And the special thing is every time you make components interchangeable, well, you still need to test and validate that they are still behaving in the same way.
And really interchangeable, right?
Exactly. Right. So at home, so of course these ones have the blue module, as we just call it. At home, I have like a complete color selection. The same demo badge with all sorts of different modules. And I run my tests on all of them. I make sure they have the same power consumption. They can source and sync the same type of current to really make sure that if you go into the mass production, thousands, millions of devices, you need to have your data sheets all aligned. You need to have your test procedure all aligned to not cause any problems further downstream.
This badge, this module is socketed, so we could try out everything. Now, this socket is very ugly and it's not the message, so we would not want to go to production with it. But it was a good choice for a prototype.
No, this is pretty cool. And then, when it comes to like the ExpressLink, did you have any problems like sourcing that, or like since it was released recently, right?
It was new for reInvent, and so there were potential troubles with it because while we do have 5 partners, each of the partners has a different availability, and 3 of them are Wi-Fi. So we ended up going with the Espressive module on this one because at that time it was the most available. But now there's lots more availability with the different options. So if we had to do it again, we'd have to go back and revisit that decision.
Yeah, that's interesting. And then, what about the software part of it? Like when you were going through this process, changing hardware through one from another. Was software also changing at that point?
Yeah, so that's the other aspect to the manufacturing of devices, right? It's not just soldering down your components. Maybe it's automated. Maybe it's a manual soldering process. You also need to flash your firmware and kind of your initial bootstrapping code to get those devices up and running and do what you want them to do. So as part of our manufacturing line, so to say, some of the boards were already flashed straight from the assembly house. Some of them came bare bones. There was no software on it. So we had to take it upon ourselves to flash that first firmware, download our files into it, and then as we continuously and in parallel develop the workshop content, also keep the update between the workshop content and the software on our badges. So going then to reInvent, the week before, 2 weeks before, or a month before, right? Of course, we finished early developing our workshop, of course. So we had to kind of keep those assets and those firmware versions in sync between the things that we described in the workshop and the things that were actually running already on 400 batches, packaged up, ready to ship, and then making a last-minute change would not have been feasible.
So part of that, while we were working through with the manufacturer, we had to do an initial load of production schematic production layout, but a short run of say 20 boards, badges to validate it, and then to see the people who are writing the code for the workshop. Because I kind of switched gears to babysitting the 400 build, but these guys couldn't just stop. They had to finish the final code on final hardware. We had to take press shots, put into the documentation. We have demos that we're showing here at Embedded World. They have 3D models. Those 3D models had to be correct.
No,
So we couldn't just wait till the very, very end and have the ones delivered at reInvent. They had to be ready earlier, but not all 400. So that's why some of these badges exist the way they do.
The other aspect to that is we just talked about parts, interchangeability, and manufacturing itself.
Right.
So how do you test the device?
Yes.
How can the assembly contractor already test them? So we built in a self-test procedure.
Right.
So what you can see on the screen, it's flashing by every couple of seconds. There is a screen that lists out every single component, every single sensor, and it performs a self-test check. Can it read the sensor temperature data? Can it read the buttons? And then it will tell me, okay, 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 fail. Oh, I know this one is not good. I need to take it outside, take another check. And if it passes our self-test, then it goes into the final flashing procedure, gets packaged up. We made a couple of nice carrier handles here to like really stack them and put them together, nicely locked and everything. So then we know, okay, this one is fully tested. We put it in the rack, set it aside, ready to use.
So you were able to deliver that self-test while the manufacturing process was taking part, so they can go through it.
I wrote a test procedure that took his self-test code, explained the display, the final steps, and I sent that to the contract manufacturer. Now, we still had to, when they all came in, we did a final test when we were doing the final code load. We had to do any changes. So I had racks of like a pipeline of operations. So one of my daughters would take the board and she'd put the code in and make sure it's the final version. and then the next person would check to make sure that all the items on the self-test screen passed. And anything that didn't pass went into my pile, and I had to go back to the lab and do rework.
So you had a production line at home?
Oh, completely had a production line. That was what we were doing the last 2 days before reInvent.
That is pretty cool. Okay. And yeah, I mean, for that quantity, yeah. So, but,
it was manageable with 400, but it was crazy for a while.
So that's the other component, right? Joe just mentioned sending those instructions to the contract manufacturer to do the self-test. Well, we spent weeks, months kind of developing that and knowing every single detail. Telling that to somebody else to run that test
in
procedure.
Asia on a different time zone.
Oh yeah. No, I feel your pain. In many situations, like having that documented in a way that somebody who is not from the same context can go through the list and make sure like everything is
And then when everything arrived, you find out how the test was really executed.
Yes.
And how it exactly matched, but was not quite. So something was lost in translation, so we still had to do some adjustments. It worked out in the end, but it was interesting.
This is excellent process. I think it's good to experience this because our customers will be doing the same, right?
Absolutely.
And, it's good to experience this and say, okay, where can we change things, or how can we make this easier for our customers so they can go through this process with less pain.
And that's one of the points also about the demo badge, right? Demonstrating how to build such a device. What we are doing right now, talking about it. We also open source the whole hardware design files. We publish the schematics, we publish the Gerber files. So you can actually go online onto GitHub, download the design and manufacturing files, and send it off to one of your contract manufacturers.
Even the testing procedures?
Everything is online, yes.
Excellent. This is pretty cool. Okay, awesome. I think we were over the running out of time. Anything else you guys wanted to add to this story? I really like the story of starting from like a prototype with this, and then having different iterations, and then coming to the conclusion. So that's awesome. I think will definitely benefit our viewers. Making this shorter time frame at least for them. Maybe with 2 iterations.
Well, maybe, or it could be more, but always you're going to have more than one iteration. So my advice is leave yourself enough time to spin the board a couple of times. There's going to be something that comes up. You're going to have that last minute critical component go obsolete. You're going to have to make an adjustment. It's just how it works.
And the other thing is also just have something in your hands, right? We thought this was a really great and amazing idea.
On the computer, on the screen.
And we sketched it out. We drew something on a napkin, like we're really proud of our design. And then we held it in hand and said, no. Actually, we could do better than that. So we went back to the drawing board and we completely redesigned it.
Excellent. This is great. Thanks a lot for coming over, showing your story, and sharing all the learnings with our viewers. So that's awesome. Yeah, that's it for the Building the Page Part 2. Hopefully tomorrow you'll have some opportunities to talk about different things. So yeah, thanks once again, and then bye until next session.
See you tomorrow.
See you guys.
Hi, thank you very much for joining us. So, in this session, I'm just going to basically recap what we have done today, and I want to basically talk about what is in store for you tomorrow. So, today is day two, and if you remember, we opened the session. I had Richard Berry with me, where we actually talked about day one sessions, how we basically go into details in terms of observability, developer experience, FreeRTOS, security sessions, and whatnot. So, in the same stream today, I'm just basically going to recap what we have done, giving you a little snippet what we actually talked about, who did we talked about, and basically what are the interesting things. If it interests you on the certain sections, you can go back and watch it in the live stream. Right. So first we started. The first session was around observability. Right. It was around DevAlert and Tracealyzer. It was with John Kraft and Mike from Percipio, where they went into the details how Percipio actually uses Tracealyzer, how it's actually working with the embedded devices, how you basically can use that to carry out observability in terms of logs, in terms of debug, in terms of monitoring. Following session we had was Amod, and joined by my colleague was Nenad, who was basically doing the session. It was effectively talking about open source software for connected vehicle. There they talked about SOAFEE, which is basically open source reference, and how did DXC technology implemented the reference for the connected vehicle. Following on, we actually had a free RTOS for industrial automation using OPC UA with Stefan Stronger and Adrian. My colleague Dan was the one who's hosting this session. This is where they went into details how basically BNR, industrial automation, which is part of ABB, actually utilizing free RTOS in an industrial automation environment. How they're basically using OPC UA in that environment. How they're basically collecting the data from that perspective and sending the data across to the cloud and utilizing the data and removing the noisy data parts. Then we had a session with Elim and David Walters. My colleague Alina was the host of the session. This is the session where we talked about embedded device CI/CD with virtual hardware and device advisor. This was with ARM engineer. This is where they went into details talking about how basically you can have CI/CD pipeline for embedded devices, how they basically use virtual hardware. I mean, let's face it, right? You could basically get it quickly bootstrapped by using virtual hardware of ARM and get cracking and start building and start testing your embedded environment rather than having a physical hardware, MCU and whatnot. So worth watching that session. Then we had embedded runtime security session, continuous monitoring, threat detection with Sternum, FreeRTOS-based evaluation kit. We had guest CTO was Liam. This is where we went into details in terms of how you basically can use the continuous monitoring and threat detection by utilizing the Sternum FreeRTOS-based evaluation kit and running this in a embedded runtime security environment. Following that, we had a session with Eurotech, Reliagate, IoT Gateway, integration with AWS IoT Greengrass with zero trust provisioning. This is where we had Marco who's the CTO of Eurotech. We talked about how you can basically use AWS IoT Gateway integration in conjunction with AWS IoT Greengrass and have a zero touch provisioning in that session. So well worth watching that session if you're basically interested on zero touch provisioning, you're interested in gateway integration, and if you're interested in AWS IoT Greengrass. Then we had a session of cloud native car with SOAFEE and Linaro. Here, my colleague Dan hosted this session where we had Andrea and Grant, who was CTO of Linaro, where they talked about how Linaro actually done the implementation of SOAFEE, how they're basically leveraging this, and how you basically can utilize this. Well worth watching the session if you are interested in SOAFEE and how you basically can read and understand and implement a real life implementation of SOAFEE out in the world. Then we had how to build an automotive grade Linux for AWS, where we had Walt, and then we had Jan from AGL Release Manager. This session was hosted by my colleague Nenad. This is where they went full geek on automotive grade Linux, for AWS, and they went into details to talk about how basically you can use AGL, short form for Automotive Grade Linux, in conjunction with AWS. Then it was a session where we talked about AWS IoT Device Advisor test framework for IoT solutions. I was joined by Joseph, who is the head of business development. We had a cracking discussion. I was the host for the session where we went into details how you can basically use Device Advisor. And just to give you a snippet of it, Device Advisor is a free service for you to use. You can basically use to test your environment. You can test the setup. You can test the security of it. You can test the MQTT of it. So it gives you the complete pre-test environment for you to go ahead and test it and verify it. So it will bootstrap it for you. So that was a great session. Following that session, I had a discussion with Andrew Longhurst, who is a managing director for Wittgenstein, and this was functional safety tips for developers. We know how important safety and security is, right? But when it has an electronic component or electronics or consumer application which are being used in an electronic component or electronic appliance, which has human interaction, this is where functional safety comes into play. And functional safety effectively means is that what will be the reaction of the device if there's been a failure to avoid any cascading impact on a human life. So effectively what we are saying is that if a machine or an electronic device or a component has a human interaction, then we need to make sure functional safety is a primary, because we need to, the risk of the device going wrong is huge. And the cascading impact of the device going wrong could cause a human life tragedy. For example, you have autonomous cruise, right, which is in a car, connected car. If the component fails, we need to make sure that it comes to safety without causing a human life error. And this is where we need to make sure functional safety ISO 26262 is taken into account, right? Now, in this discussion where I had discussion with Andrew from Wittgenstein, where we talked about FreeRTOS, migration path from FreeRTOS to SafeRTOS, where they basically encapsulate all the safety of it. They work with a lot of organizations across the globe in terms of meeting the criteria for functional safety. And then last but not least, the final session we had was just finished, which was with Joe and Thomas. This was a part 2 of the session where we talked about building AWS IoT ExpressLink demo badge. So that was the sessions, or these were the sessions for today. Now let me switch up a gear and move into tomorrow. Tomorrow is the last day for Embedded World. Sad to see you guys, we leaving you guys tomorrow. I really enjoyed this live stream, speaking to a lot of guests, having you guys watch us and entertain and pass our knowledge on to you. So tomorrow, we will start same time as tomorrow. First, we will have recap what we actually have done. My colleague Alina will basically run the session there. Immediately after that, we will have device reliability engineering with remote debugging and monitoring at a scale with Tyler Hoffman, who's from Memfault. We will go a deep dive into how basically you can increase reliability of your devices and engineer it by doing remote debugging and monitoring at the vast scale. Then after that, we're going to have a session. I'm going to be the host on that one, where I'm going to discuss with Christopher Siedel, who's the director of product management in ARM, where we talk about what's new with ARM and Keel developer tools. I'm intending to basically go deep dive into details where I want to talk about ARM virtual device, how we basically can use that. We talk about Keel developer tools, how I can actually use the developer tools, how I can get started. So watch out for the session. I intend to basically go into details because Keel is actually new to me as well. And I want to learn all the basics and everything I can basically learn and pass it on to you guys to make sure we can get started quickly and be aware of it, exactly what we're getting into. Then we have a session, how to build awesome AWS IoT ExpressLink product with Telet Centurion. We're going to have Martin Torcato, who's the head of software product management at Telet, and they're going to be joined by Carmelo D'Agostino, who's a product manager in again Tilic. They're going to talk about how they actually have built ExpressLink board similar to our other silicon vendors, and how is it any different, what sensors they have it in place, and how you can basically get started by using the board. Then we have a session, FreeRTOS and Open Hardware Core V MCU Dev Kit. This is the session where we are joined by Rick O'Connor, who's the president and CEO of Open Hardware Group. We're going to talk about how FreeRTOS augmenting Open Hardware Core, how you basically can utilize the MCU Dev Kit, and how you can get started. Then I have a session with Parag, where I'm going to basically talk about smart camera software frameworks. I want to go deep dive into details, how we basically can use the smart camera software framework provided by ARM, how I can basically augment this into AWS, how I can basically use it, how we basically can utilize it to make sure you, IoT builders out there, can learn and understand how to basically use this product and connect it to the cloud of AWS IoT. Then we have open source and IoT and edge. Oh my, this is a session where we have Frederick, who is an evangelist at Eclipse Foundation. He's going to basically give you all the lowdown in terms of open source, IoT, and edge. Then we're going to have a session with Anton, who's basically going to talk about connected product with STM32 microcontrollers, augmenting that with AWS IoT ExpressLink. So watch out for that. He'll be joined by Slim, who's from STM Microelectronics as well, who will basically be able to answer your questions if you have any. Finally, we're going to close off the stream, the last session of the day, which will be, as you have seen, what we have been doing. We had AWS IoT badge using AWS IoT ExpressLink with Joe and Thomas. Similarly, tomorrow will be the last session, which will be the part 3, and giving you a chance to basically complete the whole series. And after that, it will be the time to say goodbye to you. Until next year. And with that, this session concludes. We're going to be closing the stream for the day. If you have any questions, do reach out to us in the comments and hit up to us, and obviously we will try to answer it back to you. And make sure you subscribe, and make sure you basically watch out for the sessions coming tomorrow. With that, I want to say bye. Have a great day. See you guys tomorrow.